shear force. What is mean by shear force, guys? Shear force is a one where force is acting parallel to the surface, or the shear force will try to split the and bending moment. In today's session of strength of material, we are going to talk about shear force and bending moment, and we will learn how shear force and bending moment helps to design a beam. But hey, what is mean by beam then? Don't worry, guys, we're going to talk about the beam a bit later. Okay, for time's sake, please look at here, guys. These are the basic things I am going to cover in this particular chapter, shear force and bending moment. I want to tell you one more thing, guys. This is the important chapter, important concept, the entire strength of material I am telling you. Why? Because this is the fundamental, this is the foundation to find out the bending stress, shear stress, even for the complex stresses actually, guys. So you should be very confident in this particular chapter actually. Okay, don't worry, just follow these videos, follow this lecture. I will make you confident. That's why I logically made the contents to give you the more confidence in this particular chapter, guys. First, we will cover with what is mean by shear force and what is mean by bending moment. And we start with different types of beams and what are the loading conditions in the beam and different support conditions. This we are going to discuss about it. And then what is the concept of shear force and bending moment in designing the beam? Are you getting or not, sir? So what is the role of shear force and bending moment to design a beam? This we are going to discuss here. And after that, we'll talk about the relationship between load, shear force and bending moment. And finally, I will give you the procedure to draw shear force and bending moment diagram. And then we'll discuss a lot of standard cases with the different types of loading conditions. And we will discuss about simply supported beam, cantilever beam, overhang beam, and beams with internal hinges. These things we will discuss, guys. And most important one is point of contraflexure and its significance. And finally, guys, the summary of all these 7 points I can write. The summary of all these 7 points, it will help you in the last minute revision actually, I am telling you, guys. If you just understand these 7 topics once, from next time onwards, you no need to refer these 7 topics, just go to the summary. This will be clear for you, guys. The summary is maximum 10 to 15 minutes, not more than that. Okay, I will cover each and everything. Now, we kick off the session with what is meant by shear force. What is meant by shear force? To understand this shear force in a clear manner, guys, first we have to understand what is meant by normal force, guys. I think or not, sir? What is meant by normal force? Tell me, guys. Normal force means this is the force acting normal direction to the surface. Force acting normal direction to the surface actually, guys. Are you getting or not, sir? Exactly. If you take this axis height, exactly normal. This is the normal force. What is the nature of this normal force, guys? This normal force especially, guys, it try to lengthen, it try to increase the length of this object. It tries to increase the length of this object. That's why this force I am calling as a tensile force. Tensile force. Are you getting or not, sir? Now, similarly, I am having another normal force, but this force will try to compress the object. Are you getting or not, sir? As it try to compress the object, this I am calling as a compressive force I can write. This is the nature of the force. Are you getting or not, sir? Here I can write simply the force acts normal to the surface is called a normal force. What is meant by shear force now, guys? Please tell me. Shear force means I can write shear force means here force acts parallel to the surface. Only difference is it is normal to the surface. This is the parallel to the surface. Assume I have an object, guys. Assume I'm acting one force over here. One force over here and another force over here. Are you getting or not, sir? One force, another force. Earlier normal means acting normal direction I can write. Acting normal direction. Shear means acting parallel to the surface. It is acting parallel to the surface actually, guys. Suppose if these forces are not try to rotate, assume these things are not rotating, then what is going to happen? This force will try to split. This force will try to split the object, or I can write shear the object. When, guys, if this applied force give you the stress, if that stress is more than the allowable stress of this material, it will shear the object. Assume for time's sake, guys, I am having some object here. Now I am applying one force upward, one force downward. When I apply one force upward, one force downward, suppose if this force is more than its allowable value, it will shear. It will shear up and down. So I can say that shear force is the one which tries to split the object, split or shear the object. Are you getting or not, sir? It tries to split or shear the object. But here, guys, I'm asking you one question. Please tell me in your day-to-day life where you are using the shear force in your day-to-day life, guys. Please think about it. One easiest way, this is what we do in our day-to-day life also, guys. Cutting the loaf of your bread. When you're cutting the bread, you apply what type of force, guys? See, the force at the knife is acting what? Parallel to the cross section of the loaf of your bread actually, guys. Bread loaf. Are you getting it, sir? That is the reason I can able to cut in the parallel direction. The force is acting parallel, I can able to slice the bread. This is what is the force you are acting here? Shear force only. And another one, you are brushing your teeth. When you are brushing your teeth actually, guys, what is the force acting on your teeth? It is a force acting parallel to the surface. You are just acting parallel force. This is also kind of shear force only. And this one, guys, you are sharpening a pencil. Tell me, is a shear force or not? Yes, it is a shearing the, like I can write pencil fibers I can able to say. This is a kind of one of the practical example of shear force. Next one, you are applying a tilak on the forehead. How do you apply? You apply like this. You are applying what force, guys? Force acts parallel to the surface. It is also example of shear force only. And this is what we do every day. Again, sir. So washing your hands. While you are washing your hands, actually, guys, you apply normal force or shear force, guys. How do you wash? It's after all, it's a shear force itself automatically. So this is another beautiful example. Please think like this. Please think like this, guys. Is there any other kind of activities you are doing where you are applying the shear force? This one, as an artist, he is doing a painting actually, guys. While he is doing a painting, what he applies, guys, with the help of brush, he applies shear force only. This is not normal force, guys. It is a shear force. And what else? This generation kids, including you and including me, everyone, it is a day-to-day activity. If you take a screen, what you apply every time, guys, to move the screens, what you apply, guys? You apply simple shear force on the object, on the screen itself, I can say. Are you getting an answer? These many things. And you are doing so many things. You are washing, you are bathing, everywhere you apply shear force only. And more important one, guys, when you are counting a currency notes, how do you count? What type of force you apply for counting the currency notes, guys? These currency notes will be acting a shear force. I can write like this. Are you getting an answer? Unknowingly, you are using shear force in our day-to-day life. I can write actually, guys. I can say. Shear force. What is mean by shear force, guys? Shear force is a one where force is acting parallel to the surface, or the shear force will try to split the object. I can write. Now, coming to the bending moment. Coming to the bending moment, actually, guys. To understand the bending moment, first we have to understand what is mean by moment. What is mean by moment? If somebody asks you moment, moment means it is a moment of force, guys. It gives the turning effect of your force. Turning effect of your force is called moment of force. Are you getting an answer? If somebody asks you what is mean by moment, you have to say it is the turning effect of a force. Now look at here, guys. I'm applying force F at this location. Because of this F, I can easily able to turn this object. I can write. Are you getting an answer? Because F into D will try to turn the object. But as the distance increases automatically, you can turn it very, very easily. This nut can be rotated very, very easily. Are you getting an answer? So I can write the moment of a force equal to the applied force multiplied by perpendicular distance between the load point and pivot point. I can write. I can say, guys. Are you getting, sir? This is the moment of a force about any point. It is the perpendicular distance between 2 points actually. But I want bending moment. This is the moment actually, guys. I want bending moment. For this, please look here, guys. This moment will give you turning effect. Because of this turning effect, the object can rotate. What is the effect of this turning effect, guys? Because of this turning effect, the object can rotate. The object can twist. The object can bend. Are you getting an answer? Please look at here. I have the scale. Now, assume this is the pivot point. I am telling you, this is the pivot point. I am applying the force at this location. Because of the force, what happens exactly, guys? Now tell me, guys. Definitely moment will be there. Force into distance will be there. Because of this moment of your force, your object is, what is happening, sir? The object is rotating. Same turning effect giving the rotation. Now tell me, guys, suppose I am having something. Because of turn moment, I can say this object is twisting. I can write. Third one is same object. When a load is applied, turning moment, how much, guys? Force into distance. Because of this one, what is happening? The object is rotating, or the object is twisting, or the object is bending. The object is bending. Are you getting an answer? So now tell me guys, what is mean by bending moment? The bending moment is, it is the moment of force. It is the moment of force which tries to or tends to bend the object. Are you getting an answer? It is the moment of force which tends to bend the object is called turning effect. I can say it is the bending moment. Now we'll see what is meant by beam. The beam is a structural member which is designed to carry the transverse load. It is designed to carry the transverse load. I can write it is subjected to transverse load. Please look at here guys. Assume I am having some beam. Now the load is acting such a that exactly it is a transverse load, transverse to the cross section, or this is also called lateral load. The simple definition is the beams are subjected to lateral loads or flexural loads. Okay guys, now what are the typical beams you come across in our day-to-day life guys? If you go your home, you will definitely see the concrete beams. You might have seen the steel beams in the while constructing the bridges. You might have seen so many types of beams in your day-to-day life guys. I'm giving you some non-orthodox examples. Please look at here guys. Assume electrical pole or your mobile tower, whatever it may be guys, exactly. This tower is designed as a beam or designed as a column guys. It is designed as a beam. Why? Because exactly guys, your wind load is responsible to provide the lateral load on the entire pole. Are you getting an answer? So this electrical pole act as a beam. Another example guys, you might have seen the aeroplane. Assume what are these guys? Wings of an aeroplane. Okay, it is having engines over here. It is having engine over here actually guys, and it is having something like yeah, that is sufficient actually guys. Having landing gear and all these things are not required for us. Now tell me guys, to fly the aeroplane, what we required? We required first one is forward push. Forward push. Second one is lift. Are getting or not, guys? To lift the aircraft, to fly in an aircraft, we require two things. First one is forward push. Second one is lift. Now tell me, guys, who is responsible for the forward push in the entire airplane? Your engines. Engine is responsible to give the sufficient thrust to move the entire vehicle forward direction. But who gives the lift? Who gives the lift? The lift is given by the wings. Are you getting or not, sir? Suppose if your aeroplane having only engine, no wings, it can't fly. It just act like your car, act like your bus, whatever it may be. But it cannot able to fly. Your airplane is flying mainly because of the wings actually. How wings are responsible to fly the entire aeroplane? Because, guys, your wing is designed in such a way that the shape of an wing is such a way that it is having a aerofoil shape. What aerofoil shape will do, guys? It will create the pressure difference from top to bottom. Because of the pressure difference, it is giving the lift. It is giving the upward lift. I can say because of the aerodynamic action. Because of the aerodynamic action, your lateral load is acting on the wings. Because of that, your aeroplane flies. But this load I can call it as a lateral load. That is the reason your wings are designed as a beam. So I have to use all the concepts of shear force and bending moment to design beams. I want to tell you guys how this pressure difference is creating actually, guys. It is not creating artificially. They have designed the shape in such a way that are getting or not, sir? In such a way that it creates higher pressure at the bottom, lower pressure at the top. But you can ask the question, sir, your aeroplane is flying at the same location. At that location is pressure is same. Then how it is creating the difference of pressure? Sirji, your wing is not creating the difference of pressure. It is its shape is creating the differences of velocities of the wind. Please look at here, guys. Assume this is something like this. Suppose if I please look at here. If I blow the air with high velocity, if I blow the air with high velocity, what is happening, guys? It is just moving upward direction. Why? Because, guys, please tell me. Because earlier, because of weight of this paper, it is just moved down. Now I am moving the air with high velocity. If I flush the air with high velocity, it creates the low pressure at the top and high pressure at the bottom. Because of that reason, actually, guys, this paper will fly automatically. Same reason will be there, sir, here. For the wing also, guys, the shape is designed in such a way that it creates high velocity flow at the top and low velocity at the bottom actually. High velocity always, guys, high velocity leads to what, guys? Leads to what? Low pressure. Low pressure. That's why your aircraft will lift automatically, guys. Are you getting an answer? But this airplane wings act as a beam itself. So these are typical examples of the beams. Now, coming to, guys, typical materials of the beam you come across. Typical materials. Tell me the materials, guys, you have seen in your day-to-day life. First one, concrete. This is the first material coming to your mind when I say beam. Okay. Second thing, steel beams. You might have seen the steel bridges and all. Third one, tell me, guys, Have you seen any wooden beams? Yes. Where? If you go to any wooden huts in earlier days, guys, most of the houses are made with the huts only. They are made with the wooden beams itself actually. Next, fourth one. Have you seen plastic beams? Where you have seen the plastic beams, guys? Simple. You are sitting in the chair. The all four side of the chair like this, guys, assume. These are the legs. The legs actually, guys. If you are sitting here, these four sides of a chair act as a beam, because when you are sitting on the chair, you are acting the lateral load on this one automatically. Plastic, glass, all these typical materials, guys. You can make any material as a beam, depends upon your requirement. I can write. Are you getting an answer? Exactly. So we're done with the materials. Now, typical cross section of the beams, I can write typical cross section. Tell me, guys, what are the cross sections you have encountered in your day-to-day life? Tell me, anyone? First one you might have seen. Rectangular cross section. Rectangular cross section. And you might have seen circular cross section and I cross section, like I beams, I cross section, and you might have seen the channel cross section, and you might have seen like T cross section. These things are basic cross sections we used to see in our day-to-day life. But which one is the best out of all these cross sections? Can you able to say? The answer is no. Just buying these cross sections, I can't able to say which one is the best. Are you getting an answer? But you can able to say which one is the best with the help of section modulus of the cross section. This section modulus and which cross section is the best, these things will be covered in your normal stress due to bending or theory of uniform bending. There you can able to choose which one is the best according to the given condition. But if we just given these cross section, which one is the best, I can't able to say until unless I know some conditions actually. Are you getting or not, sir? Those things are discussed clearly in the theory of uniform bending. Now we start with the types of supports used in a beam. Generally, guys, we're having three types of supports. First one is hinge support. Second one is roller support. Third one is fixed supports. Are you getting an answer? What is the use of these supports? It transfers the load from external loads to the ground. Are you getting an answer? It is resisting the loads actually, guys. But how many reactions these supports are giving actually? If you observe, when the external loads are acting on the beam, your hinge support, hinge means there is a hinge is there actually, guys. It can resist two types of loads only. First one is vertical, that's why it will give you vertical reaction, and second it will give you horizontal reaction, but it cannot resist the loads which tries to rotate the beam actually, guys. Please look at here. Assume I can say two hinge supports are there. When the load is acting on the beam in between, what is happening? This support is resisting the load. This support also resisting the load actually, guys. Because of this resistance, it offer the reaction from the bottom, I can say. Are you getting an answer? But assume this is a hinge support. When the load is acting, look at here guys, when the load is acting, it can freely rotate about this hinge. Because there is a hinge is there, it can freely rotate about the hinge. That's why it is not offering any resistance about the rotation. Next one is, we are having roller support. Roller support means it can give you resistance only vertical direction, but no horizontal. As it is a roller, when the load is acting, it can slide on the horizontal direction. Are you getting or not, sir? It doesn't offer any resistance, I can say. Now, fixed support. It can give you how many reactions, guys? Give you 3 reactions. First one is vertical, horizontal, and it gives the resistance to rotation also. Are you getting or not, sir? So the moment you see in a beam fixed support, it give you 3 reactions. If it is a hinge support, it give you 2 reactions. If it is a roller support, it is going to give you 1 reaction. Okay, guys. But why we get the reaction, guys? Whenever you try to oppose the motion of that body, it gives the reaction, I can say. Are you getting or not, sir? Okay, I'm done with that. Now, coming to types of beams. Coming to types of beams. These beams can be divided into, guys, statically determined beams and statically indeterminate beams. Statically determined and statically indeterminate, actually, guys. Now tell me, what is the difference between statically determined and statically indeterminate, guys? The name itself says the unknowns present in the beam, if I can able to find out with the help of statics alone. Are you getting or not, sir? Statics. If I can able to find out the unknowns using with the help of statics alone, then it is called statically determined. What is the with the help of statics means, guys? It is the equations of equilibrium. What statics gives you, guys? It is the equations of equilibrium. Equilibrium. What is meant by equations of equilibrium? It is the relation between the forces. Are you getting or not, sir? The moment you hear equilibrium equation means it is a relation between the forces. Relation between forces. Majorly we are having sigma fx equal to sigma Fy equal to sigma Fz equal to 0, the same time sigma m also 0. These are called equilibrium equations. If I can able to find out the unknowns using equilibrium equations, these are statically determined beams. But what is meant by statically indeterminate beams, guys? Please tell me. Statically indeterminate beam means statically indeterminate means I can't able to find out the unknowns with the help of statics alone. By using statics I can't able to find out, but here I can find out definitely, but by using extra equations. Those equations are called compatible equations. Compatible. What is meant by compatible equation means it is a relation between deflections is called compatible equation. Are you getting or not, sir? Now tell me, to find out the unknowns in statically determined beams, I just need equilibrium equation sufficient. But to find out the unknown in statically indeterminate beams, I need equilibrium equations as well as compatible equations to find out the unknowns in the beam. But anyway, we can able to find out the unknowns. Definitely, there is no doubt that I can't able to find out. I can find out. But statics, equilibrium equations are sufficient. But indeterminate beams, just we need equilibrium plus compatible equation. Let's see what are the different types of beams are there, which divide into statically determined and statically indeterminate actually, guys. Statically determined means equilibrium equations are sufficient to solve the problem, but here I need equilibrium equation plus compatible equations. Okay, now tell me guys, typical statically determined beams are cantilever beam, simply supported beam, this is SSB, simply supported beam, this is the cantilever beam, CB guys, and we are having overhang beam, overhang beam. Okay. Coming to statically indeterminate beams, guys. First one coming to picture is, it is fixed beam and propped cantilever beams, like we are having something like this. This is called propped cantilever beams, propped cantilever beams. This is a fixed beam. And we are having continuous beams. Continuous beams means it is having more than two supports actually, guys, like this. This is a typical continuous beam. Hope you understand, guys. Cantilever beam, simply supported beam, overhang beam, fixed beam, propped cantilever beam, and continuous beam. But in syllabus of strength of material, mainly we focus on statically determined structures only. They clearly mentioned in the syllabus, guys. Find out shear force bending moment for the statically determined structures. This is what we are going to discuss mainly. But coming to deflection of beams, guys, they're frequently asking the questions on propped cantilever structures. Are you getting or not, sir? For mechanical student, guys, we required these three structures and propped cantilever structures. But for civil engineering students, you study all these varieties of beams, but you study determined structures in strength of material and indeterminate structures like continuous beam and fixed beam. You study in your structural engineering, guys, exactly. Structural mechanics and structural engineering. Are you getting or not, sir? There you discuss only, you will be discussed only statically indeterminate structures only. Are you getting or not, sir? But my scope for strength of material is limited to these three things and special case of propped cantilever structures. Hope you understand, guys. Types of loads. There are generally 6 different types of loads which are commonly applied on the beams. Assume for time's sake, guys, I have a beam. For time's sake, I am taking simply supported beam, guys. Simply supported beam. Okay. Now, there are 6 different types of loads. First one is, this is called point load. Point load. What is mean by point load? This is a load which is concentrated at one particular point only. This is also called concentrated load. Anything is fine, guys. And the second one is UDL. Uniformly distributed load. Here the unit of this one is W Newton per meter. Are getting or not, sir? It's a unit is in Newton per meter. Are getting or not, sir? Because it is distributed over the length L. But here it is a completely point load. And we are having another load, UVL. UVL, uniformly varying load. This load is varying from 0 to W Newton per meter, uniformly varying load. Are you getting or not, sir? And another load is point couple. This is the point couple, or they used to call it is the concentrated bending moment. Concentrated bending moment. And we are having another two types of loads. Suppose if the loads are acting like this, like I am having one force here, this another force here, two opposite forces, two equivalent opposite forces are applying, then what is going to happen, guys? These two will give you what? Couple. So what is the equivalent beam for this I can write? Guys, please stay here, concentrate here, guys. So it is giving clockwise or anti-clockwise, guys? It's going to give you the clockwise couple. How much, guys? P into D at this location. Are you getting or not, sir? Next, suppose sometimes on the beam there can be a inclined load. On the beam there can be a inclined load, SU for time's sake. This is the P. Then what is going to happen, guys? If you resolve this one into a vertical force, P sin theta, and horizontal force, how much, guys? P cos theta. But while drawing shear force and bending moment diagrams, or while finding the shear force and bending moment, I can completely ignore the horizontal force on the beam, because horizontal force will give you the axial force in the beam. It give you axial stress. Only lateral load will give you shear force and bending moment. Are you getting or not, sir? But this topic is to find out the shear force and bending moment. That is the reason even in the exam or even in any beam, if inclined loads are there, we will completely ignore the horizontal component of that inclined load. Are you getting or not, sir? Yeah, we will consider only this much. Second thing I want to tell you, suppose they given something like this, uniformly distributed load. They can represent like this also, guys. This is W, this is X. This is W, this is X actually. Now tell me, guys, I can make it equally like this, identical load. How much, guys? Area of this one, W Newton per meter, right? I want what is the total load is acting. How much? W into X. This is the area. Is X. Where it is acting? X by 2. Hope you understand, guys. This is the way I am converting from UDL to a point load. But guys, you can convert UDL to point load only for finding what, guys? Only for finding support reaction. But if you convert UDL to point load while drawing the shear force diagram, you will get the wrong answer. Why? Because, guys, if you look at the point load here, I am finding shear force before this. No force is there, you will consider it is 0. If you convert, I am telling you. But actual case, at least this location there is some shear force there. That is the reason don't convert UDL to point load while drawing shear force diagram or while finding the SF and BM. But you can convert while finding the support reactions. Similarly, guys, I am having a uniformly varying load is there. Uniformly varying load. This is W Newton per meter. Assume this is the distance is X. Now tell me, guys, can you convert this one? Yes. Where this load is acting, guys? At the centroid. Centroid will be 2x by 3 from here, x by 3 from here. Are you getting or not, sir? So this load equal to how much? Area of this triangle, half into W into X. Are you getting or not, sir? This is the basic things they are asking in the GATE exam, guys. Should be very, very careful about these types of loads. Okay, guys. Now we will understand the concept of shear force and bending moment related to beams. And second question is why we have to find out first? Why we have to find out the shear force and bending moment? Are you getting an answer? To understand this, assume for time's sake, I have the beam. The beam is subjected to lateral load. Now tell me guys, the beam is subjected to lateral load means it is giving the transverse load like this. Because of this load, assume the beam is not failing. The beam is not failing. Then what does it mean? It means that each and every section of the beam is resisting the applied loads or not, sir? I'm applying the load and the beam is not failing means each and every section of the beam is resisting the applied loads. Now I'm cutting the section and drawing the free body diagram, guys. Please look at here. This is the applied load. Now if we cut the section, the internal resistances developed at any cross section of beam are shear force and bending moment. Are you getting an answer? If somebody asks you in interview what is mean by shear force and what is mean by bending moment related to beams, just say single word. It is the internal resistances developed at any cross section of the beam, developed at any cross section of the beam is known as shear force and bending moment. Are you getting an answer? It gives you the resistance. But my question is, can you see the shear force and bending moment? No. But why? Because these are developed within the beam, inside of the beam actually. We can see external load, but we can't see the resistance. Okay, guys. Now coming to second question. Here, why we have to find out the shear force and bending moment first? Because, please look at here, guys. Shear force will try to develop shear stress. Suppose if the shear stress is more than the allowable material strength of the beam, are you getting an answer? Shear force gives the shear stress. If the shear stress is more than the allowable material strength, material shear strength of the beam, then what is going to happen? The beam just split like this. Are you getting an answer? Second thing is, if bending moment develops, bending moment will give you what, guys? Normal stress due to bending. If this is more than the allowable stress, then what is going to happen, guys? Beam just fails by bending like this. But how the stress will be acting, these things we discuss in detail in the next chapter actually, guys. Don't worry for time's sake. Are you getting an answer? Shear force will try to shear, bending moment will try to bend the beam when if the stresses developed due to shear force and bending moment are more than allowable. Stresses. But if you don't know, if you can't able to find out the shear force and bending moment, can you able to find the stress value? No. That is the reason I have to find out the shear force and bending moment at any section of the beam. Now guys, so for design, definitely guys, for a design, or we should design a beam in such a way that the stress developed due to shear force, the stress developed due to bending moment should be less than or equal to allowable value. Allowable value. Then only the beam is safe. This is the main objective, guys. Ultimately, our aim is to design a beams. For designing the beams, we should know how to find out the shear force and bending moment at any location of the beam. Here, there is one more interesting question, and it is frequently asked in the interviews also, guys. What is that question is, sir, in a beam, there is a shear force and bending moment develops. Which one is more dangerous? Does the shear force is made more dangerous or bending moment is more dangerous? Please think, guys. While you are designing a beam, which one you consider, shear force or bending moment? For this, I am giving you small tip, guys. Assume if length of the beam is high, when the load is acting on the beam, what is going to happen? This beam will fail by what? Fail by shear or fail by bending, guys? It fails by bending. So I can write the bending moment is more dominant in longer beams. But coming to shear force, actually, guys, assume earlier I hold this beam like this, that's why length of the beam is longer, but same beam I am keeping the support here. This is I am completely forgetting, actually, guys. Now I am applying the load at this location. When the load is acting at this location, what is happening, sir? Does this shorter beam is bending or does the shorter beam will shear, guys? It will shear, it will never bend. So what does it mean? When the beam is shorter, shear force dominates. So it dominates in shorter beams. But in general, whether you are designing a shaft or whether you are designing a beam or any concrete beam or steel beam, we used to use mostly, we are having a longer span beams only. I can write longer span beams. For the longer span beams, guys, which one is more dangerous? Bending moment, because bending moment will give you more stress. Are getting or not? So that is the reason we used to ignore the shear force and shear stress when the span of the beam is longer. Getting or not, sir? Even if you consider the stress developed due to shear force is very, very negligible compared to stress developed due to normal stress, due to coming bending moment. That is the reason, actually, guys, whenever beam length is long, we conserve only bending moment and normal stress. Hope you understand, guys. Now we find out the relation between applied load and shear force and bending moment. For this, guys, I am following some basic terminology here. First one is, in the entire SOM, I am assuming that Q is the applied load. Q is the applied load. V is the shear force. The moment you see V, it is the shear force. And M is the bending moment. Okay, guys. Now we will see, assume I am having a simply supported beam subjected to like a distributed load Q. And what is the unit of Q, guys? Newton per meter, because it is a distributed load. Look at here, guys. Then my question is, how the shear force is varying along the length of the beam, and how the bending moment is varying along the length of the beam. And if you want to find out the shear force at any location, what is that value of shear force, this we are going to discuss. So similarly guys, here I can finally conclude that shear force is varying with respect to x, bending moment also varying with respect to x. As you are going everywhere, shear force present everywhere, bending moment also present everywhere. But my task is to find out what is that particular value at any section. Please look at here guys. I have taken a small element with length equal to dx, which is at a location of x. So I am drawing a PD of this element guys. What is the length of this element guys? Tell me. It is the dx. Now tell me guys, this side I am assuming that there is a shear force V is acting this side. Okay. If the V is acting in this upward direction, to resist this V, I have to have a downward shear force here, but it should be what? V plus dV. But why? Please look at here guys. Now the load is acting on the beam. Because of this load, your beam is under equilibrium or not? Yes, the beam is under equilibrium. If the beam is under equilibrium, the element, so each and every segment of the beam also under equilibrium. Are you getting or not, sir? Each and every segment of the beam is also under equilibrium. What is mean by equilibrium? Upward force must be equal to downward force, left force must be equal to right force, clockwise must be equal to anti-clockwise. Now I am drawing free body diagram. This side, your shear force is acting upward direction. To prevent this one, or this is upward force side, to prevent this one actually guys, there should be some extra shear force. Why? Because guys, as it is varying with respect to x, if it here is V, this should be V plus dV, something extra. And what else is there? There is a force acting here. How much guys? Q times of dx. Why Q times of dx guys? Because Q is varying with respect to meter. So total upward force equal to much? Q into dx. And again, at this location, I will be having bending moment also. Assume on the left side, bending moment is M. On the right side, I can represent guys, bending moment is how much guys? M plus dm. If this is clockwise, this should be anti-clockwise to keep this element under equilibrium. This is the basic free body diagram of this element guys. Now please look at here. I want to find out relation between V and Q. For this, I am using equilibrium equations. Equilibrium equation. First equation is sigma Fy equal to 0. What is mean by sigma Fy equal to 0 means upward force acting on the element must be equal to downward force acting on the element. Now tell me, what upward forces are there? V and Q dx. V plus Q into dx. Now tell me, what are the downward forces are there? V plus dV. Hope you understand guys. This I can write. VV will be striked off. dV by dx equal to how much? It is the Q. This Q also varying with respect to x, because QV is varying with respect to x. Are getting an answer? So dV by dx equal to Q I can write. This is the first conclusion. Next one. Take moment about this point, some point I am assuming guys, this is the place, this is the point O. Take moment about this O, because you can take moment about any point because this element is under equilibrium. For time's sake, I am taking moment about this point. Now tell me guys, if you take moment about this point, definitely sigma m must be equal to how much? 0. What does it mean? Your clockwise moment must be equal to anti-clockwise moment about this point O. Now tell me guys, about this point O, this V will give you clockwise moment or anti-clockwise moment? About this point O, V will give you clockwise moment. How much? V into distance, force into distance, right? V into dx will give you clockwise moment, and this force Q into dx will give you clockwise or anti-clockwise. This one also clockwise. How much? Q into dx. This distance equal how much, guys? Anybody? This is dx by 2. Tell me, guys. Force equal to Q into dx multiplied by dx by 2 will give you clockwise moment. This must be equal to, does this V plus dV give you any moment? No. Are you getting or not, sir? And M will give you clockwise or anti-clockwise about this point? Clockwise. So I can write clockwise side M. And M plus dm about this point will give you clockwise or anti-clockwise, guys? Will give you anti-clockwise moment. Now look at here, guys. This M will be striked off. Are you getting an answer? Here also observe, guys, dx is very fine element. Dx into dx will be very small value compared to V into dx. I can say, guys, this value is very less compared to the V into dx. Assume for time's sake, the element I am taking is 0.01, sir. Assume for time's sake. Then what is mean by dx square? 0.0001. This value is very less. So I can strike off this one. Now tell me, guys, V into dx equal to how much? Dm. So I am getting dm by dx equal to how much? V. This is the relation between shear force and bending moment, and this is the relation between, tell me, guys, load and shear force actually. Hope you understand, guys. So we got the final relationship between intensity of the load, shear force and bending moment. What is that relationship, guys? Please look at here. dV by dx equal to applied load. What is unit of Q, guys? Newton per meter actually, guys. From this I can write d equal to Q into dx. If you just integrate both the sides, we get V equal to how much, guys? Equal to integral of Q into dx something plus constant. Okay. So from this I can conclude that shear force at any section equal to, please look at here, guys, this V is what? V is at a location of x. So I can say that shear force at any section equal to integral of Q dx. What is mean by integral of Q dx? It is the area of the shear force, area of the loading diagram from 0 to x, or I can convey in this manner, that equal to algebraic sum of lateral loads from left hand side of the section. Assume I have taken the section, I can say that shear force at any section at any place equal to, I can say that it is the area of the loading diagram between this to this R. I can say that summation of the lateral load from left hand side of the section R. This is also equal to minus of lateral load, algebraic sum of the lateral loads from LH, from RHS, right hand side. Whether you look from the left hand side, whether you look from the right hand side, you should get the same answer. That's why I kept the minus symbol here. But Why I kept specifically minus here? Don't worry, we will discuss in detail in the sign convention actually, guys. Similarly, dm by dx equal to how much? V. Are you getting an answer? From this I can write dm equal to how much, guys? V into dx. If you just integrate these two, I am going to get m equal to integral of v into dx plus constant. Are you getting an answer? Why I get constant, guys? It is an indefinite integral actually. D equal to I can write, please look at here. Integral of, what is mean by v? Again integral of q dx. Again integral of q dx multiplied by dx as it is plus again constant. From this I can conclude one thing, guys, exactly. This is what force. Why? Because q is, unit of q is what? Newton meter multiplied by meter will give you force multiplied by dx. Dx means again meter will give you Newton meter. Unit of this one is Newton meter. So what I can able to say, again moment integral I am having actually, sir. So I can conclude in this manner. Bending moment at any section equal to algebraic sum of moment of forces either to left hand side or right hand side of the section. This is the final conclusion, guys. You have to remember this one at any cost. This dabba you have to remember at any cost actually, guys. Okay. Now I can make another two more conclusions actually from this. What is that? Assume from here I am making A to B. Assume I want shear force variation between A to B. From this, what I can able to make it, guys? VB minus VA equal to area of loading diagram. Why? Because integral of q dx will give you area. Integral will give you area of the loading diagram. Area of loading diagram between A and B. Okay. Similarly here, guys, your bending moment is varying A to B. This one also varying from A to B. I can say that MB minus MA equal to what? Integration of V dx. Sarji, please listen. What is mean by integration? Integrating the things or adding the things actually, guys. What is mean by differentiation? It is a dividing the things. Are you getting an answer? Here integration means adding. That's why I made just algebraic symbol actually, guys. Or I can make it like this. MB minus MA equal to area of shear force diagram between A and B. Is that another conclusion we can able to make it? Okay. And last one, very important, which is very helpful for while drawing the shear force diagram and bending moment diagram. What is that? To understand this one, guys, you have to understand what is mean by slope. Assume I am having some function. Y is a function of x. Y is a function of x. Now tell me, I have drawn the something y diagram. Is a y curve. I want to find out the slope of this curve. How can you make it, guys? D theta equal to dy by dx. D theta equal to how much, guys? Dy by dx will give you the slope of this y curve, I can say. Similarly, if you observe from this, guys, dV by dx, assume, look at here everybody, guys, I am having a shear force, assume we give you the shear force diagram, okay. Now, what is mean by dV by dx? This is the slope of shear force diagram. Are you getting an answer? dy by dx means theta is the slope of the y diagram. Similarly, this theta is the slope of the shear force diagram. This is coming how much, guys? Q. Are you getting an answer? So I can able to say that the slope of shear force diagram at any section equal to load intensity at that section. Okay, you should be very, very careful about it. The slope of the shear force diagram at any section equal to load intensity at that section. Now tell me, guys, second conclusion for this. dm by dx equal to v. Assume I am drawing bending moment diagram like this. I am drawing y diagram. I am drawing bending moment diagram. dm by dx will give you what? The slope of bending moment diagram. The slope of bending moment diagram equal to how much, guys? Will give you shear force at that section. At that section. Okay, guys, these are the main two conclusions. If you understand these two, you can able to solve any problem in shear force and bending moment diagrams. Mostly in GATE or ASC, guys, they're giving the beam, they're asking you to find out what is shear force at particular location, what is bending moment at particular location. Okay, to solve these problems, guys, another thing you have to remember very carefully. First one is sign convention. Sign convention. Guys, sign convention, you should be very, very careful about the sign convention. If you make a mistake in sign convention, answer is wrong. Are you getting or not, sir? Everybody knows the concept, but they are committing the mistake in sign convention. That's why I am following a very basic sign convention so that you can remember for a longer time without extra effort. How? Please look at here, guys. And I want to tell you one more thing also. This sign convention is arbitrary. Arbitrary means some guys will define something. Some guys will take different sign convention also. Assume I am taking load upward is positive. Some guy will take upward is negative. Okay, but I have framed the equation based on this sign convention. First sign convention, load. Whenever load is upward, load upward is positive. If Q upward is positive, when load downward is negative. I'm telling you, guys, this is the only convention you have to remember for the entire SFND, shear force and bending moment. Why? Because, guys, sign convention of shear force also coming from sign convention of load only. But how? Please look at here, guys. And one more thing I want to tell you. Why I have assumed upward positive? Because in general, anything, guys, even if you take axis, upward is positive, downward is negative, right? You can remember this one without any effort. That's why I have assumed like this. Are you getting an answer? Next thing, sign convention for the shear force. Shear force. Assume I'm applying the load here. But how the shear force will be acting, guys, here? Please look at here. How the shear force will be acting? Upward direction to resist this one actually. This internal shear force will try to cause the clockwise rotation of the beam segment. Look at here, this is the applied load, this is the shear force. Because of these two opposite forces, it will try to give the clockwise rotation of the beam segment, then it is the positive shear force. Look at here, guys. Now, this is how is the load applied. Then how is the shear force, guys? Shear force will be opposite to this one. Then what is going to happen, guys? This internal shear force creates the anti-clockwise rotation of the beam segment. This is the anti-clockwise. Upward, downward, this will give you anti-clockwise rotation. That's why it is negative, I can say. Negative shear force. Now tell me, guys. But look at from the left hand side. This is how the load is acting. Then how the shear force, guys? Shear force will be upward. This will give you, tell me, guys, clockwise or anti-clockwise? Anti-clockwise shear force. Why? Because this will give you anti-clockwise rotation. Now look at here. Load downward, getting, sir? This will give you clockwise or anti-clockwise? Clockwise. That's why positive shear force. Sirji, very difficult to remember this one. Yes or no? Yes. Why? Because if you look at here, guys, here what is happening here? Downward load, right? Downward load, downward means what? Negative. But the shear force is coming positive. Load upward, upward load is positive, but the shear force is coming negative. Are you getting or not, sir? But if you look from the left side, here what is the load? Downward load. But shear force is what? Negative. Because downward is load is negative, shear force will be negative. Here tell me, guys, upward load. Upward load means fast, positive, but the shear force is coming positive. So no problem. That is the reason, guys, if you look from the left hand side, suppose I am having a body object like this. If you look from the left hand side, no problem, sir. Actually, the sign convention of shear force is equal to sign convention of lateral load. Are you getting or not, sir? But if you look from the right hand side, what is happening? The sign convention of shear force is equal to opposite of sign convention of lateral force, I can say. Are you getting, sir? Please look at here. If you look from the left hand side, load is positive, shear force also positive. Load is negative, shear force also negative. So that's why no problem. That's why shear force at any section equal to algebraic sum of the lateral force from the left hand side. Just follow sign convention of load. That's it. But if you are looking from the right hand side, what is going to happen, guys? Here load is negative, shear force is positive. Are you getting an answer? That is the reason to compensate this one, I just add minus symbol to get the right answer for me. If you just keep minus symbol, you no need to worry. Minus symbol, if load is positive, just add positive. Load is negative, just add negative. Why? Because I have compensated with the minus symbol if you are calculating from the right hand side. Okay. Even if you don't understand anything, guys, don't worry at all. Just follow this. Just remember this one and remember the sign convention of the load. And it will be more clear while solving the problems, guys. I will make sure that, don't worry and all. Next, sign convention for bending moment. Sign convention for bending moment. This is a little tricky, right? But it's very easy. Simple thing you have to remember, guys. Positive force. What is the positive force? Upward or downward, guys? Positive force will give you positive bending moment. Negative force will give you, are you getting an answer? Negative force will give you negative bending moment. This thing you have to remember automatically. If you remember this, you can get the answer easily. That's why this is the one which is you have to remember carefully. Even here also, positive force will give you positive shear force, negative force give you negative shear force, but only thing is you just have to keep minus symbol here if you're calculating from the right hand side. But for bending moment, whether it is a left or right, you get the same answer. But the question is again, why? That's why I'm giving you what is the actual sign convention of bending moment, guys. If the beam is sagging, it is a sagging of a beam, guys. It is the positive bending moment. If the beam is hogging, it is the negative bending moment. Are you getting an answer? This is the actual sign convention. From this I have simplified like this. Why? Because to sag the beam, look at here. Now the load is upward load. Upward load means positive or negative? Positive. If the upward load is acting, how the beam will bend? This is how the beam will be bending. So what is going to happen? This will give you sagging or hogging, guys. Sagging. That's why positive. Even if you look from the right hand side also, please look at here, guys. I am looking from the right hand side. Here, upward force, positive or negative? Positive. Bending moment, it gives you sagging or hogging? Sagging. So what is your conclusion actually, guys? For bending moment, whether it is from the left or right, it matches with the sign convention of the load. That is the reason simply I have taken bending moment equal to moment of lateral loads from left hand side or right hand side. You get the same answer. Hope you understand, guys. Or sometimes there is a another thing, sir. They used to give point couple. They used to give point couple like this. Point couple like this. Then this will give you positive or negative. This will sag the beam, this will hog the beam. So how the beam will bend, guys? This the beam will be bending like this. So this is a negative bending moment or positive bending moment? Negative bending moment. For this, you can remember a small trick, guys. Even if you don't remember this one also, you can remember very small trick. Because assume there is a given applied load is there. Because of the applied load, I have a beam. Look at here, guys. I have the beam. Assume before applying the load, I am having something water particles. Assume I am having something water particles on the beam. Water particles on the beam. Now tell me, guys. This will give you force upward is positive or negative? It's a positive. How the beam will bend? The beam will be bending like this. Because of bending of this beam, your water in the beam will be stored or will be falling down, guys. It will be stored. Storing of a water is a positive action or a negative action, guys? It is a positive action. You can remember like this also, guys. Positive force will give you the positive bending moment. Or if you don't remember like this, apply the given load and see whether the beam is able to store the water, will be able to remove the water, or like falls the water, I can say. Look at here now. Same logic. Now load Q is acting. Q is acting. How the beam will deflect? Beam will deflect like this. Then what is going to, guys? Water particles will be falling down. This is a positive bending moment or negative bending moment, guys? It is a negative bending moment. Why? Because, guys, water particles are falling down. It is a negative action. Similarly, M. See, guys, the couple is acting clockwise or anti-clockwise? Anti-clockwise, actually, guys. The couple is acting anti-clockwise. So how the beam will bend? Beam also bend anti-clockwise direction. So what is going to happen here? Water will be stored. Water will be stored means this is the positive bending moment. But don't think that, Sirji, my anti-clockwise is positive, clockwise is negative. Don't think that, guys. If you want, you can please check it, guys. This is what is the couple here? Anti-clockwise or a clockwise? This is the anti-clockwise. I am applying the same anti-clockwise couple here. If you apply the same anti-clockwise couple, what is happening? How the beam will deflect? The beam is deflecting like this. Then what is going to happen, guys? Your water will be falling down. It will give you negative bending moment. That is the reason I am not considering clockwise is positive, anti-clockwise is negative. I am just considering, guys, two things. When it can retain the water, it is the positive. When the water can be falling down, it is the negative. When positive force creates the positive bending moment, negative force creates the negative bending moment. Hope you understand, guys. So you have to remember three things here actually, guys. First one, load upward positive, load downward negative. That's it. Second thing is for shear force actually, guys, same logic. Take from left hand side as it is, add all the forces. From right hand side you have to keep minus symbol. But for bending moment actually, guys, positive force creates the positive bending moment, negative force creates the negative bending moment. When the water retains, it is positive, water falling down is negative. Don't worry, it will be more clear while solving the problems. Now we will learn the concept one by one with the help of example problems, guys. Most of the time in the GATE exam, they are asking you to find out shear force at particular location and bending moment at particular location. For this, you have to remember two things first. Shear force at any section equal to algebraic sum of the forces from LH side minus of from the RHS side. Moment equal to moment of forces from LHS or RHS. And second thing you have to remember is, guys, load. Upward load is positive, downward load is negative. Okay, if you remember this one, you can find out shear force and bending moment. Suppose if the couple is given, if the couple, the water falls down, is a negative, water retains is the positive. Are you getting or not, sir? This is just, you have to remember these things. The another one you have to remember. Hope you understand, guys. Now look at here, how I am finding shear force and bending moment at this segment A and at this segment B. Okay, guys, please look at here. Now shear force at this segment A equal to, I can write algebraic sum of the forces from the left hand side. For time's sake, I am taking left hand side. That equal to, look at here, guys, 20 upward or downward force, guys, 20 upward. Upward force is positive, means plus 20. And this 5 Newton meter is a downward force or upward force? Downward means negative. Force, what is mean by force, guys? 5 into 4. 5 into 4 will give you again 20. So what is the shear force at location A, guys? 0. Hope you understand, guys. Shear force equal to 0. Next, shear force at location B. Please look at here, guys. Algebraic sum of the forces. How much will be there, guys? Plus 20 as it is. Plus 20 as it is. Next, downward force, how much? Minus of 5 into how much? 4 plus 2. 5 into 4 plus 2, how much, guys? 6. Will give you, how much, guys? Minus 10 newtons, I can say, guys. This is the shear force at A, shear force at B. Next one, guys. Bending moment at A equal to algebraic sum of the moment of forces at A. How much, guys? 20 force into distance, 20 into 4. 20 into 4 will give you positive bending moment or negative bending moment, guys? It give you positive bending moment. Why? Because your 20 is positive force or negative force? Upward force is positive. That's why plus 20 into 4. Next, this downward force. Downward force means negative. And moment I want, What is the force value till this? 5 into 4 will be 20. But where this is acting exactly at this location, how much guys? 20 newtons will be acting center of this 4. So this distance equal to how much automatically guys? 2. So it is coming as 20 into 2, 40. So net answer is how much guys? 80 minus 40, it is 40 Newton meter. I got MA. Now MB. Please tell me guys, what is the moment about this point B? Same logic. Force into distance. 20 into how much guys? 20 into 4 plus 2 plus 2. 8. Okay. Next, this force into distance again. Downward force means negative. How much guys? 5 into 6. 30 multiplied by distance. What is the centroid of entire thing? Totally 6, right? It is acting at a distance of 3 meters. This is 3 meters. Because 6, because I am finding moment about this point. So this is 3, this is 2. Total how much guys? 3 plus 2 is 5. So I can write, so, correct, right? This is 3, this is 2, 5. 160 minus 25 into 6 guys, so it is a 150. So net answer is 10 Newton meter. Because for this problem guys, you can ask the question, Sirji, no sir, I will find from the right hand side only. Do it, no problem actually. But if you find from the right hand side, your answers should be correct. Whether it is a left hand side, whether it is a right hand side, your answer will be correct if you just follow this convention. Okay. But the problem here is guys, if you find from the right hand side, what is the problem? There is a support reaction is there. There is a support is there means, so I have to find out the support actually, support reaction first. So what I can say guys, assume there is support reaction something R, that I don't know actually guys, that I don't know, and I am having something bending moment M, something bending moment. You can take left or right, anything is fine. I am taking clockwise bending moment, no problem and all. Now please look at here guys. So how can you find out this R value? Take this beam is under equilibrium means upward force equal downward force. So how much I am going to get guys? Sigma Fy equal to 0. If you make it sigma Fy equal to 0, how much I am going to get guys? Upward force equal to downward force. Tell me upward forces. 20 plus 5 into 6. Yeah, sorry, 20 minus guys. This is minus. Why? Because, sorry, upward force equal downward force, right? 20 is upward plus R also upward. What is the downward force here guys? 5 into 6. So R equal to how much guys? Plus 10. That's it. So R equal to plus 10 aa gaya sir. Next, take moment about this point equal to 0. If you take moment about that point, this fixed point I can write. Please look at here guys. 20 into distance, tell me guys, 4 plus 2 plus 2, 8 plus 2, how much? 10 will give you clockwise moment, must be equal to anti-clockwise moment guys. Next, this M is what again? About this point will be clockwise again. This must be equal to, this force into distance will give you anti-clockwise. How much is this force? Tell me guys. This force will be 5 into 4 plus 2. How much? 5 into 6, 30. Multiplied by this distance guys. It is acting at centroid means 3 plus 2 plus 2. Look at here. 3 plus 2 plus 2. How much is coming guys? It is 5 plus 2, 7. That's it. So how much I am going to get guys? So M is coming as, yeah, M is coming as 210 minus 200, that equal to 10 Newton meter. So I got M equal to how much, guys? 10 Newton meter. Suppose if this direction I have taken it as a wrong direction, you will get minus 10. That's it. Because just by seeing the load, because I am having experience, I can able to say that here resistance will be upward, moment will be clockwise. I can say, even if I don't know, don't worry. Take some arbitrary direction and apply the bending law, apply the equilibrium equation. If you are getting negative answer, means you have taken the wrong direction. This is the way you can convey. Now tell me, guys, I am finding at B. This you can do it at your home, guys. I am finding at B. Shear force at B equal to algebraic sum of the forces. Algebraic sum of the forces. How much is coming, guys? This R is upward is positive or negative? Upward is, it is a positive. How much it should be? Plus 10. Sorry, guys. Yeah. MB, sorry, guys. Yeah, how much? Plus 10. Because upward force R means plus 10. But actual shear force at B equal to how much, guys? Minus 10. That is the reason I told you that whenever you are finding shear force from right hand side, just keep minus symbol and use the normal sign convention. You get the same answer. Hope you understand, guys. Actual shear force at B is coming minus 10. This is the right answer. But if you're looking from the right hand side, what is coming, guys? R is upward. As upward force is positive, I am getting plus 10 itself. To compensate this one, I am keeping minus symbol here. Now tell me, guys. Bending moment at B, I told you here, we no need to keep any minus or plus symbol here. Just add it and we will verify whether coming the same answer or not. At B, how much? It is coming as, guys, look at here, guys. This 10 is clockwise or anti-clockwise, guys? This will give you not clockwise, anti-clockwise. This 10 will try to, about this section, this will try to retain the water, or water will be falling down. Water will be falling down. Or you can say that this 10 will try to bend the beam in the clockwise direction. If the beam is bending in the clockwise direction, you are going to give you how much, guys? Negative bending moment. How much? 10. But this R, Sir G, here while you are finding the bending moment, ignore all other forces except this one. Why? Because, please look at here, guys. First I have taken M and I ignored completely remaining forces and supports. I completely ignored about the section how it is coming. I am finding B how it is coming. That's it. Now what is happening here? Again R is there here. Again about the section how the R is doing, guys. Will give you positive or negative. Water will be stored, or this reaction R is upward force means positive. That's it. Yeah, this is negative, guys. Minus 10 plus how much? Force into distance. 10 into 2, 20. The answer is 10. So answer is matched. Okay, what is the final conclusion? This is what I have proved completely. Sarji, if you remember these two things, you can able to answer any question. Okay, guys. Yeah. The next question is, guys, finding the shear force and bending moment at a location where exactly point load is acting. Sarji, if it is between these two, no problem, algebraic sum of the forces. But if they are asking exactly point load, how can I find out? They given multiple number of times, guys, especially like APPSC, AEE and all these public service commissions exams, guys. This is the most frequently asked. Deliberately they are asking the question, they are asking us to find out the shear force at location where exactly point load is there. If they are asking here or here, no problem. It is just algebraic sum. Are you getting an answer? Assume if they are asking here, what is the shear force, guys? 5 into 4, 20. Getting an answer? 5 into 4 is the 20. Is it negative or positive? Downward force is negative, so minus 20. But you are calculating from right side means minus of minus 20, you are getting plus 20 itself. No problem at all. But if they are asking exactly at this section S, then how can you find out? Please remember guys, whenever they are finding us the shear force at point load, first what you have to do is find out the shear force before the section and find out the shear force after the section, immediately after the section. Are you getting or not, sir? Assume before section how much? Before section, please look at here. Before section how much is there? First I have to keep minus symbol. Why? Because I am looking from the right hand side automatically. Now tell me guys, before the section 5 into 4, 20, but this load downward is positive or negative? It is the negative force. That's why minus 20. So the answer is plus 20. Okay. Now let's see after the section. After the section, then what is going to happen guys? After the section, please look at here. If you take after the section, as usual, starting from minus symbol, because I am clicking from the right side, 5 into 4, say minus 20, and again downward force, negative or positive? Negative. How much again? Minus 30, it becomes plus 50. Are you getting an answer? Plus 20 and plus 50. Then, which one you consider while designing a beam at that point? Because at that point, before plus 20, after plus 50 is there actually, then which one you take at that point? I can say it should be maximum of these two. I can write shear force at the location x equal to maximum of, look at here, maximum of modulus. It can be positive, it can be negative. VBS before the section, comma, VAS after the section. Hope you understand guys. Suppose this is plus 20, this is minus 50, but you will take it minus 50 is the answer actually, not plus 20. Are you getting an answer? Now coming to the bending moment guys. But if you take bending moment about this point, no problem guys, because this force doesn't give you any bending moment. Why? Because it is acting at the section, moment at S equal to, I can write, look at here, force into distance. Negative force or positive force? Negative force, because downward force is negative. Minus 5 into 4 is the force. Distance equal to how much? 2 plus 2, 4. Minus. But 30 will not give you any moment because force into distance is 0 here. So net answer is minus 80. Are you getting an answer? Look at here. Even though I am taking from the right side, I haven't kept negative symbol. But for shear force, I have to keep minus symbol and all. Hope you understand this one guys. Are you getting an answer? Yeah. Second thing, I am giving you one example guys. There is a load P exactly acting at this location. Then what is the shear force? Whenever point load is acting, find out the shear force before the point load is 0. After the point load, tell me guys, as you are taking from right side, first keep minus symbol, and downward force, positive or negative? Downward force is negative, minus of minus P plus P. So before is 0, after is P, so you will take shear force at this point A is how much? P itself. Okay guys, I'm telling you one more time, one more thing also. Anyway, I will explain you later, don't worry and all. While you are drawing the shear force diagram also, whenever point load is there, don't worry guys. First you have to draw till before the section, and after the section, just join these two. Find out before, find out after, and just join these two guys exactly. Anyway, I will explain this procedure guys, don't worry. Okay guys. So we got the second conclusion we got. Third conclusion is, whenever point load is acting on the beam, what you have to guys, find the shear force before and after, before the section and after the section. What you have to take it guys, shear force at the section equal to maximum of modulus of before section comma after section. Now I will ask you one more question, guys. Assume there is another force is there here. Another force, for time's sake I am taking. Another force I am assuming as assume I am having around 60 I am having actually, guys. Now tell me, this is the section now actually. Before the section, how much? Before the section, minus of, because I am taking from right side, 5 into 4 minus 20, next minus 30, it become how much, guys? Plus 50, no problem and all. But what about after section, guys? Look at here, shear force after section, same thing, plus minus of minus 50, but upward force plus 60 is there. How much is coming, guys? Minus 10. Okay, now tell me which one you take for design, plus 50 or minus 10? Plus 50. Hope you understand, guys. Plus 50 is the right answer. Are you getting an answer? You should take maximum. Here also answer is 50 is the right answer here. Okay. So we have done how to find out the shear force and bending moment at a location of point load. Okay, guys, what you will take it? You will take it before and after, and you will take the maximum value of these two in magnitude. Okay, guys. Coming to similar example, finding shear force at point couple. I am having point couple at a location S. Now tell me, guys, shear force at S equal to how much? Plus or minus 10. I am taking first, I have to start with minus because I am taking from the right hand side. Minus, downward is what? 10. 10 means what? Plus or minus, guys? Minus 10, shear force is 10. Whether you take it before or after, you will get the same answer, guys. That is the reason you no need to worry if the point couple is there. But if the point load is there, take it before and after for the shear force. Okay, guys, so this is not disturbed. Now tell me, guys, what is the bending moment S? This is the place you should be careful. Whenever you are finding bending moment at a location where point couple is there, then same logic, you should take it before. Find moment before how much, guys? 10 into 2. Do we need to keep minus symbol here? No, because for bending moment, you will get the same answer. How much, guys? Tell me. 10 into 2 to 20, but it is a minus or positive, guys. This is a 10. Downward force, negative force or positive force? Negative force. That's it. Before, I can write before the section, BS is minus 20. Now, M after the section. After the section, tell me, guys, after the section, if you take after the section, how much will be there, guys? As it is, minus 20 will be there. But this 50, how the 50 will be giving, guys? This 50 is clockwise or anti-clockwise? Anti-clockwise. Don't say that anti-clockwise is positive. Understand the nature. Because moment is anti-clockwise, how the beam will bend because of this moment? This one also anti-clockwise. As it bends anti-clockwise, it stores the water or retain, that it falls the water, guys. It stores the water. That's why plus 50. The answer is how much, guys? 30. Are you getting an answer? Now tell me, which one you consider for the design actually, guys? You can say 30, sorry, minus 20 is the right answer here. Not, sorry, it's a plus 30 is the right answer here. Why? Because same logic, moment at this particular location equal to, I can write, guys, moment at S equal to maximum of before the section, maximum of after the section. It is a magnitude only. The answer is 30. Don't consider positive or negative. This thing also you have to remember. Fourth one, guys, same logic. Whenever point couple is there, find before and after only M magnitude, only for bending moment you have to careful guys, but shear force you get the direct answer. Okay, MS equal to how much guys? Same logic, maximum before and maximum after, you get the same answer itself guys. Hope you understand. Now we see the another interesting question guys. The question given is simply supported beam subjected to UDL and subjected to two different point loads. The question they are asking is, first one, find the shear force and bending moment at A, B, C, D sections. Are you getting or not, sir? Okay. First of all, if you observe here guys, what is meant by shear force? Lateral load from the left hand side or right hand side. But if you look at from the left hand side or right hand side, what is there? My support is there. So I have to find out the support reactions first guys. So RA will be there here, RD will be there here. Now tell me guys, how can you find out the support reaction? With the help of equilibrium equations. Please look at here guys, sigma Fy equal to 0 if you take upward force equal to downward force. Please tell me guys, RA plus RD, RA plus RD equal to 50 plus 40 plus distributed load 10 into 4. This is a one equation I got it. Next, take moment about D. Are you getting an answer? Take moment about D equal to 0. Guys, if you take moment about D equal to 0, how much is the moment guys? Again, clockwise moment must be equal to anti-clockwise moment. Now tell me guys, about this point D, RA will give you clockwise or anti-clockwise? Clockwise. So how much guys? RA into 4 plus 4 plus 2, 10. And 50 will give you clockwise or anti-clockwise? Anti-clockwise. How much guys? Again 50 into 8 plus this 10 into 4 will give you again anti-clockwise direction. How much? 10 into 4 is the force. 10 into 4 is the force. Where this force will be at the centroid of this one. How much guys? 2 plus 4. How much? 6. Next. Again 40 into 4. Hope you understand guys. This RA you will get 80. 80 approximately guys. Next, what if the RA equal to 80, then what should be your RB guys? Sorry, RD. Look at here, 50 plus 40 will be 90. 90 plus 40 guys is a 130. If RD equal to 80, RA equal to 80, RD must be equal to 50 newtons. I got guys. I have seen RA equal to 80, RD equal to 50 guys. I have seen in most of the gate questions guys, especially they are particularly asking shear force at the supports. Shear force at the supports. Sarji, please remember, whenever they ask shear force at the supports means which doesn't mean that it is a support reaction. Are you getting an answer? Now tell me guys, what is the shear force at A? Please look at here. I am finding this is the shear force, this is the bending moment, location is A. Shear force at A. Please look at here guys. This is at A. I am looking from the left hand side actually guys. Now, do I need to keep any minus symbol? No, as it is. But as it is a point load, what is the shear force before? 0. After how much? RA, how much? Plus 80. Directly I am writing plus 80. Similarly, shear force at D. Same logic. If you are looking from the right hand side, because instead of calculating all these values, it is directly calculated from the right actually. Now, before section how much? 0. After section, upward force plus 50 or minus 50? It is the plus 50 because force is upward. But you are missing something here, guys. You are looking from the right hand side. So what I am going to get, guys? Minus I have to keep it first, and then upward force plus 50. Hope you understand, guys. If you are having a problem, no problem. Look at from the right side itself or left side itself. 80 minus 50 and minus 40 and again minus 40, you will get minus 50 directly, because it can be either left hand side or minus of right hand side. You should get the same answer. Please remember, guys, I am telling you number of times about this minus symbol. If you make a mistake, answer will be wrong. You should be very, very careful actually, guys. Next, about B. So A is done, B is done. About B, tell me, guys. About B, again there is a point load is there. So you take it before. What is the before, guys? Tell me. Before is plus 80 or minus 80. Tell me, guys. It is a plus 80. Why? Because upward force. But exactly after B, what is going to happen? Plus 80 minus 50. Plus 80 and minus 50 will give you plus 30 automatically. So what is the shear force at this point B? Maximum of, told you guys, maximum of before the section or after the section. Answer is how much, guys? Definitely 80. Now your task is finding at C location. Sarji, at least you try, guys. I'm going to give you like 10 seconds of time. Please try exactly what is the shear force at C. Please try, guys. I can wait for you. Please try. Okay, look at here, guys. It is easy to find the shear force at C from the left hand side or right hand side. If you take it left hand side, so many forces I have to add. But from right hand side, only this is the one is there. So it's easy, guys. Please look at here, guys. Again, this is the place point load is there. First, find out. Before the section, as you are taking on the left hand side, keep minus symbol first. Are you getting that? That's a minus symbol. So right hand side, keep minus symbol first. Please tell me, 50 upward, positive or negative? Positive. Okay. Next. So minus 50 is the, because before only minus 50 is there. But after what is there? Please look at here. Same logic. Minus of, because I am looking from the right hand side itself. Again, upward force is plus 50. Downward force is minus 40. The answer is how much, guys? Minus 10. Before is minus 50. After is minus 10. Then which one is a shear force you consider for the design, guys? Maximum of these two. It should be minus 50. Hope you understand, guys. Before I am getting minus 50. After I am getting minus 10. The answer is minus 50. Now coming to bending moment. Without thinking, at A, at D will be 0, because this is the place force, distance is nothing is there, or it doesn't give you any resistance, no bending moment will be developed at this supports automatically, 0, 0. Now B, at B location, is it easy to find out the bending moment at B from the right hand side or left hand side about the B? Left hand side. Why? Because only one force is there. Tell me about the B. 80 into 2, that's it. 160 plus or minus. So a positive force will give you positive bending moment, plus 160 automatically. Similarly, about this point, about C, is it easy to find out the bending moment from the left hand side or again right hand side, guys? Tell me. It's easy from the right hand side. Why? Because if you take it from left hand side, so many forces of moments I have to add. Are you getting an answer? Now tell me how much is coming, guys? 50 into 4, 200. But again, positive or negative? Positive. Why? Because upward force give you positive bending moment, downward force give you negative bending moment. Okay guys, now we will see one of the previous GATE question guys. Please look at here. The problem given is, it is a UDL load. Typically what type of beam it is guys? It is a overhang beam. The question they asked is, I want to have zero moment at the midspan. I want to have zero moment at this midspan. Then how much means the ratio of A by B equal to how much? Please look at here guys. This is symmetric load, right? Yes or no? Then how is the reactions actually? Please look at here. This is A, this is B, this is again A. So what is the overall length actually guys? What is the overall force first of all? W, because this is acting W Newton per meter. So how much guys? W of A plus, sorry, A plus A, W of A plus B I can write. So W of 2A plus B is a total weight acting downward. But it is a symmetric means it is shared between two places I can write. Assume this is the point A, this is the point B. I can write RA equal to how much guys? W into 2A plus B by 2 I can write. Hope you understand sir. And RD also same thing. So RD and RA both are having the same thing because it is symmetric I can write. Now tell me, I want to find out moment at the midspan. At the midspan what is happening guys? At the midspan your moment must be equal to 0. Now tell me, moment at the midspan, assume this section S equal to same algebraic sum of the moment of the forces either from the LHS side or from the RHS side guys. Please look at here. I am taking from the RHS side. See, MS equal to, do we need to keep any minus symbol? No, right? Now downward force, how much is the downward force guys? W into A plus this distance, how much guys? B by 2, because I want only force till this I can write. A plus B by 2, this is the force acting, but where this will act guys? At the center I can be able to say. At the center of A plus B by 2 I can say. So moment equal to how much now? A plus B by, sorry, A plus B by 2 by 2 I can write. It is similar guys, look at here. So I am having something like this. Something W Newton per meter is there. So this is the distance x. How much is the moment guys? W into x by 2, Wx square by 2, same logic. W, this distance is A plus B by 2 into x, A plus B by 2 by 2 automatically guys. This will give you negative or positive automatically? This will give you negative. Why? Because about this point beam will be bending like this. Or this is downward force or upward force? Downward force. Downward force is negative or positive guys? It is a negative automatically. Minus. This is done. Next, we are having RD. RD upward or positive, downward guys? RD is upward force means positive. Positive. And how much? What is the value of RD? The same thing itself. W of 2A plus B by 2. This is the 2 guys. Into this distance. This is the distance. How much? The center. This is the value equal to B by 2. How much? Into B by 2. Now look at here. This value must be equal to 0 because it's clearly mentioned that the resultant bending moment at the midspan shall be 0. Then what is the value of A by B? You can solve it very easily guys. Just rearrange the terms now. This W will be striked off automatically. This 2 will be striked off automatically guys. If you substitute, I'm going to get minus of A plus B by 2 whole square, that plus just multiplied by this, I can say guys, I'm going to get 2a plus b into b by 2 equal to how much? 0. Hope you understand guys. So from this I can able to say guys, please look at here, a plus b by 2 whole square equal to, I can write, just multiply 2 inside guys, I'm getting same thing, a plus b by 2 into b. Are you getting an answer? Yes. A plus b by 2, just make it this side automatically guys. So just inside a plus b by 2 into b. Now 1a plus b by 2, 1a plus b by 2 is getting cancelled. It is coming as a plus b by 2, that equal to b. Then a equal to b minus b by 2 equal to b minus b by 2 equal to b by 2. Then tell me guys, a by b equal to how much now automatically now? A by b equal to 1 by 2. So option C is the right answer. Hope you understand guys. Okay guys, the question here is, they given a typical overhang beam guys, subjected to UVL, and they given a point couple, it is going to be acting over there. The question is, what is the shear force at P, and what is the bending moment at S, I can say. Please look at here guys. First one is, to find out shear force at P or at S, whatever it may be guys, you need to find out the support reactions first. For this, I am converting this beam into a simple beam guys for finding support reactions. Please look at here. This is the RP and this is RQ, and next we are having, I'm converting this one to a point load guys. So how much is this one? Half into 25 kilonewton, distance 1.5 actually guys. I got this value, and at this location I can able to say guys, I am moving this like 100 kilonewton force into here automatically guys. How can I move? With the couple, this is 100 kilonewton. Couple is clockwise or anti-clockwise? It is the clockwise couple. How much? 100 into 0.25. Okay, I got it actually guys. Now please look at here. So from this I can able to say that with the help of equilibrium equations, I can able to find out guys, upward force equal to downward force. Tell me guys, RP plus RQ equal to how much? Downward force 100 plus half into 25 into 1.5 I can write. Next, take moment about, if you take moment about this point guys, take moment about RP, I am going to get, this distance is given as 2, this is 1, the point S is there actually guys, this is the point S, 1, this is again 1, this is 1.5 meters actually guys. Okay, and this distance equal how much automatically? 1.5 by 3, 1.2 into 1.5 by 3 guys. If this is L, it must be L by 3, this must be 2L by 3. 1.5 by 3 is the distance here. This is 1.2 into 1.5 by 3 will be the distance over there automatically, sir. Or I can write 1.5 by 3 guys. It is just 0.5 guys, I can say. Let me read directly. This is 0.5 and this is 1, I can say. Take moment about P. If you take it moment about P equal to 0, what I am going to get guys? Clockwise must be equal to anti-clockwise. 100 will give you clockwise, anti-clockwise will give you clockwise. 100 into distance equal to 2. At this moment, 100 into 0.25, which means that 25 I can say guys, plus 25 kilonewton meter, and this also will give you guys clockwise and anti-clockwise, again clockwise, how much? Half into 25 into 1.5 is the force. About this point distance, 2 plus 1 plus 1, 4 plus 0.5, 4.5 will give you clockwise couple that must be equal to RQ will give you anti-clockwise couple. So RQ into distance equal how much, guys? 2 plus 1 plus 1, 4. So you're going to get approximately RQ equal to 77.34. If RQ is 77.34, substitute over here, guys, you will get RP equal to 41.41 actually, guys, 41.41. But the question is, guys, he's asking shear force at this point P. Shear force at this point P means algebraic sum of the forces before P. Before P it is 0, after P it is just RP, reaction at the RP I can say. So shear force at P equal to reaction at the P, how much, guys? 41.4 kilonewton is the answer actually. Before P 0, after P will be this one itself. Next, second question is asking is, what is the bending moment at section S actually, guys? At this section he is asking. How can you find out? Please look at it, guys. At section S, I want bending moment. Same logic. Algebraic sum of the moments I can say. At this section S, this is easy to look at from this direction, guys. Tell me. Half into minus half into 25 into 1.5 is the force. This distance equal how much, guys? 1 plus 0.5, 1.5. Okay. Next, plus RQ. What is RQ value, guys? 77.34 multiplied by 1. Why? Because algebraic sum of the moments either from the left hand side, either from the right hand side, you get the same answer. I am taking from the right hand side here. So if you substitute, guys, you will get approximately 49.2 kilonewton meter. This you can find out from the left hand side also. If it is from left hand side, tell me the formulas are RP into 4 plus 100 into 2 minus again plus 100 into 0.25. You get the same answer. Hope you understand this problem, guys. Okay, guys. This is one of the previous ESC question. The question given here is, a lever is supported on 2 hinges at location A and location C, and it carries 3 kilonewton at some lateral load, guys, from the axis of the beam I can say. Then the question is, what is the bending moment at B will be how much? Are getting an answer? What you can do, guys? Please look at here. Simplify this problem. How do you transfer this force, guys? Assume there is a reaction at A, there is a reaction at C, and exactly at this point you want to transfer. How can you transfer, guys? Look at here. 3 kilonewton here to here you are transferring. So you have to apply what, guys? You have to apply clockwise couple I can say. So horizontal force 3 kilonewton will be there, and I will be having a couple. How much? Force into distance, guys, 3 kilonewton meter. Okay, but he's asking at this point B. At this point he's asking the what is the value of bending moment. But whether you look at from left or right, there are unknowns are there actually, guys. So find out RA first. To find out RA, take moment about this point first. Are you getting an answer? Okay. To find out RA, this is 1 meter he has given. This is 1 meter he has given. This is 1 meter he has given. If you take it at point B, what is going to happen, guys? At point C, guys, sigma moment about C must be equal to 0. So clockwise must be equal to anti-clockwise. Tell me, guys, RA into 3 meters will be clockwise. Are getting an answer? Plus, look at here, guys, RA into 3 will be clockwise, and 3 kilonewton meter will be also clockwise actually, guys. be equal to 0. Why? Because only two forces are there, and this 3 kilonewton will not give you any moment because it is a axial force, I can say. Now what is the value of RA, guys? Now -1, because -1 kilonewton is the RA. Why I got -1, guys? Because I have taken the wrong direction. Even if you take it, no problem and all, actually, guys. Now take moment about B. This is what he is asking. Algebraic sum of the moments, till this I can say. RA into how much, guys? RA into 2 and plus 3 kilonewton meter. But RA equal to how much, guys? -1. Substitute as it is. Because if I taken upward, I got minus. Just keep as it is itself. -1 kilonewton into 2 plus 3. The answer is 1 kilonewton meter. This is the value of bending moment, actually, guys, at point B. Hope you understand, guys. Now we will see how shear force and bending moment varies for the different loading conditions. Okay, guys, I'm assuming that Q is the load. This we discussed already, guys, the basic conventions, and V is the shear force and M is the, tell me, guys, bending moment. So what is going to happen, guys? So what is the relation between these three? We already derived the relationship. That is what? dV by dx equal to how much? Q. And so I can write V equal to how much, guys? Integral of Q dx plus C, constant. Similarly, dm by dx equal to how much, guys? Shear force. So rate of change of bending moment equal to shear force. So what I can say now, if we integrate this one, I am going to get integral of V dx plus C. Now please look at here, guys. Suppose if load Q is proportional to something x power n. If load Q is proportional to x power n, then how the shear force, guys? Shear force is proportional to what? Integral of x power n means it is x power n plus 1. So similarly, how is the bending moment, guys? It is proportional to x power n plus 2. Okay, guys, if you can understand these three, you can able to find out variation of shear force and bending moment for any loading condition. Okay, I am making a small column. This is the type of load or loading condition. Loading condition. Next, this is variation of shear force variation, or in bracket V, and it will give you bending moment variation in bracket M. Okay, guys, now look at here. First one is, if it is a point load, first load is, if the load is point load at this point, then what is happening for the shear force, guys? Whenever load is a point load, here in shear force, there will be a sudden change of shear force in the shear force diagram. Are you getting or not, sir? Whenever point load is acting on the beam, then there is a sudden change of shear force at that point load. It can be downward, it can be upward, depends on whether you are looking from the left side or right side. Hope you understand, sir. Now, how about the bending moment? Can you define the bending moment at a point? No, that's why I am leaving the blank over here. Second thing is, if it is UDL, second load is UDL. What is mean by UDL, guys? Here I can write W in the entire distance. W equal to how much? Constant, because W is constant in the entire X. Assume this is the X distance. Here I can write W equal to constant. W equal to constant means, what does it mean actually, guys? Sorry, W equal to constant means I can write it is proportional to X power 0. Are you getting an answer? W equal to constant means proportional to X power 0. Then how is the shear force variation? If load is proportional to, sorry guys, it should be Q as per my notation. If Q is proportional to X power 0, X power 0, how is the shear force? Shear force is proportional to what? X power 0 means X power X 1. It is proportional to X power 1, I can say. X power 1 means what? Shear force is varying linear manner. This is how it is. Shear force varies. Then how is the bending moment varies, guys? If V proportional to X power 1, how is the bending moment? M proportional to X power n plus 2, which means that M proportional to X square, which means that parabolic variation. It's a parabolic variation. Next, third one. It is varying UVL, uniformly varying load. If the load is uniformly varying load, which means that Q is proportional to X. Q is proportional to X. Earlier UDL aito X power 0. Here load is varying uniformly, which means that Q is proportional to X. Then how is the shear force variation, guys? Shear force variation V proportional to how much? X square. X power n plus 1, X power n plus 2. Same logic. So it is varying in the parabolic manner. Next, how is the bending moment, guys? It is varying in cubical manner. Definitely X power n plus 2 to become cubic parabola. I can write cubic parabola. Hope you understand, guys. Now, suppose no load. Suppose I am having no load in the shear force. No load. Assume, guys, this is A, point A, this is the point B. Between A and B, what happens? No load is there. If no load is there, how is the shear force variation? Assume dV by dx equal to what? dV by dx equal to what, guys? Q. But the load equal to 0 between A and B. If load equal to 0 between A and B, your shear force equal to how much? Constant. Because if you keep it Q equal to 0 here, V equal to constant. So here, your shear force is constant, equal to constant variation. Suppose, assume for time's sake, sorry guys, suppose at A, if this is 10, this will be remain 10 between A and B. Then how is the bending moment variation, guys? Bending moment variation is linear. Why? Because if this is constant, look at here, M equal to V equal to constant, integral of constant into dx, How am I getting, sir? M proportional to X. Are you getting or not, sir? Yes. So M proportional to X here, linear variation. So I can able to say when shear force equal to constant, look at here guys from this. So M equal to integral of something constant into dx plus c. So it is proportional to how much guys? Directly C1 I am taking out, it is coming proportional to X. So it is a linear variation. Suppose there is a bending couple is there on the loading diagram, then how shear force varies guys? I'm giving you 10 seconds of time. Think about it carefully guys. Whenever bending couple acting on the beam, then how the shear force varies? Tell me guys. No shear force variation, but the question is why? Please look at here guys. dV by dx equal to q, but there is no load. Q is the load, but he has given the bending couple. Are you getting or not, sir? That's why no variation in the shear force. No variation in shear force diagram. I can write shear force diagram. But what happens in the bending moment diagram, guys? Whenever bending couple is there, there is a sudden change in the bending moment diagram. It can be downward or it can be upward, depends upon how you are looking from the left side or right side. But which one is correct, I will tell you in the later session guys, don't worry and all. So whenever bending couple is there, there is a point moment, or there is a, I can say, vertical step. There is a sudden change of bending moment in the bending moment diagram. But shear force, no variation in the shear force diagram. So I can say here, your presence of bending couple in the loading diagram doesn't affect the shear force diagram. Am I correct or not? Yes. Your bending couple doesn't affect the shear force diagram or shear force variation, but for bending moment, it gives the vertical step or sudden change. Hope you understand this topic, guys. You have to remember this thing. Then it should be very easy to draw the shear force diagram and bending moment diagram. But in most of the time in the exam, guys, they are giving these three cases especially, guys. First one, second one, third one. This is the one they are giving most frequently. Remember here, point load, vertical step, no variation. UDL, linear, parabolic. UVL, parabolic, cubic parabolic. Mostly they are concentrating on first three methods, guys. You should be very careful. Hope you understand, sir. Procedure to draw shear force diagram and bending moment diagram. First tell me guys, what is mean by shear force diagram? Shear force diagram means it is the graphical representation of shear force. Are you getting or not, guys? Shear force diagram means it's a graphical representation of shear force or variation of shear force along the length of the beam. Similarly, what is meant by bending moment diagram, guys? Tell me now. It is the same graphical representation of bending moment or variation of bending moment along the length of the beam. This is the typical shear force diagram and bending moment diagram definition actually, guys. But how to draw this shear force diagram and how to draw the bending moment diagram? First step you have to follow is, guys, find out support reactions of the beam. Find out support reactions of the beam using equilibrium equation, using equilibrium equations. What are the equilibrium equations, guys? Already told you, sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0. This is the equilibrium equations. Okay, suppose if they given the beam like this, they given any load, whether it is a point load or UVL or whatever it may be, guys, the starting step to draw the shear force diagram and bending moment diagram is, first we need to find out the shear force. So we need to find out the support reactions. Assume this is the RA and this is RP. Okay, guys. Now, second step you have to understand is, suppose if there are some axial forces or some horizontal forces in this figure, if there are some axial forces like this, some axial forces or some like horizontal forces acting on the beam, just ignore it while drawing the shear force and bending moment diagram. But the question is why? Okay, guys. Next step is ignore axial forces or horizontal forces acting on the beam. Why, guys? Because axial force doesn't cause any variation in shear force and bending moment. Only lateral load or vertical loads creates the shear force and bending moment. Are you getting or not, sir, everybody? That's why I'm writing, guys, shear force comma bending moment due to axial force equal to how much, guys? 0. This is one of the questions they given already in the KIT exam actually, guys. Please look at here. Why? Because only lateral loads creates the shear force and bending moment variation. Next. I'm sorry, sir, I forgot to tell you. Suppose if there is a load something 5 kilonewton is there, SG for time's sake. This angle is 30 degrees. Then which one you consider while drawing the shear force diagram? Only 5 cos 30. You completely ignore 5 sin 30. Why? Because, guys, 5 cos 30 will give you the lateral load and 5 sin 30 will give you what, guys? It is the axial load. You ignore completely while drawing the shear force diagram. Next, I can write shear force at any section. Shear force at any section equal to algebraic sum of forces. Here force means lateral loads. Algebraic sum of forces from left hand side of the section, from LHS. Suppose, no sir, I will take it from the right hand side, no problem. What you have to do, guys, if you are finding the shear force at the section from the right hand side, just you have to keep minus symbol. Same logic is forces from algebraic sum of forces from RHS side. Are you getting or not, sir? Whether it is the left hand side or right hand side, you will get the same value. To get the same value, I have to take minus symbol from the right hand side. Why? Because, guys, because here I am assuming only one sign convention for the load. What is sign convention, guys? If the load Q is upward, it is positive. Load Q is downward, it is negative. But in some textbooks or in some YouTube videos or whatever you might have seen, guys, exactly, they used to assume that if you are looking from the right side, your shear, like your load is positive. Like suppose if you are looking from the right side, if the load is downward, it is positive. If looking from the left side, if the load is downward, it is negative. Lot of confusion is there. Are you getting an answer? So I don't want to do all these things. I am assuming only single sign convention. Load upward is positive, load downward is negative. So I can get the same value if we just use the same convention. This is very, very important, guys. This is the one. This point is very important. At any section equal to algebraic sum of the forces. Next important one is bending moment at any section equal to algebraic sum of moment of forces from left hand side or right hand side. You get the same value. No need to add minus symbol here. If you are looking from the right side, you will get the same value whether you look from the right hand side or left hand side. Hope you understand, sir. For shear force, if you look from the right hand side, I have to keep the minus symbol. Hope you understand, sir. Okay. Here also sign convention is same thing itself. We discussed already. When positive force, what is a positive force? Upward force will give you positive bending moment. Negative force means downward force will give you negative bending moment. Are you getting an answer? Next, suppose if they given a couple. So if the couple is there, what is going to happen, guys? If the water is falling, will give you negative bending moment, because falling of a water is a negative action I can consider. The water is storing because of your couple, then it is the positive bending moment. The same sign convention you have to follow. Very easy to remember also, guys. We will solve n number of problems based on this, so we will never have any confusion actually. Hope you understand, sir. This is the things you have to remember. So wherever you are finding the shear force or bending moment, take algebraic sum of force here of bending moment here. So with this you can able to find out shear force at any location of the beam, shear force at any location of bending moment at any location of the beam. But you have to remember few rules while solving the problems actually, guys, especially the location. Rules to follow. Rules to follow. For rule number 1, Sarji, if it is a cantilever beam, in the exam if it is a cantilever beam is there, always find the, if it is a cantilever beam, always find shear force or bending moment from free end only. From free end only. Always take the section from free end itself. It will be moving in this direction. But if you move from the fixed end, what's going to happen exactly, guys? You have to find out the support reaction here. Again, time consuming. But if you are starting from the free end, it is easy to solve. Remember, guys, whether it's the left side or right side, always go from the free end only. But in this problem, observe, guys, you are going from right to left. As you are going from right to left, while drawing the shear force diagram, you are taking from right hand side. I have to keep minus symbol here. Are getting everybody, guys? Or I can make a point here. The point is always, if possible, I can write, if possible, find the shear force from left hand side only. So we will not be having any problem. But if you are taking from, if shear force is finding from right hand side, use minus symbol first. and then write. This is similar to this one itself actually, guys. But if it is a cantilever beam, just take it from whatever the free end it is, okay? Irrespective of left side or right side, take from the free end only. And third point, very important point actually, guys. Third point is, look at here. Third point is, suppose you are finding the shear force exactly at the location where concentrated load is acting. Are you getting or not, sir? You are finding the shear force exactly the location where concentrated load is acting. Assume for time's sake, sir, something 60 newtons are there here. This is 40 newtons is the shear force is there. Then how much is the shear force at this point C? How can you find out, sir? Is it 40 or minus 20? Which one you say? It is there, both the things actually. Look here. Whenever you are finding shear force at a location where point load is there, what you have to do, guys? Find out the shear force before concentrated load, before C, and find out the shear force after C actually, before and after. You find out before and after and join these two. Why? Because, guys, I already told you. Because whenever concentrated load is there, there is a sudden change in the bending shear force diagram. So how is the shear force diagram, guys? Please look at here. 40 upward force will be there because I am looking from the left side itself. Here to here, no force is there. So that's why simple constant actually. This value equal to how much? 40. But after, so how much is the value, guys, after this? 40 minus 60 will become minus 20. So I have to join before load and after load with a vertical step. This signifies the sudden change, and this thickness will give you what, guys? This thickness will give you what? The magnitude of the load. Are you getting everybody, guys? The size of the sudden change will give you magnitude of vertical load, I can say. Suppose in design you are designing a beam, then which one you consider for while designing the beam, guys? You say that shear force at the C is 40 or minus 20, guys. It should be 40, not minus 20. That's why for design के लिए, for design, if you're designing the beam, the maximum shear force at the point C equal to maximum of only magnitude. I don't care whether it is a minus 50 or minus 60. Suppose this is plus 40, I am getting minus 70. Which one you consider for the design, guys? Minus 70. Because these sign conventions, plus or negative, I have assumed myself for my convenience. So, but in design, we take only magnitude. So, before, comma, after. So, how much is the value, guys, here? It should be 40. Similarly, while drawing the bending moment diagram, there is a point couple is there. The procedure is same. You first draw before the point couple, and after the point couple. B means before, A means after. Are getting it, guys? You just join the MB and MA with a vertical step. Or we discussed already, guys. Whenever point couple is there, what is going to happen, guys? There is a sudden change in the bending moment diagram. Hope you understand, guys. Whenever point couple is there, the sudden change in the bending moment diagram. So that's why first you have to find out before the point couple and then find out the after the point couple and join these two. This is, assume this is the before, this is after, join these two. This size of this vertical step is equal to magnitude of the bending moment. Similarly, while designing the beam, because bending moment will give you bending stress or flexural stress. While designing this beam, which one you consider, whether it is you consider MA or MB or point couple M at that point, actually guys, same, it is the, for design I can write, for design M max or moment about C equal to, you will take it maximum of modulus, means magnitude only, before comma after, whichever is coming maximum, you will take that value for designing of this beam. Hope you understand guys. Let me give the quick revision about this one guys. You have to remember these two things, very very important. Shear force at any section equal to algebraic sum of the forces if you are looking from the left side, or minus if you are looking from the right side. But bending moment is remains same, whether you look from the left side or right side, you will get the same value. And should be very very careful whenever concentrated load is there. Find out before and after and join these two with a vertical step. Hope you understand, sir. If you understand this slide, you can able to draw the shear force and bending moment diagram very easily. So to draw it, you have to remember two things actually. First one is this slide, completely this slide you have to remember at any cost. And second one is what guys? Second one is what? Second one is you have to understand how the slope varies. How the slope varies in the shear force, like in the shear force diagram and bending moment diagram. Who gives the slope guys? I can write. Who gives the slope? The slope of the, tell me guys, the slope of the shear force diagram is equal to applied load. The slope of the shear force diagram is equal to applied load, and the slope of the bending moment diagram equal to what guys? It is the shear force. When shear force increases, the slope of the bending moment diagram increases. When loading increases, the slope of the shear force diagram will be increases. If you understand these things guys, you can play with the shear force and bending moment diagrams. You can easily able to answer any question in the GATE and ESE. Hope you understand guys. Standard cases of shear force diagrams and bending moment diagrams guys. These are very helpful in solving the problems also guys. For drawing the shear force and bending moment diagram, I given the complete procedure and important points to remember while drawing the shear force diagram, everything I have given. But for drawing the entire SFD and BMD, I am keeping what are the main things is required for drawing the shear force and bending moment diagrams on the left side actually guys. First, I just want to give you a quick recap here. Always remember, upward force is positive, downward force is negative actually guys. Because of bending moment, the water is falling down, it is negative. The water is falling up, it is a positive guys. Now, shear force equal to algebraic sum of the forces from the left hand side are minus of algebraic sum of the forces from the right hand side. Bending moment equal to algebraic sum of the moments from left hand side or right hand side, you get the same answer actually guys. And this is the one you have to remember actually. Whenever no load is there, your shear force is constant. Whenever bending moment is linear actually guys. UDL linear parabolic, UVL parabolic, cubic parabolic. Whenever point load is there, there is a vertical step at the point of application of the load, gives the sudden change of the shear force at that location, but bending moment, it doesn't disturb. Next, coming to your point couple, no change in the shear force, but there is a vertical step at the point of application of the bending moment in the bending moment diagram you have to say. And another important one is the slope of shear force diagram is equal to, tell me guys, applied load, and the slope of bending moment diagram equal to shear force. Why? Because M is the bending moment, dm by dx is the slope of the bending moment diagram. So if you understand this one guys, you can play with any shear force diagram or any bending moment diagram. Please trust me guys. Okay, I will make it one example here. Assume I am having a cantilever beam subjected to point load. Point load actually, guys. Now tell me, I can able to find out very easily, guys. I am drawing the shear force diagram. Please look at here. Shear force diagram SFD. Assume length equal to L. Okay. Now I am looking from the left hand side only. So tell me, guys, force downward. Downward force is positive or negative? Negative. So shear force diagram is negative automatically. Are you getting or not, sir? And there is no load between here to here. As there is no load, shear force is what, guys? Constant. Are you getting or not, sir? And again, it will go upward direction. Why? Because support reaction will be there at that location. This is the negative shear force, completely negative shear force actually, guys. Next, coming to bending moment. So how much is the value of shear force everywhere? P equal to constant. If you want, you can verify, guys, at any location. Keep your hand in the middle of the bar, wherever you want. Algebraic sum of the forces minus of P. Are you getting or sir? Shear force equal to minus of P. Coming to the bending moment. I am drawing the bending moment. Now tell me, this gives you the negative bending moment or positive bending moment? Force, negative or positive? Negative force should give you negative bending moment, but the starting point will be 0 and end point will be what, guys? How much? Bending moment, algebraic sum of the moments. P into L minus P into L, be specific actually, guys. But how to, guys? If it is, look at here everybody, it is constant, it should be linear. This is the typical bending moment diagram. But in the exam, what they're asking is mostly, guys, they will give you typical shear force, like they will give you typical beam subject different types of load. What they ask is, what is the maximum shear force in the beam? What is the maximum bending moment in the beam? Why? Because, guys, beam always fails at the location where the bending moment is maximum, because it gives you the more turning effect actually. Are you getting or not, sir? Yes or no? Suppose I have a tree. Look at here everybody, guys. Assume this is a tree branches. Tree branches are there. Assume for time's sake, guys. This is a tree branches. Which location is going to fail first? Suppose if you are hanging here automatically, guys, this is the weakest point, because F into D is more. This is the place it is going to fail. This is the place where the maximum bending moment will be there. It gives you maximum shear stress. So I have done with this. Now let us see. Same thing. Same thing, guys. So UDL, W Newton per meter or Q Newton per meter, anything is fine. The length is L here. Please tell me, guys, if you're looking from the left hand side, you can look from the right also, no problem, but there is a fixed support is there. So you should be very careful. Are you getting or not, sir? Now look at here. Shear force diagram. At starting, algebraic sum of the forces before, nothing is there, starting from 0. Next, but as you are going towards this one automatically, guys, where is the maximum shear force? Algebraic sum of all these forces, how much? W into L. Force equal to W into L. But look at here, guys, it is a downward force or upward force? It is a downward force. Downward force is what? Negative, I can say. Are you getting or not, sir? Please look at here. This is how much? Minus P into L. Please look at here, guys. Why I am having, please look at here, why I am having linear variationship? Told you, whenever it is a UDL, your shear force must be linear variationship. And second thing, how is the bending moment variation actually, guys? Definitely at the starting it is 0, and at the end, this location actually, guys, how much is the bending moment? Algebraic sum of the moments. What is the moment? W into L is the force acting at what distance? L by 2 distance. W into L into L by 2. How much I am going to get, guys? W L square by 2. minus WL square by 2. I forgot to tell you why I have taken minus, guys. Tell me. Because this is a downward force. Downward force is negative. Negative force will give you negative bending moment automatically. But the problem here is it is a parabolic variation. But tell me, guys, parabolic. This is also parabolic. I can write. This is also parabolic. But which one is correct? This is the place, guys, where most of the students commit a mistake. These are the simple beams, guys. You can draw it very easily. But if the complex beams are there, complex loads are there, so very difficult you to draw unless you know the proper concept. Okay, guys? Because this is the decreasing slope. This is the increasing slope. Are you getting it, sir? Why I am saying decreasing slope? What is the slope for this? 0. I am not saying negative increasing or positive increasing. It is a highly confusing for the students actually, guys. Since I have been teaching from past 10 years, I know where the students are committing a mistake actually. Please listen. If you refer the textbooks, they give you is a decreasing slope, increasing slope. Don't worry at all. Keep everything aside. Just follow this one actually, guys. Horizontal means 0 slope. Vertical means maximum slope. Horizontal means 0 slope. Vertical means maximum slope actually, guys. So how the slope is happening, sir, here? Slope is changing from, look at here everybody, guys. It is increasing from here to here, 0 to maximum. But what is happening for the second plot? Tell me, guys, second plot. This is horizontal here. This is horizontal. Starting is horizontal and ending is vertical. So what is happening, sir? The slope is 0 slope, increasing to vertical automatically. But which one is correct? Who will decide this one, guys? From where you can get this answer? From this one. But this is the bending moment diagram. The slope of the bending moment diagram is what, guys? Shear force. This is the slope I can write. Now tell me, guys, slope is proportional to quantity of shear force at that location. Now tell me, guys, exactly at this location, shear force equal to how much? 0. Yes or no? Because shear force is varying from 0 to maximum. I'm telling one more time, guys, don't consider it is a negative or a positive. Consider only magnitude. Are you getting or not, guys? Please look at here. It is varying from 0 to maximum. Look at here, guys. At exactly at this location, shear force equal to 0. Assume this is x equal to 0 location, the x equal to L location. I am increasing x from left hand side. Now look at here, guys. At x equal to 0, your shear force equal to 0. At x equal to 0, your shear force equal to 0. What does it mean? If shear force equal to 0 means the slope of the bending moment diagram is equal to 0. The slope of the bending moment diagram equal to 0 means, tell me, guys, it is a horizontal line or vertical line? Horizontal line, because horizontal one is having the 0 slope. Okay. Now, at x equal to L, what is happening, guys? You are having a maximum shear force. If the shear force is maximum, your slope should be also maximum automatically. Are you getting it or not, sir? Here, this is the place you are having a maximum shear force. I must be having a maximum slope. But tell me, guys, maximum slope is for what? It is a vertical line or horizontal line? Vertical line. So how do you join this horizontal to vertical, guys? Smoothly like this. So what is going to happen? As you are going from here to here, the value of shear force is increasing. The slope of the bending moment diagram also increasing, I can say. 0 slope, maximum slope. 0 slope, maximum slope. Hope you understand, guys. This is the, if you're perfect in this one, guys, you can able to find out for any curved beams, I can able to say any different types of loads. Only thing, the slope of the bending moment diagram shear force, the slope of the shear force diagram is applied load. Hope you understand, guys. Now we will see the another variation of cantilever beam. Assume I have a cantilever beam subjected to uniformly varying load. Load is varying uniformly. Load is varying uniformly, guys, exactly. Then what is the maximum shear force? The question is same, guys, everywhere. They will ask you, you have to find out what is the maximum shear force and what is the maximum bending moment. These things are very important while designing the beams actually, guys. Please look at here. Now, it is varying from uniformly varying load means it is varying from 0 to W Newton per meter. W Newton per meter. The length is L. Okay, guys. In the previous problem also, like this is I forgot to tell you guys. They have given the UDL. What I have taken, I can write in the equation form also, analytical form also. Look at here. I have taken a section here at a location of X. What is the shear force I can write? Shear force equal to algebraic sum of the forces. But I am taking from the right hand side. So minus I have to keep. Earlier diagram, guys, I have taken from the left hand side. Okay, please be careful. Minus downward force is what? Minus itself. Minus W, because this is a W Newton per meter, W into X, it is coming as W into X. Hope you understand, guys. Similarly, bending moment at any location is equal to how much? Same thing. Downward force, negative. Okay. What is the moment? Force into distance. What is the force? W into X, X by 2. W into X by 2 will give you minus W X square by 2. There is a moment for that actually, guys. Are you getting or not? Yeah. That is the reason. If you observe in the previous diagram, guys, so we are having a shear force is varying linearly and bending moment is varying parabolic variation. Are you getting or not, sir? Okay. Similarly, we do the same thing for here, or you can directly draw it, guys, if you are very well confident about it. But I will write the equation as well as I will write the normal form. Look at here. Shear force at X equal to 0. Assume this is X equal to 0 I am writing, and I am going from left to right. I am going from right to left. How much, guys? X equal to 0 to X equal to L. Okay. I am going from right to left. Tell me, am I going from right to left? So if you take a section or anywhere, you are finding from right hand side of the beam. Right hand side means your shear force must be minus. Now tell me, guys, at X equal to 0, 0. Now at X equal to L, how much, guys? Tell me. At X equal to L, this is minus of, because you are coming from right hand side, minus of downward force. Negative or positive downward force is negative. Minus of minus entire algebraic sum of the forces downward. What is the area of this one automatically, guys? Half into W into L. So it is a WL by 2, positive WL by 2. So I can write it like this, guys. I can draw it like this. This is 0 and this is what? Positive WL by 2. But how do you join 0 to WL by 2? Is it linear variation or parabolic variation or cubic parabolic variation, guys? Please look at here. Whenever load is UVL, shear force must be what? It is a parabolic variation. Whenever parabolic variation come, again the problem come. What is that problem? It is increasing parabola or decreasing parabola. But who decides this? This is the one. Because the slope of the shear force diagram is given by what? Applied load. Please look at, guys, I have to join these two. How do I join, guys? With the help of a slope concept. Look at here. This is shear force diagram, right? The slope of the shear force diagram dV by dx equal to what? It is the applied load. Please look at here, guys. So I can say that at this location, what is happening? your applied load is what? 0. Whenever applied load equal to 0, I can write at x equal to 0, your Q value will be equal to 0. Applied load equal to 0. When applied load equal to 0, what is happening for slope, guys? Slope must be 0. Slope equal to 0 means how you start the shear force diagram here. It's a horizontal line or vertical line, guys. Slope 0 means horizontal line. Next, at x equal to L means what is happening, sir? Your Q is maximum, your W is maximum. Having Q max, load is very high, 0 to W max. Then your slope should be also, the Q is maximum, slope should be also maximum. Please tell me, guys, maximum slope means vertical line or horizontal line, guys? It is a vertical line. Okay. Now, how do you join horizontal to vertical? Like this or like this? Yes. This is the typical shear force diagram. Hope you understand, guys. Now coming to bending moment diagram. Same logic. At the starting, bending moment equal to 0. At the end, bending moment equal how much, guys? I want m at x equal to L. What is the bending moment, guys? Tell me. Force into distance. What is the force? Entire downward force, half into W into L, where this will be acting, guys, at the centroid. So this distance equal to how much? This is L by 3. This is 2L by 3. Okay. I am taking moment about this point means force into L by 3. It is coming as WL square by 6. That's it. Okay. But it is a negative or positive. You are missing again, actually, guys. The force is downward. As the force is downward, it is a negative bending moment. Hope you understand, guys. That is the reason, guys. You no need to worry about the sign convention of shear force or bending moment. If you just remember the sign convention of the force, it gives you automatically. Okay, this is very easy to remember, actually, guys. Minus WL square by 2. So minus WL square by 2. But again, the problem here is how do you join? It is a parabola or cubic parabola. Whenever shear force is parabola, your bending moment must be cubic parabola. Again, the problem comes. How is the slope? Increasing slope or decreasing slope? It depends upon again what, guys? The slope of the bending moment diagram depends upon what? Shear force. When shear force equal to 0, slope must be 0. Identify the location. This is the place where the shear force equal to 0. So slope of the bending moment diagram must be equal to 0. Now tell me, guys, at what location I am having maximum shear force? At this location, I am having maximum WL by 2, actually. So your slope of the bending moment diagram must be also maximum. So I have to join vertical. How do you join these two, guys? Vertical to horizontal. This is the typical bending moment diagram. Okay. Suppose if they ask in between somewhere, it is easy, guys. Write in the equation format this problem also. Please look at here, guys. How can I write in the equation form the same problem? In the analytical form I can write. This is a Q or W Newton per meter or Q Newton per meter. Anything is fine. Please look at here, guys. Length is L, but I have taken a section X. Section X. I want to find out shear force at this location. I am taking section from the right hand side or left hand side, guys? Right hand side. So the moment you take it right hand side, V must be equal to start with minus symbol, and then downward force, positive or negative? Downward force is negative, negative, and area of this one. Please tell me, guys, if this is Q, what is the height over here automatically? Just take it angle. Please look at here, guys. If this is Q, assume this is the Q dash. This angle is same, I can write. This distance is X, this distance is L. Tell me, guys, angle is same, tan theta, take it angle guys. So Q by L, take it tan theta, Q by L must be equal to Q dash by X. So Q dash equal to how much guys, this value? Qx by L, that's it. Now tell me guys, downward force of this entire area how much? Half into, tell me guys, Qx by L into X, that's it. This is the shear force. So how much is coming guys? Plus Qx square by 2L. 2L. I got it guys. Now, what is the bending moment now, tell me? Bending moment equal again force into distance. So what is the force? Enter this force, half into Qx by L into X. It is the bending moment. So it is a force multiplied by distance. How much guys? It is acting x by 3 distance here automatically. X by 3. It is coming as Qx cube by, I can write 6L. With this, I can find out shear force and bending moment at any location. Sirji, I made a small mistake here. Have you recognized? This is the place. X equal to L, WL square by 6. But while writing, I have taken 2 guys. It should be 6. Okay guys. Now we see the same cantilever beam, but UVL is reverse direction actually guys. Earlier it was maximum to minimum, here minimum to maximum. Then how the shear force and bending moment varies and what is the maximum bending moment and what is the maximum shear force. Please look at here guys. Same logic. Starting shear force is how much? 0. You can ask the question, Sirji, starting maximum load is there na? Then how can you say it is a shear force equal to 0? Arey, load is there, but I want shear force. What is mean by shear force? Algebraic sum of the forces before the section. At this section, is there any shear force is there before? No, that's why it is 0. Are you getting an answer? Yes. Now, please look at here guys. Here it is starting is 0. As you are increasing, definitely shear force will be also increasing. But maximum shear force will be at this location at x equal to L. Shear force at x equal to L. Please look at here guys. I am looking from right hand side. So minus I have to keep it. So minus first. Entire force, algebraic sum of the forces. How much is the entire force guys? Half into W into how much? L. Are getting minus WL by 2. Sorry guys, it is a minus. As it is downward, again minus, one more minus. It is coming plus WL by 2. 0 to WL by 2. How do you join? Linear or parabolic guys? Because it is the UVL, it must be parabolic. Tell me, parabolic means how do you join again? Please look at here. The slope of the parabola, it depends upon what? Applied load. This is the place applied load is 0. Your shear force may be maximum. I'm not caring about the shear force because shear force is developed within the beam. But slope is depends upon applied load. This is the place your Q equal to 0. As the Q equal to 0, what is happening guys? Please tell me. Q equal to 0, your slope of the shear force diagram must be equal to 0. Please look at here. dV by dx equal to Q. When Q equal to 0, slope equal to 0 means horizontal line. Here, Q equal to maximum. So slope should be maximum means vertical line. How do you join? That's it. This is a typical shear force diagram. Similarly, how is the bending moment diagram? Please look at here. Starting is 0 as usual, but V at x equal to L, how much guys? Force into distance, right? Downward force minus force equal how much? Half into W into L is the force, but where this force will act? At the centroid. So this distance equal to how much? 2L by 3. This distance equal to how much? L by 3. So you are taking moment about this point means force minus half into W into L into 2L by 3. How much is coming, guys? WL square by 3 minus WL square by 3. So you are going to get minus WL square by 3 and it is 0. How do you join, guys? Again, it is a cubic parabola. Please tell me, guys, how is the slope? By this time, you must be very confident, guys. I am giving you 5 seconds of time. Join these two. 5, 4, 3, 2, 1. Okay, guys? Done? Okay, please verify the answer now. 0 to minus WL square by 3. See, guys. The slope of the bending moment diagram is depends upon what? Shear force. This is the place where your shear force equal to 0. The slope of the bending moment diagram must be 0. That's it. Now, this is the place where your bending moment is, shear force is maximum. The slope of the bending moment must be maximum. So, vertical. Okay, guys. Then how do you join? Like this. That's it. Very simple, guys. Remember one thing. Horizontal line, 0 slope. Vertical line, maximum slope. Join these two. You can able to solve any problem, guys. Hope you understand this problem. Now, we draw the shear force diagram for this cantilever beam subjected to end couple. Are you getting that or not, sir? Now tell me, guys, what is the shear force diagram for this? No shear force. Shear force equal to 0 at any location. Doubt? Keep your hand in the middle of the bar. Look at one direction. It is the algebraic sum of the forces. Any force is there before? No. Are you getting an answer? Or I am giving here. Whenever point load is there, no change of shear force. So nothing is there. Shear force equal to 0. Then how is the bending moment diagram, guys? Please look at here. Here I am taking a section here automatically, guys. Please look at here. Then this M, this is clockwise or anti-clockwise, guys? This is a clockwise. As you apply the clockwise moment, how the beam bend? Clockwise only. This is how the beam also bend automatically, guys. So if I keep the water particles here, what is going to happen? Water particles will be falling down. As water particles will be falling down, it is the positive bending moment or negative bending moment, guys? It is the negative bending moment. That's it. But whenever point load is there, there must be vertical step automatically. Everywhere negative bending moment. Are you getting an answer? S, M, continuous everywhere, M equal to constant. That's it, guys. There is a typical bending moment diagram for this. Now let us see another example. Sorry, guys. This is the M. Okay. This is the 2M. Then, can you know the shear force diagram? Shear force diagram is 0 because algebraic sum of the forces everywhere, it is 0 itself. Let us draw the bending moment diagram. I told you, wherever point couple is there, there should be before and after. Before it is 0, after how much? This M will give you negative bending moment or positive bending moment? This M will give you negative. Why? Because a beam will be bending like this, water will be falling down. So negative bending moment means minus M. Now tell me, guys, but here exactly one more point couple is there. So what you have to find out, guys, whenever one more point couple is there, find out before. So before how much, guys? Only M, because this is acting at this. Before how much, guys? Minus M as it is. Same minus M. And after this how much? Tell me, guys. After this minus M plus 2M. Minus M plus 2M. Net value equal how much, guys? Plus M. Are you getting or not, sir? So what you have to do, guys? This is the before point. This is the after point. I just have to join. That's why I told you, guys, whenever point couple is there, there must be a vertical step at the point of application of the couple actually. And this height of the vertical step must be equal to the magnitude of this one, m plus m. Now tell me guys, what is the bending moment at this location? Tell me now, bending moment at this location equal to minus m plus 2m again plus m itself. This will be remains constant actually guys. So this is the positive, this is the negative bending moment. Hope you understand this couple concept guys. Now we will see the another problem guys. Same cantilever beam subjected to two loads P and P at two different places. Here we will solve the problem, or we will draw the SFD and BMD, and we will calculate from the left side. In the previous problem guys, I have calculated from the right side. That's why I kept a minus symbol for shear force bending moment as it is itself. You can ask the question here guys, sir, I want to calculate from the same support side itself. But if you observe, what is meant by shear force? Algebraic sum of the forces before the section. But if you take before the section, what is there here? Support is there. So do you know what is the support reactions they are giving? No. That's why wherever support is there, I have to remove the support and find out the support reactions. That's why I told you guys, whenever cantilever beam is there, always find out the shear force and bending moment from the free end only, because if you calculate from the fixed end, the number of steps are increasing, because you have to find out the support reaction. If you find out from the free end, nothing is there, you can find out very easily. Look at here guys, everybody. So it is a fixed beam, right? How many support reactions are there? Two support reactions. One is vertical force V will be there. Okay, vertical force, second, right, vertical force something R, reaction R will be there. And second thing is, as these two give you the couple, what couple it is giving side is giving the clock couple, there will be a moment of anti-clockwise couple definitely. So one is a vertical reaction R, second one is your clockwise couple. And as it is a fixed support, you will be having three reactions guys, vertical reaction, couple and horizontal reaction. But here horizontal reaction is completely absent. Why guys, tell me? Because there is no horizontal force in the beam. Hope you understand sir. Now look at here. How can I find out the support? To find out the support, same procedure guys, what I told you before itself. What is that guys? I can simply say that your upward force must be equal to downward force, which means that sigma Fy equal to 0. Now tell me, what is upward force here? Upward force is only R. Downward force, how much guys? P plus P. That is a 2P. Next, take to find out the M, I have to take moment about any point guys. Assume this point is A. This point is A. I am taking moment about A. I am taking moment about A equal to 0. How can I find out guys? Clockwise moment must be equal to anti-clockwise moment about the point A. Now tell me, what is the clockwise moment here? Now look at here, about the point A, here what total 4 forces are there. First force is P, second force is P, third force is R, fourth force is M. Look at here now exactly sir. This P will give you clockwise or anti-clockwise guys. This will give you clockwise. Again, this will also give you clockwise. So I am writing in the clockwise direction. Tell me guys first, P into 2L, P into 2L plus P into L, P into L. Next, R. What is the moment due to R about the point A? It is 0. Again, the question is why guys? Because moment means force into distance, right? Look at here, R into distance is, it is acting at the same point, means R into 0, you will get 0 and all. Now, R into 0 will be 0 and M. M is clockwise or anti-clockwise over there guys. M is the anti-clockwise direction. So, I can simply say that M equal to how much guys? The 3PL. Just, it is a 3PL. 3PL guys, 3PL. Now let us see guys. Now I find out the R. R is how much guys? 2P. M is how much guys? 3PL. I got both reaction and bending moment. Now let us see. I want to find out the shear force diagram. I can draw it very easily, guys. For the shear force diagram especially, draw a line. If you are looking from the left side, it is very, very easy, sir, because as it is, however is the force, you can make the same thing itself. Look at here, everybody, guys. Here at x equal to 0, what is the force is there? 2p is there. I can directly make it 2p because vertical 2p itself. Because from the left side, the force is positive, shear force is also positive. But from the right side, the force is positive, shear force is coming negative. That's why I'm keeping my symbol over there. Hope you understand, sir. Now 2p, this value equal to 2p. Next, from here to here, what is there, guys? Here to here, no force is there. As the force equal to 0, then shear force must be equal to constant. I am just making it constant actually. And then again, what is there? P downward force. For that, again I am making P downward. P downward. So here net value become P downward, guys. P will be downward direction. This value equal to how much? 2p. This value equal to P itself actually. Now again, from here to here, what is there, guys? No force is there. It is simply constant again, and again P downward. This is what is there actually, guys. We observe both are, this is also positive shear force. This is also positive shear force. This value is P actually. This value also P, sir. This value also P. This value also P itself. Hope you understand, sir. P, 2p, 2p, everywhere same thing itself actually. Now observe. Suppose if I want to find out the same thing, with the help of normal finding, guys, look at here. You know that V at x equal to 0. How much is there, guys? At x equal to 0, as I am looking from the left side itself, no need to write minus symbol, guys. X equal to 0, what is there? Only reaction R is there. Plus R, upward force is positive, na? So how much, guys? Plus R means as R equal to 2p plus 2p itself. That's why I got it 2p itself. Next, V at x equal to L. How much, guys? At x equal to L, what are there? Tell me, guys, at x equal to L, what are there? R is there. R upward. At x equal to L, how much is there? Minus P. Minus P, which means that, guys, 2p minus p, it is coming as how much, guys? As it is p itself. But here there is one more thing is there, guys. If we observe here, first I went to 2p first and then vertical step of p. I told you already in the procedure itself, whenever point load is there, you are drawing the shear force diagram in the point load. First we have to go to the before the point load and then vertical step. What is the before point load? Just 2p itself. After point load, how much, guys? Minus p. So net value must be equal to p. Here, how much is the vertical step, guys? Here minus p of vertical step. First I have to go to 2p and then minus p means downward, upward, sir. Just downward. So I'm getting net value equal to p. Hope you understand, guys. Now, again, I'm asking one question. If somebody asks you, what is the value of the shear force at x equal to L? How much you tell, sir? This is the place most of the students commit a mistake here. At x equal to L, what is the shear force? Definitely, if somebody asks you x equal to L by 2, force is as it is 2p itself. At x equal to 3L by 2, so 3L by 4, whatever it may be, guys. Between these two, no problem, sir. You can directly get only one value. But whenever there is a vertical step is there, which one you consider? You consider the 2p RP in design. Tell me, guys. I got it P itself. Final value will be P. This is a process of how to draw the shear force diagram. But while designing, which value you will take it? You take it P or 2P, guys. You take it P. Again, the question is why? That is the reason whenever you are finding the shear force at the point load, calculate before and after, take the maximum value. Here before is how much, guys? 2p. Before is 2p. After is how much, guys? P. 2p and p. Which one is the maximum value? 2p itself. Hope you understand, guys. Before 2p, after p. So how to take it? The maximum value is 2p itself. Hope you understand. Now again, guys, V at x equal to 2L. algebraic sum of the forces. How much, guys? Same, R means 2p. Now again the point load is there. First I have to take it before, guys. Before, how much is there? R minus 2p minus downward force p. How much, guys? P minus p. This is the before, and then vertical step, how much, guys? Again minus p. Vertical step, how much, guys? It is coming as minus p. So what I have to do, guys? 2p minus p equal to how much, guys? P minus p. It is going to be 0. Again I'm telling you, finally I have to go to 0 itself. But the problem here is, if somebody asks you what is the value of shear force at x equal to 2L, how much you say, guys? Same thing, because there is a vertical step, is there's a point load is there. You have to take it before. Before, how much is there? Before is how much is there, guys? P is there. After, how much is there, guys? 0 is there. Before P, after 0, because there's a vertical step of minus P is there actually, guys. So what is the maximum value? P. It is not 0. That's why whenever point load is there, definitely there must be a shear force is present. Hope you understand, guys. Don't confuse. Whenever point, don't take the final value. Always take the before and after. Suppose you are looking from the right side, what is going to happen? First you start with 0, and then as force is downward, don't take it downward. Why? Because as you are taking from the right side, I have to keep it minus symbol. Minus of downward is minus p. Minus minus become plus p. So your diagram coming like this actually. 0, it is coming to p itself. Hope you understand, guys. From this you will draw accordingly. That's why you will not have any confusion if you are trying from the left side itself. If you are trying from the right side, just keep minus symbol. Hope you understand, guys. This is a typical way of drawing the shear force diagram. I'm telling you one more time, guys, here. Don't make any mistake. Whenever in the examination, if they ask what is the value of shear force at the location where exactly point load is there, what you have to take it, guys? Just take it before and after, and that maximum value of that value will be the shear force you consider for the design. But definitely while drawing the shear force diagram is easy and all. 2p stepping into p and all, no problem, guys, exactly. Now coming to bending moment diagram. Now observe. M at x equal to 0. Again I am looking from the same left side itself. X equal to 0, how much, guys? What is there? Only M is there. But this will give you negative or positive, guys, a negative bending moment. Why? Because if you take somewhere actually, guys, this will try to bend the beam in the, like water will be falling down like this, guys, because beam is bending like this. This is how the beam. So if I keep the water will be falling down. Water will be falling in negative or positive, guys? Negative. So minus of 3PL at x equal to 0, it is a minus of 3PL. Now tell me, guys, at x equal to L. At x equal to L, how much, guys? Now tell me, at x equal to L, how much is there? Minus of 3PL as it is will be there. Minus of 3PL as it is will be there. Plus, because R, again, one more R is there exactly. This reaction will give you bending moment or not, sir? Yes, that is going to give you the bending moment. How much? This R into distance. R into distance, how much, guys? L. But it is a positive or negative, you tell me, guys? Yes, sir. About this point, R will try to bend the beam upward direction. So water will be stored here. So water is stored means it is a positive or negative? It is a positive itself. R is upward force, right? Upward force means a positive force. Positive force will give you positive bending moment. So I'm getting minus 3PL plus RL. So I can write minus 3PL plus R means how much, guys? It is a 2PL. The value become minus PL. But is there any vertical step is there? No. Why? Because, guys, in case of a bending moment exactly, vertical step will be present whenever there is a concentrated couple is there. Whenever there is a concentrated couple is there. Do you have any concentrated couple? No concentrated couple. That's why minus PL itself. Now, M at x equal to how much, guys? You calculate the 2L value. It must be 0. It must be 0. Whether getting the same thing or not, we will verify it, guys. How much, guys? It is the same thing. Minus 3PL plus R into how much, guys? R into 2L. 2P into L. 2P into L. Again, plus P into, again, positive negative, guys. It is the same. About this point, how much will be coming, sir? P into L. Again, it is coming as 2p into L minus P into L. This is coming as approximately, guys, which will be there, guys? Look at here. 2p into 2. This is a 2p into 2L. Why? Because R into L plus L become 2L actually. So it is coming as minus 4PL plus 4PL will become 0. Sir, please observe, guys. Here force is RP itself, R itself, multiplied by length equal how much, guys? 2L. I'm getting 0 itself. Now let's see how I am drawing, guys. Here how much? Starting from minus 3PL. When x equal to L, how much, guys? Minus PL. When x equal to L, how much? 0. If you observe here, guys, how I have to draw it here? Is it linear or parabolic? It is a linear variation. Why? Because if the shear force equal to constant x power 0, then bending moment must be linear. I just join like this. This is a typical, this is a completely linear variation. This is a completely linear, guys, varying with respect to x. Linear variation. Now, so here bending moment is how much, guys? Minus 3PL, because there is a vertical step is there. Why there is a vertical step, guys? Because there is a concentrate couple is there at the edge. That's why there is a vertical step here is there. Minus 3PL, minus PL and 0. Now tell me, guys, my task is what is the maximum shear force? How much? It should be 2P. Maximum of entire thing itself. 2P. What is the maximum bending moment, guys? Tell me maximum bending moment. M max equal to minus 3PL. I want just magnitude, guys, 3PL itself. Now tell me, guys, suppose if this beam is failing due to shear force, if there is splitting is happening in the beam, which part will split, guys? Tell me. So wherever maximum shear force is there, so from here to here, this entire part is vulnerable for the shear force. Why? Because the entire part having the same shear force value. Suppose, if it is failing due to maximum bending moment, then where it will fail, guys? Where it will fail off exactly? Exactly at the support location. This is the place where the maximum bending moment is there. I can realize this situation like this. Assume I am having a tree. I'm having a tree, guys. Assume I'm having one branch of a tree is there. Okay, you might have played in your childhood, guys. Here one person is hanging here. One person is hanging here. Here one of your friend is hanging here actually. Your weight and here weight will be acting. Then which part most, suppose if it is a failing, which part will be failing, guys? Exactly at this location. Now tell me, this part will fail because of tell me, guys, because of bending moment or shear force. It is failing because of bending moment, because it is not splitting, guys. It is a bending first and then fail itself automatically. Hope you understand, guys. This is a place where this weak point is there. Should be very, very careful. That's why as you are moving towards to this one, you are completely safe. As you go away from it, more deflection will be coming, more bending moment will be coming, the more chance of failing of this branch automatically. We have done with the standard cases of cantilever beam. Now we will see standard cases of simply supported beams, guys. Please look at here. I have a point load. This is P. Assume length equal to L. Then tell me, guys, how will support reactions here, guys? P is shade between two supports. Then this must be how much? P by 2. This must be how much? P by 2. Okay, guys. But please draw the shear force diagram from the left side only for the simply supported beam. But for cantilever beam, always try to draw from where, guys? From free end actually, guys. But here you can draw any side, but for cantilever beam, always draw from the free end so that you no need to find out the support reactions. Okay guys, let's see how I'm drawing the shear force diagram. Please look at here. At this location, load is before 0, starting is 0, after, because whenever point load is there should be vertical step automatically. Before 0, after how much guys? Upward force plus P by 2, that's it. Okay. Now, till this, no load is there. If there is no load, how is the shear force? Constant. Just constant. Okay guys. But again vertical step is there. So before plus P by 2, after plus P by 2 minus P is coming as minus P by 2. Hope you understand guys. So please look at here everybody. So whenever point loads is there, there should be vertical step with magnitude equal to how much guys? It is the, sorry, with this height of this vertical step equal to how much? Magnitude of the force. But and again from here to here, no load. So no load, shear force equal to constant, again plus P by 2. Are you getting or not, sir? Okay. P by 2 minus P by 2 minus P by 2, it went to 0 because after this it becomes 0 automatically. Now tell me, if somebody asks you what is the shear force at this location, you say 0 or plus P by 2 guys? It is the plus P by 2. If somebody asks you what is the shear force at this location, is it minus P by 2 or 0? It should be minus P by 2. Why? Because you have to take it before and after, take the maximum value. Then how is the bending moment diagram guys? Same logic. 0, 0. Now tell me guys, why 0, 0? Because two hinge supports, two rollers, this is the roller support, 0 bending moment. This is also 0 bending moment. Now tell me guys, so how is the bending moment till this? P by 2 into L by 2. Because algebraic sum of the forces, P by 2 into L by 2, it is plus PL by 4. Okay, it become again 0. How do you join guys? Linear variation, no doubt at all. Are you getting it? And I want you to observe one thing guys exactly, but this is not that much helpful, but in some cases it may be helpful also guys. Please look at here guys. Whenever shear force is positive, what is happening for the bending moment? Bending moment diagram is rising. Rising, okay? Whenever shear force is negative, bending moment diagram is falling. Are you getting, sir? Rising or falling. It can be increasing magnitude or decreasing magnitude, don't worry and all. But I want, when shear force is positive, when you are looking from the left hand side, always looking from the left hand side, your shear force should be rising, sorry, your bending moment should be rising. When shear force is negative, your bending moment must be falling. Observe it, that's it. Okay, next thing. Another example guys, we'll take the UDL example. UDL, W Newton per meter, okay, as it is. Okay guys, how is the reaction? Tell me. W L by 2 here, because it is a symmetric, W L by 2 here. Now, how is the shear force diagram guys? Please look at here. Starting is W L by 2. Please look at here. W L by 2. But exactly in the middle, how much guys? Exactly in the middle. Up algebraic sum of the forces, right? Plus W L by 2 minus W into how much? L by 2. It is coming 0. So W L by 2 to 0 again. Next, again here. Upward is W L by 2 minus W L. W by 2 minus WL, it become minus WL by 2. Okay. So, this is how I am joining actually guys. Now look at here. This is positive shear force. This is the negative shear force. Again here also I can make one analogy guys. So, what is that analogy? Whenever here load is, the applied load is what? the applied load is negative load or positive load, guys? Applied load is downward, right? It is a negative load. As it is a negative load, I can say that your shear force diagram must be falling or rising. It should be falling. See, it is just falling like this. Hope you understand, guys. Just falls. Okay, because these things will help you to draw the loading diagram from the shear force diagram. Why I am saying is, guys, in sometimes they give you the shear force diagram, they ask you to draw the loading diagram. So this is the place you are going to helpful. Now tell me, guys, how is the bending moment diagram? Before drawing bending moment diagram, I am asking you to observe one thing. What is that one thing? Till this, your shear force is what? Positive. So bending moment must be rising. Here, shear force is negative, bending moment must be falling. Whether it is applicable here or not, we are going to verify it actually, guys. Now, starting bending moment equal to 0, ending bending moment equal to 0. At this location, I am having a maximum bending moment. How much? Algebraic sum of the moment I can write m x equal to L by 2. I am calculating from this side. This is x equal to 0. This is x equal to L by 2. I am going from left to right. From left I am finding actually, guys, how much? Algebraic sum of the moments. Force into distance. How much? W L by 2 into L by 2. It is coming as WL square by 4. Next, downward force minus, tell me, guys, this force equal to how much? W into L by 2 is the force, but where this acting centroid. So if you take the moment, it is L by 4 multiplied by L by 4. So answer is WL square by 8. This is the WL square by 8. But how do you join? Linear or parabolic? It is a parabolic. Why? Because whenever shear force is linear, your bending moment must be parabolic actually, guys. But again, one more problem is there. That is the slope. It is increasing slope or decreasing slope. But who will help you, guys? Your dm by dx equal to what? V. Whenever shear force equal to 0, slope equal to 0. Identify the location, guys. Which place I am having the 0 force at this location. So slope must be 0. 0 slope means horizontal line. Now tell me, which place I am having maximum shear force? This is the place. This should be vertical. Are you getting an answer? Again, this is the place I am having again maximum shear force. Sirji, don't consider negative or positive. Just think magnitude only. Because while assuming also, I have done the same thing itself. I just assumed magnitude itself actually, guys. So again, shear force is maximum. Slope also maximum. How do you join? Vertical to horizontal. Horizontal to vertical. This is the maximum bending moment. Now tell me, guys, before starting this, I ask you to observe one thing. What is that one thing, guys? Whenever shear force is positive, your bending moment must be rising. Whenever shear force is negative, bending moment must be falling. Is coming same or not, sir? Shear force positive, yes, bending moment is rising. Shear force negative, bending moment must be falling. That's it. Are you getting or not, sir? Now tell me, guys, whenever bending moment rises, shear force must be in the positive side. Whenever bending moment falls, shear force must be in the negative side. Hope you understand, guys. Now we will see the simply supported beam subjected to uniformly varying load. Okay, guys. Now we will see the simply supported beam subjected to uniformly varying load. Okay, guys. Please look at here. But if you look it from the left side or right side, you are having the support actually, guys. So I have to find out the support reaction first. This is RA, this is RB. RA and RB, guys. Please look at here. Upward force must be equal to downward force. So how much is the value, guys? RA plus RB equal to how much? It is downward force, half into W into L. Now take moment about this point. If you take moment about this point, guys, I'm going to get clockwise must be equal to anti-clockwise. What is clockwise? RA into L will give you clockwise, okay, and this will give you anti-clockwise. How guys? Entire force half into W into L multiplied by L by 3. So I'm going to get RA equal to WL by 6. Once you RA equal WL by 6, RB equal to how much? WL by 3. I got RA equal to WL by 6, RB equal to WL by 3. Okay, guys, I got these things. Now, please look at here. I want you to find out the shear force at this location A, at this location B. Are you getting an answer? Now tell me, guys, shear force at location A, shear force at location x equal to 0. This is the place I am writing x equal to 0, and I am going like this. And this is the place x equal to L, because x equal to B means it is a x equal to L location. So I am increasing at any location, the distance is x. And I am telling I am looking from the left hand side. So no need to keep the minus symbol. X equal to 0, how much, guys? RA. That's it. What is mean by RA, guys? W L by 6. Positive or negative? Upward force is positive. Now, at x equal to L, directly I can write RB, or just keep it like this, guys. Algebraic sum of the forces. How much is the algebraic sum of the forces, guys? WL by 6 minus W downward force, WL by 2, because area of this one is WL by 2. How much is coming, guys? Minus WL by 3. Are you getting or not, sir? So what is happening, guys? I find out the support reaction. Once I find out the support reaction, please look at here. So I can draw the shear force diagram like this. At x equal to, please look at here, guys, x equal to 0, it is WL by 6. At x equal to L, it is WL by 3. Now my question is, guys, if you observe here, it is going from positive to positive WL by 6 to minus WL by 3. But how it is going, guys? It's a linear manner or parabolic manner? It must be parabolic. Why? Because if it is a uniformly varying load, your shear force diagram must be parabolic. But again, how is the slope? Slope must be, guys, tell me. Yeah, look at here. The slope is depends upon the intensity diagram, because dV by dx equal to how much? Q. The slope of the shear force diagram is equal to Q, I can write. Now look at here, everybody, guys. At this location, your Q equal to how much? 0. Sir, are the support reaction? I am saying changing load. Q equal to 0 to Q equal to maximum here. So Q equal to 0 means your slope must be 0. Okay. Here Q equal to maximum means slope must be maximum. Maximum means vertical line. So it is changing uniformly like this. It is changing linearly like this. So how is your shear force diagram, guys? Like this. Okay, guys, this is a typical shear force diagram. But if you observe, guys, horizontal to vertical, there is no zigzag portion or anything. It is a smooth curve, guys. Okay. And I want to tell you one more thing also, guys. See, I ask you to observe one thing. Whenever load is positive, your shear force diagram will be rising. Whenever load is negative, your shear force diagram will be falling. Are you getting that or not, sir? Yes. Similarly, when shear force is positive, your bending moment diagram must be rising. When shear force diagram is negative, bending moment diagram must be falling. But here, how is the load, guys? Here, the load here is downward load. Downward load means it is the negative or positive, guys. It is the negative load. Negative load means what happens exactly, sir? Negative load means it is shear force is falling from here to here. Is it falling or not? Yes, falling everywhere. Are you getting or not, guys? Yes, this is how it is falling. And second thing you have to observe here is, guys, please look at here. There are some location you are having shear force equal to 0. What is that some location? I wanted to find out. Are you getting an answer? How can I find out actually, guys? Please look at here. I don't know at some distance x my shear force equal to 0, coming 0 or not, because it is going from positive to negative means it should touch the 0 point definitely. Yes or no? Okay. So assume I am taking some distance at location of x, my shear force equal to 0. Please look at here, guys. At location of x, this is location is x. What is the RA, guys? WL by 6. And what is the height at any location, guys? I told you it is varying from 0 to W. At any location, height equal how much? Wx by L. This we discussed already in the cantilever beam examples actually, guys. Now tell me the shear force at this location. Yes or no? Tell me the shear force about this point exactly. If you find out the shear force at x, tell me, guys, at x equal to upward force WL by 6 minus this force half into entire force, guys, Wx by 2 into x. This must be equal to how much? 0. If you make it 0, guys, you are getting approximately x equal to L by root 3, which means that at this distance of L by root 3, you are having the 0 shear force. Okay. Now let's draw the bending moment diagram, guys. Let's draw the bending moment diagram. Starting will be 0. Ending will be also 0, because two supports here, it is 0. Two hinge supports, it is 0. Now at what location I will be having maximum, guys? Approximately here at exactly L by root 3. It is not always possible, guys. Why? Because dm by dx equal to v equal to 0. When v equal to 0, your bending moment can be either maximum or minimum. Why? Because from theory of calculus says that if y equal to f of x function is there, dy by dx equal to 0 will give you y can be either maximum or minimum. Don't always say that whenever shear force is 0, don't say that bending moment is maximum. It can be maximum or minimum. And d square y by dx square, if you double differentiate, if it is coming greater than 0, your function is a minimum function. If it is coming less than 0, your function is what? Maximum function actually. Okay. For this here, definitely is coming a maximum, not minimum. If you want, you can calculate actually, guys. If you just calculate at this location, please do it. RA into L by root 3 and calculate the same thing. Downward force also calculate actually, guys. Approximately you are going to get, it is a task for you. You try it on your own. It is coming as WL square by 9 root 3. You try this maximum value on your own actually, guys. But how do you join? Look at here. How do you join, guys? You join based on what? Slope of the bending moment diagram. Whenever shear force is high, your slope of the bending moment diagram must be high. slope is high. Whenever shear force is 0, slope must be 0. Whenever shear force is high, again magnitude, slope must be high. How do you join? Maximum to 0, 0 to again maximum. Understood, sir, everybody? Yes. And second thing I want to observe, when shear force is positive, bending moment must be rising. This is the positive shear force, right? Then your bending moment must be rising. Next, negative shear force, bending moment must be falling if you are looking from the right hand side, sorry, left hand side. I am looking from the left hand side only. This is one of the conclusion you have to remember. Hope you understand, guys. Now we will see another problem, guys. Here, same simply supported beam subjected to two loads here. Same load P, load P. Again, here the beam is symmetric about the center. And even loading also symmetric. Beam also symmetric as well as loading also symmetric. Definitely, the reactions here also symmetric. I'm asking the same question. Now tell me, guys, what would be the reactions here? Definitely, this P is taken care by this reaction, this P is taken care by this reaction. So definitely here, guys, reaction is P, reaction is P. Even if you calculated by using sigma fx and sigma fy, and you get the same answer itself. As it is symmetric, I can simply say that same P and P. Now observe how I am drawing the shear force diagram. It's a very easy, guys, as it is. If you observe, upward, P upward plus P upward, guys, and then as there is no force is there between, load must be constant. Load must be constant. Again, P is downward force P. This is the P. This is the P again exactly, guys. Now it becomes 0 because one is upward force, second one is downward force. It becomes 0 again. Now again from here to here, no force is there. Again it become automatically, guys, 0. Again it becomes 0. Again here downward force P. P. Again no force is there. Again constant. This is the typical shear force diagram. If you observe, this is the positive value. This is the negative value. But my question here is, what is the value of shear force at x equal to L by 3? You consider 0 or you consider P? I'm asking the one question, guys. What is the value of shear force at x equal to L by 3? The shear force is 0 or the shear force is P? Which one you consider? The shear force must be P, not the 0. Why? Because I told you, whenever the point load is acting, you are finding the shear force for the design purpose. Find out before and after. Before, how much is there? P is there. After, how much is there, guys? This is the P. After 0 is there. What I told you, guys, I should take it maximum of these two. What is the maximum of these two, guys? Maximum equal to, I can write, it is the P itself. Maximum of P and 0, it is the P itself. Similarly, what is the value of shear force at x equal to 2L by 3? Again, same logic. Before 0, after minus P, it is become again minus P itself. This is how you draw the shear force diagram. Even by using the same algebraic sum method also, you get the same answer itself. Now let us see how can we make the bending moment diagram, sir. If you observe here. Now, bending moment x equal to 0 must be equal how much, guys? 0. Before nothing is there. Definitely P, like P into 0 will be 0. Now x equal to L by 3. How much, guys? X equal L by 3? P into L by 3. But it is a positive or negative? Again it is a positive bending moment. How much, guys? P into L by 3 become PL by 3. It become positive bending moment. Next, Mx equal to how much, guys? 2L by 3. 2L by, tell me, guys, P into 2L by 3 minus P into L by 3. How much will be coming, sir? P into 2L by 3 will give you positive bending moment minus this will give you negative. Why? Because, guys, if you the P will try to bend the beam like this, so water will be flowing down. So P into L by 3 minus P into L by 3. So how much is coming, guys? PL by 3. So x equal L by 3, PL by 3, x equal to L by 3 also PL by 3 itself. Next, m at x equal to L. Without solving, I can able to say it must be 0. If you solve, you should get the same answer. How? Same thing. P into L minus P into 2L by 3 and minus P into L by 3, you get the same 0 value itself. I got the bending moment. Let's see how I am drawing, guys. Look at here. Simple line. Now, at x equal to 0, how much, guys? 0. At x equal to L, how much? PL by 3. At x equal to L by 3, how much? Again PL by 3. This will be 0. If you observe here. From 0 to P by 3, how do you join this up? Assume PL by 3. How do you join these two, guys? Linear or parabolic? Linear variation. Why? Because whenever shear force is constant, your bending moment must be linear variation. So when it is a linear, no need to worry about the slope concept and all. Now at x here to here, observe, guys. One more here. What is the value of shear force? Here shear force equal to 0. Na? Whenever shear force is 0, I can say it is having the constant value here. Shear force equal to 0. I got the same PL by 3. Same thing, sir. No shear force is there between these 2 points. I given in the in the entire context also, guys. Whenever shear force 0 between 2 points, then m must be equal to constant. Why? Because if you observe same thing, dm by dx equal to 0. If integrate, how much I am going to get, guys? Dm equal to 0. If you integrate, m equal to constant. So m equal to constant. Again from here to 0. Hope you observe, guys. This is the place I am having a pure bending moment. Pure bending moment I am having at this location. Here bending moment is varying from 0 to maximum. Again 0 to maximum it is varying and all. Again I am asking the question, guys. Is it always true that whenever shear force is 0, bending moment is maximum? No, it need not be. Hope you understand, guys. Why? Because when shear force equal to 0, bending moment can be either maximum or minimum. It depends upon the second degree of differentiation. If d square m by dx square is less than 0, shear force can be maximum. If it is a greater than 0, it can be minimum. Now, we will start with another interesting problem, guys. I have a beam subjected to concentrated couple at the middle. Assume the length here is L by 2. Again L by 2. But my first question is, guys, is there any support reaction will be there at the support? Will be there? Yes, it is. But how the support reaction will be there, guys, exactly? Because even though there is no force are acting in the vertical direction because of momentum. See, observe, guys, this is a scale is there. Assume this side I'm keeping here, this side I'm keeping downward direction. Assume, guys, now when I try to twist it, I'm trying to twisting like this, guys. When I try to twisting, what is going to happen? I am pushing this one downward direction. This will be lifting upward direction. As this is lifting, what this support will do? Try to pull it downward direction. So indirectly, how will the support reaction? This will try to move it in this direction. As it is moving like this, is going to happen, guys. This will push this support downward. This will pull this support upward direction. Then how it will be, guys? Look at here. As it is moving down here, support reaction is upward RA. As it is moving up, support reaction will be downward RB. Second thing, you no need to analyze this one also, guys. Sir, I don't know, first of all, how the support reactions are upward, downward. Don't worry and all. You take normally as it is upward here, still you get the same answer. This is the beauty of equilibrium equation. Assume I'm taking the upward itself, because from the common sense I know that here support reaction must be downward direction. But assume I don't have the common sense. Still you can able to get the answer just by using the equilibrium equations. Assume, guys, I'm having the RB here. Now definitely upward force must be equal to downward force. Tell me, guys, RA plus RB is the upward force. The upward force must be equal to downward force. RA and RB, I have taken RB also upward direction. Then what is the downward force, guys? 0. Now, take moment about this point. Sigma MB equal to 0, how much I am going to get, guys? This RA about this point, same thing I told you guys. Clockwise moment must be equal to anti-clockwise direction. Anti-clockwise moment. Now tell me, about this point, RA will give you clockwise or anti-clockwise, guys? It will give you, tell me, it will give you clockwise moment. How much? RA multiplied by the distance of, guys, L. That must be equal to, in the entire beam, what is the anti-clockwise moment, guys? This m naught. M naught will give you anti-clockwise. This is m naught. So I can write RA equal to m naught by L. This is the reaction at RA. Now RB equal to how much, guys? I'm getting minus RA. It is minus m naught by L. Why you got minus symbol, guys? Because the direction you have taken is a wrong direction. That's why minus m naught by L. Hope you understand, guys. You can take it upward or downward. Still you get the right answer. If you take it wrong direction, you get the minus symbol and all. Now let us see how I am drawing the shear force diagram for this, guys. As it is. Reference for me. X equal to 0, RA upward, but RA value how much, guys? M naught by L. M naught by L. And second thing, look at here, everybody, guys. M naught by L, but exactly at the middle, is there any vertical force is there? I told you, your concentrate couple doesn't cause any variation in the shear force. It doesn't mean that it will not give you any support reaction. It will give you the support reaction, but it doesn't cause any effect on the shear force. Because I am drawing the shear force diagram now, your M naught doesn't give you any effect on the shear force. Again, the question is why? Why? Because shear force means algebraic sum of the forces acting before the section. But here, this is not force, it is a moment. Before that, no force is there. That's why it is completely constant. Constant. Again, minus m naught by L is coming downward exactly, guys. If somebody asks you what is the value of here, it is a completely positive shear force. So you can ask question, why it is a positive shear force, guys? Observe, this is upward, actual reaction is downward now. Then upward, downward will give you what type of couple? It will give you clockwise couple. If the couple is clockwise, it is a positive shear force or negative shear force, guys. It is a completely positive shear force. I already told you, guys, the shear force is clockwise, it is going to give the positive shear force. If the couple is anti-clockwise, it is going to give the negative shear force. Now coming to the another interesting thing is the bending moment. As usual, guys, at x equal to 0, bending moment must be 0. At x equal to L, bending moment again must be equal to 0. Again, the question is why, guys? Definitely look at here. X equal to 0. Only support is there here, hinge support. Force into distance, RA into 0 will be 0 as usual. Now, x equal to L by 2. How much, guys? RA into how much? L by 2. RA and then how much is RA value, guys? It is m naught into L by 2. M naught into L minus into L by 2, and m naught is there. It is a negative or positive, guys. Just keep it here and try to bend the beam in the downward direction. As it bend the beam in downward direction, it is going to retain the water, or water will be falling down, guys. Water will be, because it is going to bend like this, so water will be falling down. So definitely it is a minus m naught. But equal how much is coming, guys? M naught by 2 minus m naught. Net value will be how much, guys? Minus m naught by 2. Now as usual, m at x equal to L. How much, guys? It must be, because m naught by L into L minus m naught, it must be equal to 0. Here, one thing you should remember, guys, while drawing the bending moment diagram, please look at here. Now, at x equal to 0, no problem. X equal to L also no problem. But when it is coming to x equal to L by 2, I am getting minus m by 2. This is a place where most of the students commit a mistake. What is the mistake they are doing, guys? I already told you. Whenever concentrated couple is there, what we have to do, guys? We have to draw the bending moment diagram before the concentrated couple and then vertical step of the magnitude of the concentrated couple. Hope you understand, guys. So whenever concentrated couple is there, first to consider the bending moment before the concentrated couple. Before the concentrated couple, how much is the bending moment, guys? It is a plus m naught by 2. That's why first I have to go to plus m naught by 2. So plus m naught by 2 and then vertical step of minus m naught. So from here vertical step downward or upward, guys? Because it's a minus, it must be downward. It is a downward actually. If it is a plus, it will be going upward direction. As it is a minus, it will be going in the downward direction. Now, how can you join these two, guys? Linear or parabolic again, guys? It is a definitely linear variation. It's a typical bending moment diagram. It's a completely linear variation. Here I want you to observe one thing. Whenever bending couple is there, please observe there must be a vertical step in the bending moment diagram. That's why whenever bending couple is there, draw the shape of bending moment diagram before the bending couple and then vertical step at the location of the bending couple, with the magnitude of the bending couple actually, and then draw the bending moment diagram. Hope you understand, guys. Now we will start with another interesting question of simply supported beam, guys. Assume I have a simply supported beam subjected to varying load from maximum to minimum, again minimum to maximum. It is varying linearly. Let us see how shear force diagram varies in the entire length of the beam and how the bending moment varies in the entire length of the beam, and we will find out what is the maximum shear force and what is the maximum bending moment. Definitely it can be any problem. First I have to start with finding the support reaction, but here I can find out the support reaction very easily because your beam is completely symmetric. Even loading also symmetric actually, guys. So what does it mean? Assume this is RA, this is RB, RA and RB. Upward load must be equal downward load, but as it is symmetric, this entire load must be equal to half of this load. I can able to say this load must be equal to this load. So how much is value RA, guys? This is the weight of this one. I can able to say what's the entire load, guys? Half into W into L by 2, W L by 4. Similarly, RB also how much, guys? W L by 4. I got these two values. Now tell me, guys, how is the shear force at x equal to 0? Definitely WL by 4. At x equal to L, it must be minus WL by 4. Why? Because as you are looking from this direction, one is upward, one is downward. Upward minus downward will become 0. Again minus downward is there, so it will become minus WL by 4. Or if you're looking from the right side, just keep minus symbol first. As upward force is positive, minus of WL by 4 become as it is minus, guys. Let us see. What is the value of shear force at x equal to, how much, guys? This is as it is WL by 4. And at x equal to L by 2, at exactly the middle point, how much is the value of shear force? Tell me. Middle point, this entire RA, WL by 4, and then minus of this entire weight. How much is the entire weight, guys? Again, WL by 4, it is become 0. That's it. Now coming to the maximum bending moment actually, guys. How can you get the maximum bending moment? Look at here, everybody. M max. At what location I am going to have the maximum bending moment? Tell me, guys. Definitely I know that at the starting, bending moment equal to 0. At the ending also, bending moment equal to 0. Again the question is why? Because starting and ending I am having a hinge support. Hinge support doesn't give you any reaction. That's why 0 and 0, guys. Now Mx, what is the maximum bending moment? Now tell me about this point, right? RA into this distance L by 2, it is coming as W L by 4 into L by 2, W L by 4 into L by 2, and then minus of this force. Why minus, guys? The downward force, negative force will give you the negative bending moment automatically. Minus of this value. How much is minus of, guys? Minus of force into distance. What is this force? Area of this diagram, half into W into L by 2. W L by 4 multiplied by distance. Distance means where it is acting, guys? It is acting at the centroid. This distance equal to L by 3 or 2A by 3, whatever it may be. But 2 into L by 3. L is how much, guys? Here L by 2 by 3. It is because how much, guys? Approximately L by 3 itself. So this distance equal to L by 3, I can able to say. Because 2L by 3 means 2 into L means here how much, guys? L by 2. 2 getting cancelled, by 3 will be there. It is coming as WL square. So WL square by 8 minus WL square by 12. It is coming as WL square by 24 for the maximum bending moment. Let's see how I am drawing the shear force and bending moment diagram for this. Look at here, everybody. I am just taking the reference for me. Reference line, assume this is the reference line for me, guys. Now tell me at x equal to 0, what is the value of shear force, guys? X equal to 0, shear force equal to WL by 4. WL by 4. At x equal to L, what is the value of shear force, guys? It's a minus WL by 4. Even if you look it from the right side as minus of plus, it's coming minus WL by 4 minus WL by 4. But how can I join these two, guys? At the center, how much, guys? Definitely one more thing is there here we are missing. At the center, it must be 0. How can you join from plus WL by 4 to plus WL by 4 to 0, 0 to minus WL by 4? How can we join, guys? Tell me. It's a parabolic variation, right? Why parabolic variation? Because your load is varying linearly. Your shear force diagram must be parabolic. Now tell me again parabolic, guys. How is the slope? We observe at x equal to 0, your load is maximum means your slope must be maximum. Slope must be maximum means vertical line or horizontal line, guys? It is a vertical line. Now at x equal to L by 2, your shear force equal to 0 definitely, but the load also 0. As the load is 0, the slope of the shear force diagram also 0. It's a horizontal line. Now x equal to L, how much, guys? Load is more means the slope must be more. So how can we join, guys? Vertical to horizontal, horizontal to vertical. How do you join smoothly? This is the way you join smoothly. Hope you understand, guys. This is the typical shear force diagram. Now let me draw the bending moment diagram for this, guys. I know that at the starting it is 0. At the ending, guys, at the ending also 0. And exactly at the middle, you are having maximum bending moment. How much? WL square by 24. But how do you join these three? Definitely, it is a parabolic or cubic parabolic, guys. It is the cubic parabolic variation. Why? Because your shear force is parabolic means your bending moment must be cubic parabolic. But how is the slope? We observe, guys, the slope of the bending moment diagram is depends upon the shear force. Wherever shear force is 0, the slope of the bending moment diagram must be 0. If you observe here, this is the place where the shear force equal to 0. The slope of the bending moment diagram must be equal to 0. Here I can say. So 0 slope means horizontal line. Now, if you observe here, this is the place where the shear force is maximum. As the shear force is maximum, the slope of the bending moment diagram must be maximum, means it is a vertical line again. Now again here tell me guys, again here your shear force is maximum, the slope of the bending moment diagram must be also maximum, again vertical line. Now tell me guys, vertical to horizontal, horizontal to vertical, how do you join? Very smoothly. It's a again cubic parabolic variation. So this is the way how the slope is changing. Now tell me guys, what is the maximum bending moment here? WL square by 24. This is what you have to consider for the design of this beam. Now coming to the another question, sir. Same problem, but it just made it ulta guys. Here load is changing from 0 to W, W to 0. Definitely beam is symmetric, load also symmetric actually. So definitely here, how much is the support reaction guys? Half of this weight. What is the half of this weight? W half into, this is L by 2 guys. This is L by 2. So how much is the half guys? Half into W into L by 2. W L by 4 is at this location. Here also W L by 4. Now let's see how much the shear force, as it is at x equal to 0 WL by 4, at x equal to L minus WL by 4, but x equal to L by 2, it must be 0. Why it must be 0 guys? Keep your hand in the middle of the bar, look at one direction. One upward force must be equal to downward force here, definitely. WL by 4 must be equal to this entire downward force. So definitely what is going to happen guys here? Shear force equal to 0 exactly at the center. If I want to draw the shear force diagram, look at here. If I want to draw the shear force diagram, x equal to how much? WL by 4. X equal to L minus WL by 4. This is a WL by 4. Now x equal to L by 2, your value is coming 0. Why? Because before this entire force must be equal to 0. This upward force is equal to downward force. So that's why this WL by 4 minus WL by 4 is coming as 0. But how do you join? This is the place where the trick is going to work guys. Look at here. Here observe, I have to join from WL by 4 to 0. Definitely it is a parabolic variation, because it's a linear means it must be parabolic. Now my question here is guys, how is the slope? Is it a horizontal line or vertical line, or it is increasing slope or decreasing slope? Look at here everybody. This is the place where load is 0. As the load is 0, your bending moment diagram must be having a 0 slope, because the slope of the shear force diagram having a 0 slope, because your shear force having a 0 slope because of your having a value equal to 0. Let me tell you guys one more time. If you observe, the slope of the shear force diagram is depends upon the loading diagram. Whenever the load diagram equal to 0, the slope of the shear force diagram must be equal to 0. That's why 0 slope means horizontal line. If you observe here, this is the place I am having the maximum force. The slope of the shear force diagram must be also maximum. Maximum means vertical line again. Again, this is the place where the load equal to 0. So definitely guys, I am telling you, the slope of the shear force diagram must be also 0, means again horizontal. You observe how it is varying, sir. Horizontal to vertical, again vertical to horizontal. This is how the shear force varies. Observe guys, two different cases here. Here how is the shear force is varying? If you observe here, slope is decreasing from here to here, again it increasing. But here the slope is increasing from x to L by 2, again it is decreasing and all. Hope you understand. Now let me find out what is the maximum bending moment. M max. M max equal to how much guys? It is the exact at the center. Now tell me, what is the maximum bending moment? Force into distance, W L by 4 into L by 2 minus of this force into distance. This force is how much guys? Again W L by 4 into distance. As it is acting at the centroid, guys, exactly, this distance equal to L by 3. But here L is how much, guys? This L by 2. It has become L by 6. This distance equal to L by 6. Now tell me, if you make it here, I am going to get, guys, W L square by 12. I am going to get the answer. Now, how can I join, guys? X equal to 0, your bending moment equal to 0. Why? Because this is the place where I am having a hinge support. Bending moment must be 0. At x equal to L, again it is 0. But x equal to L by 2, I am having the maximum bending moment. How much is that value, guys? W L square by 12. But how do you join? Linear, parabolic, or cubic parabolic? It is the cubic parabolic variation. But how is the slope? If you observe, guys, x equal to 0 exactly, guys, your shear force having the maximum. This is the maximum value of shear force. So how is the slope of the bending moment diagram? Maximum is vertical line. This is the place I am having the 0 shear force. So the slope of the bending moment diagram must be equal to 0. 0 means again horizontal. Again, this is the place I am having the maximum shear force. I am having a vertical line. How do you join these three, guys? This is the way you join these three: vertical to horizontal, horizontal to vertical. This value equal to W L square by 12. If I want to compare which beam is going to fail first, guys? Which beam is going to fail first? This beam or this beam? This is the one which is going to fail first. Again, the question is why? If you observe, guys, maximum bending moment W L square by 12, approximately I can able to say, guys, this is 2 times the maximum bending moment of this one, I can say. Hope you understand, guys. If we just make the load, this is going to fail first compared to this one, because it is having a 2 times of maximum bending moment of this previous problem. I can able to say, guys, W square by 12, W square by 24 for this. Now we will start with the another interesting question, guys. It is a typical same simply supported beam subjected to UDL and point load. Before solving this question, guys, first we have to find out the support reactions. Assume this is the A, this is the B, this is the C. Assume, guys. Here how many reactions will be there, guys? RA will be there, RA, and RB will be there. Assume, guys, upward force must be equal to downward force. How much will be there? RA plus RB will be the upward forces. Tell me the downward forces, guys. 400 into 8. How much, guys? 3,200. 3,200 plus 6,000. So how much will be coming, guys? Approximately it is coming as 9,200 is the RA plus RB. Why? Because, guys, 400 into 8, it is coming as 3,200 plus downward force 6,000. Now if you take moment about B, guys, sigma moment about B equal to 0. If you observe, clockwise must be equal to how much, guys? It is the anti-clockwise. If you take moment about this point, tell me, RA, it is the reaction at A. This is the RA, guys. This is the RB. RA into how much, guys? 16 will give you clockwise, and 400 into 8, force is how much? 400 into 8 will give you anti-clockwise, because about this point it will try to rotate in the anti-clockwise direction. And 400 into 8 is the force. I want distance, right? It is acting at the centroid, so 8 plus 4, 12. 12 plus, again 6,000 will acting in the anti-clockwise direction. 6,000 into 8. Then approximately RA is coming as 5,400. 5,400, guys. Then if RA is 5,400, RB must be equal to how much, guys? RB must be equal to 3,800. So I find out the support reaction because 5 plus 3 equal to 8, 8 plus 4 equal to 12, it becomes 9200 itself. Now observe, I got the support reactions. Let me start drawing the shear force, guys. Observe, guys. At x equal to 0, how much is the shear force? RA. RA equal how much, guys? 5400. Plus or minus, it is as it is plus itself. This is a 5400 is the shear force at the location A. Now I want the shear force at the C. See how I am finding, guys? V at C. At C means how much? X equal to 8. How much will be there, guys? Upward force. RA how much? 5400 minus about C, 400 into how much? Minus 3200 and then plus 6000. Plus 6000. It is coming as how much, guys? It is a 2200. I can write 5400 minus 3000 is coming as 2200 plus, I'm extremely sorry, sir, this is not minus, this is the plus. Why it is plus, guys? Please tell me why it is plus, why it is minus, guys? Because the force downward is a negative force. Negative force will give you negative shear force itself, minus 6000. So the net value is coming as approximately how much, guys? 5000, sorry, is coming as 3800. 3800 is V at x equal to 8. But observe here. At x equal to 0, 5400, and at x equal to C, how much is the value, guys? 3800. But how do you join these two? Again, there is a small thing you have to remember, guys. What you have to remember is at x equal to C, at x equal to 8, there is a vertical step is there. Now tell me, whenever vertical step is there, what you have to remember, guys? There must be a point load exactly at the vertical step, exactly at the location C. How much point load, how much vertical step should be there, guys? 6000. That's why I told you, whenever you are drawing shear force diagram at the location where the point load is there, first you have to go to shear force before the vertical step, before the point load, and then vertical step of minus 6000. Now tell me, guys, before the point load, how much is the shear force, guys? 2200. I can write this is the 2200. Now how can I join these two, guys? 5400 to 2200. Linear or parabolic? It must be linear variation. Why? Because your load is constant, means exactly, guys, your shear force must be linear. The load is UDL, shear force must be linear. Again, from 2000 to 6000 vertical step is there. If you take it minus 6000, it becomes 3800. Now again, at x equal to B, it must be, at x equal to 16, it must be 3800. That's why your RB also coming same 3800. This is the minus, this is the plus. But I'm asking the question, guys, what is the value of shear force at x equal to 8? Which one you consider for the design, guys? Tell me. At x equal to 8, how much you consider? Definitely at x equal to 0, no confusion, how much? 5400. At x equal to 16, no confusion, like how much, guys? 3800. But x equal to 0, how much you consider? How much you consider, guys? Is it you consider 2200 or 3800? It is a negative or positive? I just consider the magnitude only. Why? Because negative and positive, these conventions given for my convenience itself. So now tell me, you consider 22 or 38, guys? It is a 3800 you consider. That's why I told you find out before and after. Before 22 and after 8, definitely guys, we consider the maximum value for designing the beam for the shear stress. Now coming to bending moment guys, look at here. What is the value of bending moment at x equal to 0? Without thinking 0, because it is simply supported actually guys, hinge support is there, x equal to 0 0 and x equal to L how much guys, again 0, again it is a hinge support itself. Now x equal to 8, x equal L means 16 guys, here L means 16, but I want x equal to 8. Please tell me guys, is there any concentrate couple is there? No, there is no concentrate couple is there, so I can directly join over there. But x equal to 8, I have to calculate first how much RA into 8. What is RA guys? It is the 5400 multiplied by the 8, because the force into distance. Next, again this force, what is this force guys? 400 into how much? 400 into 8 is the force, but is acting exactly centroid. Distance equal how much guys? It is the 4 itself. Now tell me, it is a negative or positive? Because about this point will give you the negative bending moment. The minus I can able to say. So this value is coming as guys 30,400. I'm getting positive itself actually. Now my question here is, how can I join? I'm drawing this, I'm overlapping with the same shear force diagram guys. Observe, at x equal to 0 0, at x equal to L 0, at x equal to, at this location how much guys? 30,400. 30,400 newtons, like a Newton meter guys. It's a Newton meter, because these dimensions all are in the meters only. Now how do you join? I'm giving you almost 10 seconds of time. Think about it. How do you join 0 to 30,400, again 0 to 30,400 guys? I'm giving you 10 seconds of time. Please think about it. Yes, same thing guys. Here, as here shear force is linear variation, so shear force is constant, your bending moment must be linear variation. Definitely 30,400 to 0 must be linear variation. But 0 to 2,200 actually guys, 0 to 30,400 linear or parabolic? It must be parabolic. Why? Because your shear force is linear, your bending moment must be parabolic. But tell me guys, how the parabolic slope? It is increasing slope or decreasing slope? How it is? Same logic. Between these 2 points, which point I am having the maximum shear force? 5,400. So it has to come with the vertical. Which point having a minimum shear force? 2,200. It must be having something horizontal. How can you join these two? Vertical to horizontal. That's it. This is a typical shear bending moment diagram for this typical kind of figures actually guys. Now tell me, for design, what is the maximum bending moment here guys? 30,400. This is the maximum bending moment for design. What is the maximum shear force guys? It is a 2,200. Hope you understand guys. These kind of problem they ask multiple number of times in the GATE, ESC competitive exams. Should be very very careful. Only one thing you should be careful guys, whenever point load is there, should be vertical step in the shear force diagram. Whenever point moment is there, there should be vertical step in the bending moment diagram. Now we will learn how to draw the shear force and bending moment diagram for the overhang beam actually guys. Now let us see, for any kind of beam, the first step is what? For finding the support reactions. Let's see. Here how many supports are there? 2 supports are there. So assume this is A, this is B, this is C, this is D. Let's check it guys. Assume this is RB and this is RC. Now observe, how can I find out the support reactions guys? Definitely with the help of equilibrium equations. Let's see now. Definitely sigma Fi must be equal to 0, which means upward force must be equal to downward force. Upward force must be equal to downward force. Tell me what are the upward forces are there. This is RB plus RC equal to downward force. What is the entire this force, guys? 100 multiplied by 2 plus 2 plus 1, 5. It is 100 into 5. 500 I can say. Now, I want to find out moment about B or moment about C. Let us see. I am finding moment about C equal to 0. What does it mean? About point C, I will take all clockwise must be equal to anti-clockwise direction. Let us see now, guys. About point C, RB will give you clockwise or anti-clockwise, guys. About point C, it will give you clockwise direction. How much? RB multiplied by distance is 2 meters. That must be equal to, look at here, this force, where this force acts, guys, at the centroid. Total distance is 2 plus 2 plus 1, it becomes 3 meters, it will become 5 meters. Now, where it will act, guys, it is exactly the center, that means 2.5. I can say that here, I can say this must be 2.5 meters. Again, this must be 2.5 meters. So, where it is going to be acted, guys, tell me? At 2.5 meters. So, total value equal to how much force is? 100 into 5, 500 multiplied by distance between these two. Total distance is 2.5. This distance become how much, guys, automatically? 1.5. This is a 1. This should be 1.5. This 1.5. Then RB is coming as how much, guys? It is a 375. RB is coming as 375. Now let's check at the how much is the value of RC. RC equal to how much, guys? 500 minus 375. It is coming as 125. Let's see how we are drawing the shear force diagram. If you observe, guys, assume this is the scenario. This is a reference for me. Now observe. At x equal to 0, what is the value of shear force, guys? At x equal to 0, shear force equal to 0 itself, because before no force is there. Now, tell me, guys, I want finding for the shear force. I am finding for the shear force V at x equal to 0 because I am moving from this direction, guys. This is the direction of x I am considering. Now, V at x equal to 2. At x equal to 2, how much, guys? X equal to 2. About this point, how much? It is something downward force side. Downward force is negative or positive, guys? Negative. Minus this force. This force, how much? 100 into 2. It is a 200. Minus 200 actually. But at the same location, what is this? A vertical step of RB is there. So, what is the value of RB, guys? Plus 375. Plus 375. So, it is coming as net value is 175. But observe, guys, this is the place you should be very, very careful. Why? Because x equal to 2, net value is coming 175 only. But there is a vertical step of RB is there, means first you have to go to minus 200 first, and then vertical step of plus 375, your value become 175. Hope you understand, guys. Now, V at x equal to, tell me now, x equal to 4. X equal to 4, how much is coming, guys? Till 4 minus of 100 into 4. So, minus of 500 I can say. So, minus 400, guys, sorry. So, 100 into 4 become 400, and then plus, what is this value, guys? RB is there. RB is how much? 375, and then there is a vertical step is there. Upward force means positive or negative. It is again positive. What is this positive force, guys? It is the RC is coming as 125. Observe how I am grouping these values, guys. I am grouping these together. So net value equal to how much, guys? Here it is coming as minus, observe, minus 25 plus 125. It is coming as how much, guys? 100. Net value is coming as 100. Observe, guys, why I grouped these two. I told you, whenever there is a vertical step of RC is there, find out the shear force before RC. Before RC, how much is there, guys? Minus 400 plus 375. So before RC is minus 25. After RC, minus 25 plus 125 equal to 100. Now tell me, how much magnitude I have to draw the vertical step? It is exactly 125. Now we will find out what is the value of force at x equal to how much? 5. Look at here, everybody, guys. X equal to 5. Before this, all downward force, how much? 100 into 5, it is coming as minus 500. And we are having upward force, RB, how much? It is a 375. And again upward force, RC, how much? Plus 125 must be equal to how much? 0. Or even if you look it from the right side, nothing is there, it must be 0. Let's see how we are drawing the shear force diagram. Observe, guys. Definitely, this is the place it is 0. This is the place it is 0. Now let's see, at x equal to 2, what is the value of shear force? 175. This is the place you make a mistake, guys. Don't go to 175. Assume the 175 actually, guys. 175. But don't go to 175 directly. Why? Because there is a vertical force is there. There is a vertical force is there. There should be a vertical step in the shear force diagram. Let's see, guys, what we have to do. First, we have to go it before the RB. Before RB, how much? Minus 200. So, I have to go to minus 200 first. Assume this is the minus 200. First, I have to go to minus 200 and then vertical step of plus 375. Assume 200 plus 375. So if we add minus 200 plus 375, the final value is coming as 175 itself. Next, again, how do you join from 0 to minus 200, guys? Linear or parabolic? It must be linear because load is distributed load. Let's see. So 0 to minus 200, it is the linear variation. Now again, at x equal to 4, how much is the value, guys? Observe, it is the 100. Again, this is the place you are going to commit a mistake if you don't understand the concept, guys. Most of the students directly join from 175 to 100, but is absolutely wrong. Again, why, guys? Because at x equal to 4, first I have to go to sum of the algebraic sum of the forces before 4. Before 4, how much? Minus 25, and the vertical step of plus 125. First, I have to go to minus 25. First, I have to go to minus 25. So, and then vertical step of, there is a vertical step of, I can able to say, guys, vertical step of 125. So, net value is coming as 100. Now, observe how I am joining, guys. 175 to minus 25, and then let me make little more distance, guys, so it is easy for you to understand. Let's see. I am keeping somewhere over here. This is a reference for me. This is the place where I have to go to minus 25 first, and then this is the place where 100 is there. So total travel distance is how much, guys? 25 plus 100 become how much? 125. There should be 100. So I have to go to minus 25 first. Again, 100 to 0, again linear variation, guys. Why? Because again this is a distributed load. Now observe, guys, whenever I told you already, whenever there is a point load is there, there must be a vertical step in the shear force diagram. Observe, two vertical steps because there are two point loads are there. There is a point load can be reaction, point load can be applied load, anything guys, exactly, don't worry about it. Whenever point load is there, there must be a vertical step here. But look at here, if somebody asks you directly, they don't ask you to draw the shear force diagram, but if they ask you to find out what is the value of shear force at x equal to 2, at x equal to 2, what is the value of shear force? It is 175 or minus 200 guys. What is your answer? It must be 200, not 175, not minus 200. You have to take only magnitude guys. The maximum of these two, maximum of 175 and 200, how much guys? Its value is 200. Now tell me at x equal to 4, what is this value guys? Tell me 100 and minus 2, how much you have to consider guys? It is a 100 value you have to consider for the design of this beam for the shear stress. Now if you observe, this is the place your shear force having a 0 value. Shear force having 0 value. Can you please tell me this distance? How can we find out this distance guys? How can we find out? Same simple tricks are. The height is how much I can able to say. The typical diagram. The typical diagram guys, observe. This height equal to 175, this height equal to I can say 25, this angle theta, and total distance equal to how much guys? Assume this is the x distance, then this distance must be equal to how much? 2 minus x, because this distance between these two is 2, then this distance become how much? 2 minus x. Now find out how much is the value of x guys. Same, theta is same actually. If theta is same, tan theta 170 by x equal to 25, positive or negative I don't care because I want the magnitude. I am just finding the angle guys. So 25 by 2 minus x, if we substitute, I am going to get x equal to 1.75. I am getting 1.75 is my value of x actually, which means that this is 1.75, this is 2, again this is the 1 itself actually. Now we will draw the bending moment diagram guys. As usual, we got RB equal to how much? It is coming as 375. R is how much guys? We got it 125. Okay, we have completely finished the shear force diagram. But there is one thing I want you to observe here guys. In previous problems, what we have observed guys, in most of the cases, whenever shear force equal to 0, your bending moment is coming maximum. But let us check whether it is coming the same thing in the problem, or whether it is repeating or not repeating. We will check it now itself guys. Let us see. First I am finding what is the value of bending moment at x equal to 0. At x equal to 0, 0. At x equal to 5, also 0. Why? Because guys, at x equal to 0, here no load is there, before that force into distance. Again here x equal to 5, I am looking from the right side so for easy purpose because nothing is there here, so definitely it is coming as 0 itself. Here it is 0, here it is 0 itself. Now m at x equal to 2, x equal to 2, how much guys? X equal to 2, it is coming as 100 into 2 into 1. 100 into 2, it is a 200 into distance, how much guys? Just 1. How much is coming guys? 100 into 2 into distance is 1. It is coming as 200, but it is a minus or positive guys. You should be very, very careful. This try to bend the beam like this. So when water is, when I keep the water will be simply flowing down. As the water is flowing down, I ask you to consider the negative bending moment, or it is a negative force, right? As it is a negative force, it is going to give you the negative bending moment, because downward force is a negative, so it is going to give you the negative bending moment. Now m at x equal to how much? X equal to 4. x equal to 4, observe guys, I can look from this side or I can look from this side, because I told you bending moment means the algebraic sum of the forces. It can be either LH side or R side, either right hand side or left hand side. But here I can easily find out from the right hand side. Why? Because guys, only this much small amount of the force is there. If you look at from the left hand side, I have to find the moment of this force about this point as well as moment of this RB about this point also. You will get the same answer only, but I am looking from the right hand side. How much is coming, sir? The same thing, 100 into 1 acting a distance of half, minus again 100 into 1 into 0.5. How much is coming, guys? It is coming as minus 50. But observe, no sir, I will look at from the left side only. Look at here, it's up to you. How much is coming, guys? It is coming as 100 into 4 minus 100 into 4 into 2, because acting at the centroid, and then plus 375 into this distance is how much, guys? 2. You will get the same minus 50. That's why I told you, whether you're looking from the left or right, you get the same value. But I want to find out another location also, guys. Now I want to verify whether the shear, whether the bending moment here is coming either maximum or minimum. Let us see it, guys. M x equal to this distance equal to how much, guys? So 2 plus 1.75. 2 plus 1.75 means x equal to 3.75. X equal to 3.75. How much is coming, guys? Let us observe. X equal to 3.75. I can able to say 100. Force equal to 100 into distance how much, guys? 3.75. So this is the force. 100 into 3.75 is the force. What is the distance? 3.75 by 2 will give you negative bending moment. As a downward force is the negative, it is going to give you the negative bending moment. And then we are having RB upward direction. RB upward is positive or negative, guys? It is a positive value itself. RB upward is positive. How much is going? I'm going to get, guys, positive 375 multiplied by how much? 2. So you are going to get how much, guys? It's coming as minus 46.8. I am going to get minus 46.8. Let us check how I am drawing the bending moment diagram. Before drawing the bending moment diagram, I am asking you to verify, is there any possibility of vertical steps in the bending moment equation? Please check it, guys. Is there any possibility? The answer is no, it is not possible. Why? Because to get a vertical step in the bending moment diagram, there must be a point moment actually. There must be a point moment. But is there any point moment is there in the beam? No, there is no point moment is there. So there will be no vertical steps in the beam. Let us draw it, guys. Let us draw the bending moment diagram. Definitely. X equal to 0, how much, guys? 0. X equal to how much? 2 plus 2 plus 1, 5, how much? 0. Now observe. Now x equal to x by 2, how much? Minus 200. It is coming as minus 200. Again, at x equal to 4, it is coming as minus 50. And x equal to 3.75 is coming as minus 46.8. This is the place I am going to have a minus 46.8. Assume this point having value of minus 46.8 actually. Now let us see how I am joining 1, 2, 3, 4, 5. Total 5 points I want to join. Tell me, guys, how we have to join here? Is it linear or parabolic or cubic parabolic, guys? It must be parabolic. The question is again why? Because your shear force is a linear variation, your bending moment must be parabolic variation. Let us check it, guys. But how is the slope here? Is it increasing slope or decreasing slope? Again, it depends upon what, guys? It depends upon how is your shear force magnitude. If you observe x equal to 0, what is the value of shear force, guys? 0. It is 0 means it has to start with a horizontal line exactly. Now, at x equal to minus 200, definitely at x equal, I can able to say, guys, at x equal to 2, your shear force having the maximum value of 200. So, it must be vertical line or horizontal line, guys, approximately vertical line. Again, observe, guys, again it is coming 175. So, it is not having the same slope from here to 46.5. Yes. Again, this is the place it is having a 0. So, it must be 0. Again, it is having something minus 25. So, minus 25, something like this. Again, 100. It is 0 means again horizontal line. Observe, guys, I'm telling you, whenever shear force is there, it should be something near to the vertical. Now tell me, 0 to minus 200, minus 200 to minus 46.8, minus 40.6.8 to minus 50, and then minus 50 to again 0. This is a typical shear force, typical bending moment diagram. Hope you understand, guys. So this slope concept, it should be clear by now. Always think, guys, whenever shear force is maximum, I will be having a maximum slope. Whenever shear force is minimum, I will be having a minimum slope actually. Hope you understand, sir. Now we will see how to find out the support reaction for the beams if it is having a internal hinge. Let us see, guys, what is mean by internal hinge. Internal hinge means, assume this is the one beam, this is the another beam. If it is having a internal hinge means it doesn't transfer any moment. It doesn't transfer any moment because you know that hinge doesn't give you any support reaction for the moment. So definitely m equal to 0 for the internal hinge. Now let us see, guys. Assume I'm having a two cases, case 1 and case 2. We'll start with the case 1. Here the bar AB and beam AB and beam BC, guys. Here the beam is fixed at the point A. Let us see, guys. This is the beam AB. This is the beam BC. Now what is happening now? Now load is acting at the point P here. Assume the load is acting at this location. The moment when the load is acting here, what is happening, guys? Here, if you observe, the scale is just rotating. As the scale is rotating, so what is the force acting in this one? Nothing, because it just give you rotation. It just give you rotation. At the same time, as it is rotating, it doesn't transfer any moment in the beam AB. Why? Because as the load is acting on the BC, it is not transferring any moment, it is not transferring any force. So definitely moment equal to 0. The stress in the bar AB also 0. Why? Because as the load is acting, my hand is not feeling any pain. The pain means stress, the pain means the stress. I already told you, guys. Now coming to second scenario, assume same thing, the beam AB, the beam BC. This is a hinge here, this is also hinge. Observe, guys, this is also hinge actually, it is rotating about this point. Now observe, this is a beam AB and beam BC. Now the load is acting somewhere at this, some load P is acting at this location. Observe, guys, as the load P is acting, what is happening, guys? Exactly, yes, it is not rotating because we both are giving the resistance for that. My hand and the other hand giving the support reaction here. That's why as the load is acting, I can able to feel the pain in my hand because the moment is transferred, shear force also transferred. That's why the stress will be definitely developed in my beam AB. But my task is how to find out the moment here and how to draw the shear force and bending moment diagram for the beam AB and beam BC. Now let us see, guys, how can we find out? Let me draw the free body diagram of beam AB. this is the FPD of assume beam BC. What is happening guys here? Look at here everybody. There is a hinge support reaction RC will be there. Now this is the RA will be there as well as moment will be there here. Moment will be there. Now observe what is happening, sir. This BC tried to push the beam AB downward direction. Beam AB tried to push the beam BC upward. That's why this is the place where I am having resistance of the hinge here. Again, same thing will be happening, opposite direction, resistance of the H. Hope you understand, guys. These two give you action and reaction. Let us see. How can I find out these two, guys? This is the place where the load P is acting. This is the place where the load P is acting, guys. Now, upward force must be equal to downward force. Tell me what are the upward forces, guys? RH plus RC must be equal to P. But load P is acting exactly at the symmetry. So, definitely RH equal to how much, guys? RH equal to P by 2 and RC also how much? It is P by 2 itself. Now I got it, sir. Now I want to find out what is the value of RA and what is the value of M. How can I find out? Definitely this beam AB is in equilibrium. As the beam AB is in equilibrium, let us see, guys, how I am finding upward force must be downward force. Definitely RA must be equal to RH. RH is how much, guys? This is usual P by 2. So definitely RA equal to how much? P by 2, because upward force equal to downward force and moment. How much is this moment must be, guys? Take moment about this point. If you take moment about this point, clockwise must be equal to anti-clockwise. What are the clockwise moments here? RH into L. Assume this length equal to L. So P by 2 into L is the clockwise moment. What is anti-clockwise moment? M. So this must be equal to how much, guys? PL by 2. Now, so what is the maximum bending moment in this beam, guys? It is the PL by 2. Let us draw. How can I draw the shear force and bending moment diagram for this? Let us look at here, guys, everybody. If you look at here, I'm just drawing the SF and BM diagram for this. At x equal to 0, is in this place x equal to 0, this x equal to how much? L 2L. I can able, this is the point is x equal to 2L, or this is the point A, this is the point B, and this is the point C. Assume this point is the D, assume, guys. So this is the point D. Let us see how shear force is changing in the entire beam AB. Now let me find out, guys. Definitely x equal to 0, how much is there? P by 2. So I can simply able to draw it like this. P by 2 is there. This is the value of P by 2. Now at x equal to, definitely, guys, at x equal to L, at x equal to L or x equal to B, I can have this point B. How much is there, guys? No force is there. That's why straight line. Again, there is a P by 2 downward direction. I can able to say P by 2. No, guys. If you observe here, when you're drawing the shear force diagram for the entire beam, this is the force, internal hinge force here. One is downward, one is upward. This is net force become 0 when you consider the entire beam. So there will be no extra force is there. So you will continue the shear force till the point D. Why? Because, guys, when you taken separately, it will be there actually. When you taken combinedly, here one is upward, one is downward, one is upward, one is downward, the net force becomes 0 here. Now let us see, guys. At the point D, what is going to happen? Again, there is a downward force of how much? P is there. So this is the P by 2 here plus P by 2, and the downward force P means it is become how much, guys? Minus P by 2 is there here. Minus P by 2, and then here again P by 2. This is the typical shear force diagram. This is the positive shear force. This is the negative shear force. Even if you observe from this direction, see guys, again, if you look at from this here, the support reaction is how much? Support reaction is just P by 2 itself. But as you are looking from the right side, I have to keep the minus symbol, minus of P by 2, it is coming as minus P by 2 itself. Let us see how to draw the bending moment diagram. If you observe guys, at x equal to 0, what is the value of bending moment? It is just minus PL by 2. Why? Because it is giving the negative bending moment. I am starting with minus PL by 2. Now tell me exactly at the internal hinge, what is the value of bending moment? It must be 0. Whether it is coming 0 or not, shall we verify? If you observe guys, take moment about this point. If you take moment about this point, it is coming as P by 2 into L positive and minus PL by 2. PL by 2 minus PL by 2 is coming as it is 0 itself. That's why it is coming 0 here. Next, at x equal to, I can able to say guys, this is the point. How can we find out easily? I can find out easily from the right side. Observe guys, this is the force is how much here? P by 2 is there. P by 2 into L by 2, how much I can able to say guys? It is a PL by 4 I can able to say. PL by 4 is there here. Assume this is the place PL by 4 is there. How can I join guys? Just linear variation. PL by 2 to 0 and then PL by 4 and then again 0. This is the negative shear force, the negative bending moment. This is the positive bending moment. I want you to observe only two things guys here. Whenever internal hinge is there, there must be moment must be equal to 0. These kind of questions they ask multiple number of times in the GATE, ESC as well as AEE, almost ISRO, all the competitive exams guys. And remember, whenever internal hinge is there, it doesn't transfer any moment reaction. It can transfer only force if it is having a support reaction at the end. Hope you understand guys. And please be observed here. Here bending moment is changing from negative to positive. This is the place as we discussed already. Bending moment is coming as 0. Now we will solve another interesting problem for the internal hinge. Look at here guys. It is the same fixed beam. I am having an internal hinge of between AC and CD. Let us see guys, there is a uniformly distributed load 200 Newton meter is acting in the entire beam AC and CD. First task is we have to find out the support reactions. Look at here guys. So I have divided the beam into AC and CD because this is the place where the internal hinge is there. If I want to draw the free body diagram, look at here. Because it is a hinge support, one reaction will be there, RB will be there here, and at the hinge, RC will be there, and entire downward force. How much is the entire downward force, guys? 200 multiplied by the 6. 200 into 6 actually, and it is acting at the centroid because entire distance is 6. It is acting exactly 3 meters from the point C. Now observe. How can I able to find out? Upward force equal to downward force. What does it mean now? RB plus RC equal to how much? It is 1200. If you take moment about the point C, how much I'm going to get, guys? It is RB into 4 will give you what, guys? Will give you clockwise moment, and 200 into 6 into 3 will give you anti-clockwise moment. How much? 200 into 6 into 3 will give you anti-clockwise moment. Now tell me what is the value of RB, guys? RB is coming as, I can say, this is 4 times 5. It's coming as 900. It's coming as 900. Then RC equal to how much, guys? As usual, RC equal to 1200 minus 900. It is coming as 300. That's it. So I got the RB and RC. Now, how to find out RD? As I already know, guys, RC equal to how much? 300. If you observe, guys, why RC is upward direction? Why RC is upward direction, guys? When the load is acting, beam CD try to pull the beam AC upward, and beam AC try to pull the beam CD downward. That's why here reaction is upward, here reaction is downward. Now look at here. Take moment about that point. How much I am going to get, guys? 300, I can able to say 300 into, I'm taking moment about this point, guys. 300 into 2 is a anti-clockwise direction, plus 200 into distance equal how much, guys? 200 into 2, acting at a distance of 1 meter. This is a 1 meter, I can able to say, plus 400 into 1. That must be equal to clockwise. Clockwise how much, guys? This is the M. So this M value equal how much, anybody, guys? It is coming as 1000 Newton meter. 1000 Newton meter. I got the moment about this location. Now tell me, how can we get the RD, guys? Upward force equal to downward force. Upward force equal to downward force. Tell me what is upward force? RD. Then what is the downward force, guys? 300 plus 400. It is coming as 700. Now I got it completely. Support reactions. So this is the place they ask multiple number of times in the various competitive exams. Most of the time, they don't ask you to draw the SFD and BMD for the internal hinge problems. Mostly they used to ask what is the support reaction for the internal hinge problems. You have to be very, very careful. At the internal hinge, there will be no moment reaction will be there. Now look at here, I got this one. This RB equal to how much, guys? It is 900. RD equal to how much? It is 700. Your couple, how much is the couple, guys? It is coming as 1000 Newton meter. Can we draw the SFD and BMD for this? Yes, definitely. First we will draw the shear force diagram. I assume this is the reference for me. This is just reference for me, assume for time's sake. Now, observe. At the point A, shear force must be equal to 0. Why? Because before point A, no force is there, it must be 0. Next, at the point B, observe, the force is downward force, right? The how much is the downward force? Before this, how much is there, guys? 200 into 2, 400. It is a minus 400 because downward force. Assume this is the point, minus 400 is till this. But how do you join? Linear variation as it is itself. Again, there is a vertical step of 900 is there. So minus 400 plus 900, it is coming as, upward is coming as plus 500. This point is plus 500. Now observe. Exactly at RC, at this location, guys, how much is your shear force, guys? Algebraic sum of all the forces. How much is the algebraic sum of all the forces, guys? At C, V at C equal to how much? Entire downward force minus 200 into how much, guys? 6. 200 into 6, and upward force plus 900. It is coming as minus 300. Sorry, 900. So 12, it is coming as minus 300 itself. We observe, guys, at the point C, its value is minus 300. How can we join these two? This is the way we join. But observe, there should not be any vertical step at the point C. Why? Because definitely at the internal hinge reaction is there. On the bar AC, it will give you upward. On the bar BC, it will give you downward. Upward, downward together, it is become 0. So there will be no net reaction will be there at the C. But at the B and at the D, there will be net reactions will be there. At C, there will be no net reactions are there. That's why there will be no vertical step is there at the point C. Let's see at the point D. The how much is simple logic, sir. Even we can able to solve from looking for the right side itself. If you're looking from the right side, how much is the value, guys? It is 700. Upward force is positive or negative? It is positive. But as you are looking from the right side, it is just V at D equal to minus of, as I am looking from the right side, how much? Minus of plus 700, it is minus 700. No, sir, I will look at the left side only. No problem. You can look at the same thing itself. How much I am going to get? Look at everything, guys. Downward force, positive or negative? It is the negative. How much? Minus of 200 into 2 plus 4 plus 2. How much? 6, 8. So 200 into 8, guys. 200 into 8. Next, 900 plus, I can simply able to say 900 into, how much is there, guys? 4 plus 2, 6. (900) plus 6. How much is coming, guys? It is coming as 200 into 2. Sorry, guys, just is a 400 itself. It is just. Why? Because I am finding the shear force, not the bending moment. Should be very, very careful. 200 into 8 minus 1600 plus 900. It is coming as minus 700 as it is itself. Why I have cut off this distance 4 into 2, guys? Because I am finding shear force, not the bending moment. So if you're looking for calculating from the right side or left side, you are getting the same value. Now observe how much it is coming, guys. It is 700 minus 700. So I can join freely like this. Minus 300 to 700. This is the typical shear force diagram. Now we will see how to draw the bending moment diagram for this. Before starting this one, guys, let us assume this is the place where the shear force is changing from positive to negative. We will find out exactly what is at what distance its value getting 0. Observe, same logic. Assume I am assuming it as a x distance, then this distance must be how much? 4 minus x. Why, guys? Distance between these two is 4, so this must be 4 minus x. If you make theta same, how much I am going to get, guys? I can write 500 by x must be equal to 300. 300. Don't keep minus symbol, guys, because I am just finding the angle. I just want magnitude only. So 300 by how much? 4 minus x. Now tell me, guys, x equal to how much? It is coming as 2.5. If you just solve this one, I am going to get x equal to 2.5. Now we will find out what is the bending moment at different locations actually. Let us see. Definitely without thinking, at x equal to 0, observe, guys, at x equal to m at x equal to 0 must be equal to how much? 0. Why? Because this is the place, there will be no force. This is the place exactly, guys, where no force is there here. So moment must be equal to 0. Now, m at x equal to, observe, guys, 2. M at x equal to 2, how much is coming, sir? It is 200 into 2. So it is how much is coming, guys? It is a minus 200 into 2. It is the force multiplied with the distance. How much? 1. It is coming as a minus 400. Why minus again? Because it is a negative force. Downward force is the negative force. Negative force gives the negative bending moment. So I got mx equal to 2. Now m at x equal to, observe, m at x equal to, observe guys, this distance, because I just got it, this distance equal how much? 2.5, because I got x equal to 2.5. 2.5 plus 2, how much? 4.5. This distance I got it as a 2.5. It is coming as 4.5. At x equal to 4.5, how much is the value I'm going to get? If you observe guys, that is coming as, look at here, x equal to 4.5. 200 into 4.5 is the force into 4.5 by 2. It is the distance. Now tell me, it is a negative or positive? It is a definitely negative, because it is a downward force, is negative definitely. And this is the downward force. And again, what is onward upward force is there guys here? What is that? 900. 900 multiplied by how much? 2.5. 900 multiplied by 2.5. It is coming as 225. It is coming as 225. Now observe guys, definitely, I'm extremely sorry sir, this is coming as, because exactly at this location I'm going to get 225. Now m at x equal to how much? 2 plus 4, 6. It must be 0. Even if you want, you can verify guys, you will get the 0 value, because this is the internal hinge, you must get the 0 value. Now m at x equal to how much? 2 plus 4 plus 2, 8. It must be equal to 1000, because it is the 1000 over here, but it is coming negative or positive guys. It is the negative minus 1000, because it tried to rotate the beam downward direction, so water will be falling down. I am getting negative 1000. Let us see how I am drawing the bending moment diagram for this. Assume this is the curve at x equal to 0, 0. X equal to 2, how much guys? I am getting minus 400. This is the place, minus 400 is there. Now at x equal to 2.5, how much guys? X equal to 2.5, sorry, x equal to 4.5, how much is coming guys? Plus 225. This is the place, 225 is there. And x equal to 6, it must be 0. And again here, how much guys? It is coming as minus 1000. So I have to join this one and this one and this one and this one. How can I join guys? All these three things. Definitely it is a parabolic or linear variation. Definitely it is a parabolic variation. Why? Because your shear force is a linear at each and every point. Now let us see guys. But slope, this is the place where most of the students commit a mistake guys. Look at here everybody. At x equal to 0, your shear force is 0, right? When the shear force is 0, what is going to happen for your bending moment guys? Definitely the slope of the bending moment diagram must be 0, means horizontal line, vertical line. It is the horizontal line. Observe here. At x equal to 2, your shear force is having something plus minus 400. So it is having a vertical line. It is no more 0. Now again exactly at x equal to 225, what is happening exactly guys? Your shear force coming 0. As shear force is coming 0, so it is again horizontal line. Now observe again at x equal to observe guys, at x equal to 6, your moment is coming 0, but shear force is having something positive value. That's why again something vertical line here. Again at x equal to 8, your shear force is having something maximum value. The slope of the bending moment diagram, again guys, maximum is again vertical line. How can you join guys? Please observe, horizontal to vertical, again vertical to horizontal, again horizontal to vertical, and again from here exactly guys, this is how it is going. It is going smoothly guys. Please observe, it is going smoothly itself. The curve here is, the curve must be smoothly here. If you observe, let me draw it guys smoothly here. As it is varying linearly, in parabolically guys, this is how the curve is going to be happening. Assume this is the place, assume this is where the hinge is there, this is the 0, this is the place, you can say this is the point C. So how is a typical bending moment diagram for the internal hinge? Sir, please observe the slopes concepts, guys. Here shear force equal to 0, the slope of bending moment diagram 0, shear force is having some magnitude, the slope having some magnitude. Again, here shear force equal to 0, the slope is 0, again shear force having some magnitude at this location. I can able to say, please make it clearly, guys. Yeah, again at x equal to last point, x equal to 8, I'm having shear force some magnitude, having the some definitely high slope is there, minus 1000. This is a typical shear force bending moment diagram. Now tell me, guys, which part is going to fail first? It is the point D or point A or point C? It must be point D. Again the question is why, guys? At point D I am having the maximum bending moment. Maximum bending moment leads to maximum stress. So this is the place it is going to be fail first. Okay, guys, this is one of the previous gate question, but it's a very simple, guys. Look at the problem. They're giving a simply supported beam, but two different types of cross sections actually, guys. So one is having I, second one is having 2I. Are getting an answer? It is not a uniform beam actually, guys. But the question is, what is the correct representation of bending moment diagram for the given loading diagram? This is the question actually, guys. But observe, if you observe the option A or option B or option D, C and option D, in A, B, D, there is one common thing is there, guys. There is a vertical step. There is a sudden change of bending moment is there. There is a sudden change of bending moment is there actually, guys. Please look at here. So when the sudden change of bending moment occurs, whenever point couple acts on the beam, are you getting or not, sir? Whenever point couple or point bending moment acts on the beam, then only sudden change occurs. But A, B, D, they given the sudden change of bending moment at the midpoint, but the given load is a point load, not a point couple actually. So right answer must be what, guys? It is the option C without thinking, I can say. Are you getting an answer? Why? Because only C doesn't have a sudden change. Remaining option A and option B and option D having a sudden change of bending moment, but the given load is only point load. There is no point couple is there. So option C is the right answer. Coming to the next question, guys. Coming to the next question. Look at the problem, guys. A cantilever beam carries a anti-symmetric load as shown in the figure. Then what is the correct representation of bending moment? This is the tricky question, guys. This question is given for the 2 marks in the GATE exam. If you can solve this one, it's a very easy, guys. You can able to understand this concept very thoroughly. Please look at here, everybody. I am having cantilever beam. Please look at here, guys. Subjected to uniformly varying load like this. This is the downward, this is the upward actually, guys. But definitely, guys, can you directly draw the, please look at here, guys, can you directly draw the bending moment diagram from the given loading diagram? The answer is little. You have to practice more to directly draw the bending moment diagram from the loading diagram. But we can directly draw the shear force diagram. Why? Because, guys, I can find out directly bending moment at any location, but while drawing, the slope concept is there, na? The slope of bending moment is diagram depend upon shear force diagram, because if you see the option A and option B, option C, option D, all are having different slopes. But which one is the right slope? I can't able to directly tell from the loading diagram. First, I have to draw the shear force diagram, guys, approximate shear force diagram. Please look at here. Now tell me, guys, as it is symmetric load, whatever downward force is there, So I'm having a upward force automatically, guys. As you, I'm looking at the left hand side. So what is going to happen, guys? These two will give you zero force. Downward force, upward force. Then how is the reaction here automatically? Zero. Are you getting our answer, everybody? So I will be having a zero bending, zero shear force, I can say, zero support at this location. But look at the bending moment. How much is the reaction here automatically, guys? This assume something. This is the something force will give you what type of couple? Will give you anti-clockwise couple. To prevent this one, I will be having a clockwise bending moment. Please look at here, guys. These two will give you anti-clockwise. To prevent this one, support will give you clockwise. Are you getting an answer? So I am looking from here. Starting, is there any support reaction is there? No, actually. So I am having zero shear force. Okay. Now look at here, everybody, guys. From here to here, what is happening? It is a uniformly varying load. So your shear force must be parabolic in nature. But if you observe here, guys, this is the place you are having algebraic sum. Algebraic sum of all these force. Are you getting an answer? Will be maximum automatically, guys. But here load equal to 0 means dV by dx equal to how much? Q. That equal to 0 means the slope of the shear force diagram must be 0. That's why I have to make it horizontal line or flat line. So I am having negative shear force or positive shear force. Load is negative, so negative shear force. I am just drawing like this. Again will be here. Why? Because, guys, I want shear force at this location. Algebraic sum of all these forces. Downward force equal to upward force. Shear force will be 0 automatically. So answer is 0, 0. I am having a maximum shear force here, I can say. But what is the approximate bending moment diagram for this, guys? Please look at here. Now I can forget the given loading diagram. By seeing this one, I can able to say. Please look at here, guys. Starting bending moment equal to how much? 0. At this location, bending moment equal to how much? M. 0 M. So if you observe this one, guys, option A is completely ruled out because I am having 0 M actually. And option B also completely ruled out. Why? Because it is a linear variation he has given actually, guys. But it must be cubic parabola. Because shear force is x square means your bending moment must be equal to x cube. Okay. Now look at here. It is coming from 0 to M, it is going, sir. But how it is going? Cubic parabola only. But if you observe here, guys, this is the place shear force equal to 0. So dm by dx, the slope of the bending moment diagram equal to shear force. So if shear force equal to 0, the slope of the bending moment diagram will be 0, which means the flat. Okay. Again here also, guys, shear force is 0, the slope of the bending moment diagram will be again flat, I can say. Okay, guys, two flats. And again I am having, if you observe here, guys, exactly, this is the place I am having a maximum shear force. So I should be having, as V is maximum, slope must be also maximum is something, maximum slope I can write, or make it vertical line or whatever it may be, guys. But how do you join these two? This is the typical shear force diagram. So option D is the right answer. If you look at here, guys, always, please look at here, guys, shear force is negative. This is the negative shear force or not, sir? I told you, whenever shear force is negative, your bending moment is rising or falling? It is falling, I can say. That's why it is falling everywhere if you look at from the left hand side. Are you getting an answer? Two things you have to remember. Whenever loading diagram is given, don't immediately jump into the bending moment diagram, guys. Draw the approximate moment shear force diagram. Then you can draw the approximate bending moment diagram correctly. If you directly jump into the conclusion, you may get the wrong answer because slopes are very important here. Okay, guys, hope you understand. We see the another example, guys. The load intensity on a beam segment is given as root x, Newton per meter. Then what would be the bending moment as a function of what? Here the question he has given is, guys, Q is equal to x power 1 by 2 or root x. Then bending moment is a function of actually, guys. For this, I given the clue also for you guys. I given everything here because you know that if Q is proportional to x power n, then how the shear force, guys? Proportional to x power n plus 1. Whatever bending moment, guys? Proportional to x power n plus 2. But how we got it, guys, these things? Look at here. You know that dv by dx equal to q. Assume q equal to x power n. Then dv equal to how much, guys? X power n into dx. If you integrate, how much I'm going to get? That equal to how much? X power n plus 1 by n plus 1 plus something constant will be there. So from this I can say that shear force is proportional to what? X power n plus 1. What about bending moment, guys? Same logic. dm by dx equal to what? Something constant k into x power n plus 1. If you integrate, guys, I am going to get m equal to again something constant k1 into x power n plus 2 by n plus 2. So I am taking it as a constant itself. So this is the final conclusion I have written actually, guys. But if you look at the problem actually, here the problem is he has given q equal to x power 1 by 2. I can write q proportional to x power 1 by 2. Then how is the bending moment equal to? Proportional to x power n plus 2. N is 1 by 2 here plus 2 here. I can write m proportional to 5 by 2. The option is C is the option here. Okay, guys, another conceptual question. They have given a symmetrical uniformly varying load. Then he is asking us to choose the correct shear force diagram for the given loading diagram actually, guys. Okay, two clues you have to remember actually, guys. First of all, it is what type of load? It is a uniformly varying load. Sirji, please listen carefully how I am coming to the conclusion. As it is uniformly varying load, okay, how is your shear force? It should be parabolic. So which option can be ruled out now without thinking? This can be ruled out. Why? Because they given the linear variation automatically here. So this is not possible. Next, slope. Option A and option B are having parabolic. So it can be A, it can be C, guys. It can be C. Now look at here, guys. But slopes are different. But the slope is coming from where? Again, dv by dx equal to what? Your shear force. Are you getting an answer? But look at here, guys. Whenever, dv by dx equal to applied load. Whenever applied load equal to 0, the slope of shear force diagram equal to what, guys? Slope of shear force diagram equal to flat. It is a flat slope I can write, or horizontal flat slope. Now tell me, guys, identify the locations where you are having flat slope, or like a zero force actually, guys. Maximum force, this is the place I am having a q equal to 0. If q equal to 0, your shear force must be flat, must be having a 0 slope. But if you observe here, guys, what is happening, guys, here? There is a maximum slope is there here. So this is completely ruled out. So option can be, guys, what, guys? This can be answered, but don't come to the conclusion immediately. Are you getting an answer? Don't come to the conclusion immediately. So option can be either C, either D right now. But A is not possible. Why? Because at q equal to 0, your shear force diagram must be flat. Okay. Next. But this is right or wrong, we will judge it, guys. Same logic. This is the place I am having, look at it, this is the place I am having maximum shear force. sorry, maximum load. If Q is low, Q load is high, definitely I am having a maximum slope for the shear force diagram. As load is high, maximum shear force, again load is high, maximum shear force. But is it right or wrong? It is also wrong, guys. But the question is why? Why? Because, guys, whenever your load, here to here load is upward load or downward load, upward load. Upward load means positive load or negative load. It is the positive load. But whenever load is positive, how is your, look at here everybody, guys, how is your shear force diagram? Shear force diagram is always rising. But whenever load is negative, how is your shear force diagram? Always falling, actually, guys. It is a falling shear force. Are you getting or not, sir? But if you observe here load is what? Load is upward shear force. That's why I am having a falling shear, sorry, rising shear force diagram. Load upward means rising. So it is rising like this, if you're looking from the left hand side, guys. But again here it is a positive force or negative force, guys. Downward force is a positive force. So it must be what? Sorry, downward force is a negative force. It must be what? Falling shear force. But the given is rising shear force. Are you getting or not, sir? So the answer is wrong here. Are you getting or not, sir? So, clear? Because here downward force is what? The force is downward, so it must be falling shear force. But here shear force is rising. So right answer is, please look at here, guys. Till this it is correct. But from here it should be falling again. This is rising and falling. This is the right answer for this automatically. Understand, guys? Please look at here. I am telling you one more time neatly, guys. Here, as the load is upward load, your shear force will be rising. As the load is downward load, shear force must be falling, but here it is rising. But what is the diagram for this, guys? Please tell me. Loading diagram is, guys, it must be like this. Again it must be like this. This is the loading diagram for this. Why? Because, guys, then this is the correct answer. Look at here. It is shear force, say load is upward shear force, sorry, upward load. Upward load means rising bending moment diagram. Again here it is also upward means again it is rising, I can say. So this is the right answer for this. But for this, this is the right answer. Hope you understand, guys. Q equal to 0, flat slope. Q maximum, vertical. Q maximum, vertical, I can say. Hope you understand, sir. This is my favorite problem in shear force and bending moment diagram topic, guys. If possible, pause the video for 10 seconds. Please try to solve before watching the solution, guys. Please look at here. They are giving a curved cantilever beam subjected to a point load P. And the question is asking is, what is the correct representation of bending moment diagram for this? Be careful, guys. Okay, that is the reason. Assume I am taking a section at this location here. This is the point I am telling, guys. Look at here, everybody. And assume this height equal to how much, I can say? Y. Are you getting or not, sir? Now, what is moment about this point till I can able to say, guys? P into Y. Moment about this section, I can say. Moment about this theta or anything is fine. Equal to how much? P into Y. P into Y is the moment actually, guys. Please look at here. Then what is the value of Y here, I can say, guys? Y equal to, look at here, everybody, guys. Y equal to R sin theta. R sin theta equal to R sin theta. So I can say that m theta equal to P into R sin theta. which means that bending moment varies with respect to sine theta. Because P is constant, R is constant, it is varying with respect to theta, sine theta. But in the given bending moment curves, which one having a sine theta curve, guys? At sine theta, at theta equal to 0, exactly theta equal to 0, bending moment equal to 0. So it is there everywhere, but this is completely ruled out because I am having something PR here. So it can be option B, it can be option C, it can be option D. But sine curve, this is no more a sine curve. This is a typical sine curve actually. Are you getting an answer? So at sine theta equal to theta, you are having 0. When sine theta equal to 80 degrees, so sine 180 also again 0. Are you getting an answer? But when sine theta equal to 90 degrees, exactly 90 degrees, you are having the maximum bending moment. Sine 90 how much? 1. So value is PR. But you can ask the question, Sarji, it is a plus PR or minus PR according to our sign convention? Please look at here, guys. About this point, this is how the beam will be bending, deflecting about this section. So if I keep the water, water will be stored or water will be falling down, guys? Water is stored. Are you getting an answer? If the water is stored, it is a positive bending moment. That's why plus PR. This is my favorite problem, guys, in entire SFD and BMD. Be careful. Hope you understand this topic, guys. Procedure to draw loading diagram from shear force diagram and bending moment diagram, guys. This is the most frequently asked question in various competitive exams. They are giving the particular shear force diagram. They are asking you to draw the corresponding loading diagram actually. They are asking Volta manner actually, guys. So far, we know that when the load is there, I know how shear force varies and how the bending moment varies, guys. But he is asking Volta. If the shear force is given, if the bending moment is given, how is your loading diagram? Are you getting an answer? Please look at here. For this, just follow one thing, guys. Suppose they are given a shear force diagram. First thing, identify segment. Identify segments having shear force equal to constant. Assume he has given the shear force diagram like this. Assume for time's sake, guys, they given the shear force diagram like this. Between A and I can write your shear force equal to constant. Then what is the corresponding load diagram, guys? Load equal to 0. Load equal to 0 in that segment, I can say. Are you getting an answer? The first rule you have to find out. You have to understand why. Because if shear force equal to constant, there will be no load automatically, guys. Second one, identify the section. Here it is segment. Identify the section where there is a sudden jump of shear force is there. There is a sudden rise or fall off, I can say, guys, shear force is there. Please look at here, guys. Suppose I am having a segment. The sudden jump of shear force is there. Sudden jump of shear force. Then what is going to happen, guys? Whenever there is a sudden jump of shear force, your load must be what? Point load. I can write. In shear force diagram, if there is a jump or sudden change, I can say, guys, then it must be what, guys? Tell me, guys. There must be a point load. Point load. If the jump is upward jump, then point load is upward point load. If the jump is downward jump, then point load is downward jump, but the condition is as I am looking from the left hand side of the section, I can say. I am looking from the left hand side. While you are looking from the left hand side, if it is having a, please look at here guys, if it is having a upward jump in the shear force diagram, then load must be upward load, I can say. Hope you understand guys. Next, third one you have to remember is, please look at here guys. Suppose shear diagram is given linear variation x. If there is a linear variation actually guys, you are having the load actually. This is a what type of load? Then the load is UDL, uniformly distributed load. But the distributed load is upward load or downward load. How can I know actually guys? For this we already discussed guys. What we discussed? If, look at here guys, if load is positive, if load acting on the beam is positive, then always shear force will be rising shear force. Rising shear force I can write. Are you getting an answer? If load is negative, always shear force is falling shear force. Like this. In the shear force diagram, this how shear force falls. It can be negative falling or positive falling. Are you getting an answer? It must be falling, but only the condition is guys looking from left hand side only. All things are I am looking from the left hand side. Now tell me guys, for this how is the loading diagram for this? If you are looking from the left hand side, it is rising or falling guys? It is a rising I can say. So definitely guys, please look at here. You are having a upward load. If you, this is a beam I thought, this should be upward UDL I can say. Are you getting an answer? Suppose this is what? Falling shear force. If it is a falling shear force is rising, shear force is falling, then how is the loading diagram guys? If shear force falls, load must be negative. Negative load is what? Downward load. Downward load is negative. Why? Because I given the sign convention that Q downward is negative, Q upward is positive guys. Now fourth one is, if shear force diagram is parabola, if SFD is parabola, then how is the loading diagram guys, tell me? If it is parabola, it must be UVL load I can write. Are you getting an answer? But again a problem will come actually here. The problem is parabola can be increasing parabola or decreasing parabola, depends upon that UVL also changing. For this follow simple trick guys. Look at here sir. Assume this is the parabola he has given. This is the parabola he has given. The parabola given here is falling parabola or rising parabola guys. This is a shear force diagram, right? Falling parabola. If it is a falling parabola or if it is a falling shear force, then your load must be negative load. Are you getting an answer? Negative UVL, be precise I can say actually guys. So for this, your loading diagram will be negative load. Load must be downward direction. But again problem is coming sir. UVL means one must be 0, one must be maximum. But here it is 0 or here it is maximum. How can you say that? Again there is a one more relation you have to follow guys. dV by dx equal to what? Q. Which means that whenever load equal to 0, the slope of the shear force diagram will become flat or 0 slope I can say. Now tell me guys, which place I am having a flat slope? This is the place. If this is having a flat slope, tell me guys, this is having a flat slope, your loading should be equal to 0. QV equal to 0 here actually. And again, this is the how downward load, Q equal to maximum here. Whenever maximum shear force, maximum load is there, shear force slope must be maximum. Are getting an answer? Why downward load? Because shear force is falling. Second one. Please concentrate, guys. Same thing they have given like this. This is falling SFD or rising SFD, guys. This is a falling SFD itself. As it is falling SFD, guys, how is the bending shear loading diagram actually, guys? Falling SFD means load must be negative only. Load must be downward UVL. Yes, definitely it is a downward UVL only. But it is varying from 0 to maximum or maximum T0. It is varying from 0 to maximum. So load is varying from 0 to Q. Here Q equal to 0. Why? Because, guys, exactly at this location, your shear force is flat. As the shear force is flat, your load must be equal to 0. Next. Fourth one, this is third point I can write. Third point. You have to tell me now, guys, this case. I'm having something like this. Now we will see rising parabola. This is the rising parabola. Parabola is rising. Then how is the load must be, guys? UVL only. Are getting an answer? Load must be upward load. Load must be upward load on the beam. It is varying from 0 to Q. Why it is 0, guys? Whenever slope is 0, your load of the shear force, load of the loading diagram must be equal to 0. Fourth, please you have to tell me, guys, whenever this is also rising parabola only. This is also rising parabola itself. How is the loading diagram must be equal to, guys? Like this. Hope you understand by this time. Because flat 0 maximum slope, I am having a maximum force automatically, guys. As it is rising, load is positive load. Load is positive load means upward load is the positive load actually, guys. So you have to remember this one. But don't worry, guys. I am giving so much of information, but don't worry at all. While solving the problems, it is a more clear for you. I will give you summary of all these things. It is a more clear for you, guys. So you can able to solve any problem. If they given the shear force diagram or bending moment diagram, you can draw the loading diagram very easily. Now look at here, guys. Suppose this is a bending moment diagram, guys. Last point. They given the bending moment diagram. There is a vertical step in the bending moment diagram. Then there must be a point couple in the loading diagram. This is the only thing you have to observe, guys. The first basic two things you have to observe is, if there is a sudden change, sudden jump of shear force diagram, there must be a point load. If there is a sudden jump of bending moment diagram, there must be a point couple. If you can understand this one, guys, you can able to draw the load diagram from SFD and BMD. Hope you understand, guys. Now we see some examples to draw loading diagram from the given shear force diagram, guys. You have to remember these 4 points actually, guys. This we discussed already. Whenever shear force jump is there, there must be point load. Whenever jump is upward, load must be upward. Whenever shear force equal to constant, your load must be 0. Whenever shear force is linear, it is rising linear, I can say. Shear force is rising means your load must be positive load. Positive load means what, guys? Upward load. Whenever shear force is falling, this is the falling shear force actually, guys. This is the rising shear force. Then load must be downward. Why? Because, guys, falling shear force means I can say it is a negative load. Negative load means downward load, I can say, guys. Are you understand or not, sir? Are simple. Rising means assume upward, falling means assume downward. Again here, guys, shear force is falling or like rising, guys. Shear force is falling, so load must be falling load means downward load. Are you getting or not, sir? Next again, shear force falling, load must be again downward, But observe here, because it is a parabolic, it must be UVL load actually, guys. One more thing you have to remember, whenever slope of a parabola is flat, then your load must be equal to 0. Whenever slope of the parabola is flat, load must be equal to 0. Are you getting that or not, sir? Similarly, rising slope, upward load. Rising slope, upward load. Flat slope, 0 load. Flat slope, 0 load actually, guys. If you remember these four, you can draw any loading diagram from the given shear force and bending moment diagram, guys. Please look at here, guys. I am giving you typical shear force diagram giving you typical shear force diagram actually, guys. Given that shear force diagram, then your task is to draw the approximate loading diagram. I don't want any quantitative loading diagram, guys. I want qualitative, which means that approximate. I don't want any values, just draw the approximate loading diagram actually, guys. How? Please look at here, guys. First observe, is there any sudden jumps are there in the shear force diagram or not? Yes, one jump, another jump. But this jump is upward or downward. Look at here. Always given the task test, look only from the left side, because all these convention I have made by looking from the left side. When you are looking from the left side, please look at here, guys. What is happening? Coming, this is a falling, suddenly rising upward direction. Suddenly raising upward by direction means there is a point load upward at this location. Are you getting or not, sir? Again, rising, falling again suddenly rising like this. So there must be again one more point load at this location. That's it. Next, observe, is there any places where there is a linear variation of shear force is there? This is a linear variation. Observe. This is the linear variation, right? But it is, look at here everybody, guys. It is a falling or rising, sir? It is a falling. It is a falling shear force. If it is a falling shear force, it should be a UDL, but downward UDL I can say. Done. Again went upward direction, again it is falling like this. Falling means load must be again downward load. Again went upward, again falling, again downward load. It is a typical overhang beam, I can say, guys. Hope you understand, sir. Let us see another problem. Look at here. Okay. Now, they're given like this. They're given the typical CFD, shear force diagram, guys. Your task is to draw the approximate bending moment diagram. So, approximate loading diagram for this. Please look at here. First thing, observe how many sudden changes are there. One sudden change is there here, but downward change or upward change actually, guys, it is a downward change. If you are looking from the left hand side, downward change, guys. So your point load must be downward point load here. Are you getting or not, sir? Next, please look at here, guys. And again, from here what is happening, sir? It's a linear variation of the shear force. But linear variation of shear force is fine. If a linear variation, load must be UDL. But listen, guys, it is a rising UDL or falling UDL. It is a rising UDL. If it is a rising UDL means, sorry, rising shear force. If it is a rising shear force, then how is your UDL must be, guys? Upward or downward? The shear force is rising, load must be also upward, I can say. That's it. Next, here to here what is happening? Shear force is constant. If the shear force is constant, no load will be there between these two. After this, suddenly again falling downward direction. As again falling downward means there must be a point load. This is a typical loading diagram. How easy it is, guys. Only thing is you have to remember these things. But if you practice little bit, guys, you don't need to remember these guys. Just you can able to understand very easily with the small basic concepts. Now we see the little complex problem, guys, but if you are confident about this problem, if you can able to solve this problem, I am pretty sure that you can able to solve any question in this particular topic, guys. Please look at here. The given shear force diagram is like this. This is the given shear force diagram. Then they're asking, what is the approximate loading diagram for this, guys? Approximate loading diagram for this. But understand, guys, it is varying linearly or parabolically, guys. It is a varying parabolic in nature. So how is your load must be UVL? UVL, but without seeing, I can able to explain you guys. So you should be very, very careful. So you don't need to remember all these things also. Please look at here. If you observe, how is your shear force diagram is behaving, guys? From A to B, it is falling or rising, guys. Keep on falling from A to B. But again, B to C, it is keep on rising. Okay? So load must be UVL load only, but A to B keep on falling, B to C keep on rising like this. So I can conclude that A to B must be negative load, or I can say downward load or upward load, guys. Falling is downward load or negative load. Rising means upward load or positive load, I can say, guys. But again, the problem here is, how is the variation? Please look at here, guys. First, it is upward. I am looking from the left hand side only. Upward, there must be a support will be at this location. Next, after this, from here to here, what is happening exactly, guys? From here to here, I am having, see, there was 2 points actually, guys. Flat. Flat means zero load. Again flat. Again zero load. Are you getting or not, sir? Flat, zero load. Flat, zero load. Again one more flat is there. Again zero load actually, guys. So I have to go with the 3 zero loads actually. Then how it will be? Please look at here, guys. As it is from here to here, what is happening, guys? Your shear force is falling, so load must be also falling like this. Downward load. And as I am having a maximum slope, it must be having a maximum value at that location. But again, from here to here, load is falling only, guys. I am not talking about something else. Shear force is falling only, so load must be also downward, but having a maximum to 0, I can say. Now again tell me, guys, from here to here, what is happening, sir? It is a rising shear force, so your load must be upward load. Like this I am writing. Please look at here, guys. Here to here, it is a it is falling, so downward load automatically, guys. But zero slope means it must be zero automatically. But again, slope is changing from 0 to maximum here. That's why your load must be also 0 to maximum, and again maximum to minimum actually. But after this, again falling down. Falling down means again one more load automatically here. So falling down suddenly, guys, so there must be a point load. This is the typical load diagram with the help of a shear force diagram. Please look at here, guys. What is happening? Please look at here. Same thing. Falling shear force. Load is like this. Next. But again falling shear force. One more falling shear force here automatically. This is the manner. This is the manner. So how is the load here? Behaving same manner or not? Yes. Again from here, rising like this. Same, 0 to maximum slope. So how is the load must be, guys? Same upward load here. Same thing. You can to understand, guys. Please look at here, guys. This is the thing you should be very, very careful while solving the problems also, guys. If you remember these four topics, four things, you can able to solve any problem here automatically. Hope you understand, guys. I'm pretty sure that you can able to solve any problem. In this lecture, we discuss one of the most important topic of strength of materials, that is point of contrafluxion. From this topic, guys, the questions are asked multiple number of times in GATE, ESC and various competitive exams like AEE, ISRO and BERC. So one of the most important topics from exam point of view also, guys. Okay. To understand this topic in a crystal clear manner, we have to question ourselves with three questions. First one is, what is mean by point of contrafluxion? Second one is, why we have to find out the point of contrafluxion and its significance? And third one is, how to find out POC. If you can answer these three questions, I'm telling guys, you can able to answer any question from any competitive exams. This is one of the most important topic. If you can answer these three questions, you can answer any question in any competitive exams. Let's see. We start with the first question. What is mean by point of contrafluxion? Let's see, guys. Assume I have a beam. Because of different types of loading, the beam is bending like this. If you observe, guys, what is happening? One part of the beam is under sagging, another part of the beam is under hogging. Point of contrafluxion means this is the point at which the curvature of the beam changes from sagging to hogging or hogging to sagging. This point I can call it as a point of contrafluxion. Let's see, guys. Assume I have a beam here. The beam is subjected to continuous load, or I can say is completely UDL. So what happens here? Because of the application of the load, assume the beam is deflecting like this. If you observe, guys, only till this the beam is under sagging, and again the beam is under hogging. Again it is under sagging actually. So point of contrafluxion means this is the point at which the curvature changes from sagging to hogging or hogging to sagging. Now tell me, guys, how many POCs are there in this beam? Two. One is here, second one is here. So I can define POC like this. Point of contrafluxion means, assume K is the curvature, guys. So we can define that point of contrafluxion means it is the point at which the curvature changing from sagging to hogging or hogging to sagging. Sagging to hogging or hogging to sagging. At the same time, I can define the point of contrafluxion in another interesting manner. What is that? If you look at here, guys, whenever beam is under sagging, what is happening for the bending moment? It is a positive bending moment. Whenever beam is under hogging, what is happening for the bending moment? It is the negative bending moment. Again here beam is under sagging, again bending moment is positive. So I can define the point of contrafluxion means this is the point at which the bending moment changes from positive to negative or negative to positive. These 2 points I can call it as a POC again. Let us say, guys, assume bending moment. the bending moment is changing from positive to negative or negative to positive. The point between these two I can call it as a POC. This is meant by point of contraflexion. Second question is, what is its significance? Let us understand, guys. It helps you to identify where to reinforce. It helps you to identify where to reinforce the beam. Reinforce the beam and where not to reinforce the beam. First, we can ask ourselves why we have to reinforce, guys. Assume I have a beam like this. I have a beam subjected to point load. So what is happening, guys? The beam is deflecting like this. As the beam is deflecting like this, if you observe, guys, what is happening in the same manner? The beam is just deflecting like this. If the beam is deflecting like this, what is happening, guys? The top fibers are under compression, bottom fibers are under tension. The top fibers are under compression, the bottom fibers are under tension. Okay, this is a typical type of beam subjected to point load. Assume the same beam I am making with a concrete. So, concrete, you know, guys, concrete is strong in what? Strong in compression. And it is weak in what? Tension. It is weak in tension. So what is going to happen? Where this beam will fail? Wherever your fiber of the beam subjected to tension. If you observe, guys, completely bottom fiber is under tension. This is the place where your beam is going to be failed if you don't reinforce it actually. That is the reason we always reinforce the concrete with a steel. Okay. Why? Because, guys, why steel? Because steel is strong in tension. Steel is strong in tension. Now tell me, guys, which place I have to replace? I have to reinforce actually the top, near to the top fiber, near to the bottom fiber, guys. It is near to the bottom fiber. Why? Because on top fiber, it is already under compression. Your concrete is strong in compression. At bottom fiber, your concrete is weak in tension. That's why we have to reinforce with a steel which is strong in tension. So your is completely safe. Let us observe, guys. Assume I have a continuous beam. Then where to reinforce, where not to reinforce, this is the place your POC helps you. Because you know that, guys, at POC, the curvature changing from sagging to hogging. If you observe, guys, this is the place, what is happening exactly? Your curvature is changing from sagging to hogging. Now tell me, this is the place your beam is under tension. And this is the place again beam is under tension, and this is the place again your beam is under tension. So you have to reinforce at three places. How I am reinforcing, guys? If you observe here carefully, look at here, sir, everybody. This is, I can able to bend it here actually, sir. Again reinforcing here. Again bending down. Again reinforcing like this. This is how you reinforce the beam, I can say. This is the steel bars. We used to reinforce with what, guys? Steel bar. That's why you might have seen in the construction sites that the steel rods are bending according to the curvature of the beam to give the proper reinforcement. Okay, guys, we done with what is POC, and we done with what is the significance. What is the significance, guys? Just to reinforce correctly in a beam, where to reinforce and where not to reinforce. This answer I can able to get it easily from POC. Next, third one is how to find out the point of contrafluxure. Look at here everybody guys, because there is a proper relation between the curvature to the bending moment. But I can find out the bending moment very easily. Assume guys I have a beam. The beam is having a 3 points. Assume point A, point B and point C. Suppose if point A is at point A, if bending moment at A is positive, and at B, if bending moment at MB is positive, at C, if bending moment at C is negative, then tell me guys, between what points you should get the point of contrafluxure? Is it possible to have the point of contrafluxure between A and B? The answer is no. Why? Because at A it is positive, at B also positive, so there is the scope of point of contrafluxure between A and B. But if you see between B and C, B it is positive, C it is negative, so there must be somewhere between B and C your moment must be equal to 0. So that point I am calling as a point of contrafluxure. But how can we find out? Once you identify the two locations, what you can do is take the section between B and C. Take a section between B and C by taking a distance of x from the end. Write the bending moment equation between B and C and make it equal to 0. From this you can find out the location where your POC lies. You can understand this one very easily with a simple problem guys. Here the overhang beam is given, subjected to one UDL and 1 point load. Then he's asking us to find out the point of contrafluxure from the point D. Okay, first we have to find out the support reaction RC. How can we find out guys? Take moment about A. If you take moment about A equal to how much? 0. I can simply able to say that about point A, your clockwise moments must equal to anti-clockwise moments. Tell me guys, what are the clockwise moments? This 20 will give, because 20 is acting downward, this will try to rotate in the clockwise direction about the point A. With what moment guys? 20 into distance, how much guys? 4 plus 4 plus 2, 10. Plus this UDL 17.5 guys. Again this will give you again clockwise how much guys? 17.5 into 4 is the force where it is acting at centroid, means 2 meters actually. Again it is giving clockwise moment multiplied by 2. This is the clockwise moment. What is the anti-clockwise moment guys? RC will give you anti-clockwise. So RC into how much guys? 4 plus 4, 8. From this RC equal to how much is coming sir? It is coming as 42.5 newtons. So I got the value of RC. Now observe, I am finding bending moment at different places. Assume guys, what is the moment at D? I can simply able to say that assume moment at D equal to how much? 0. Why? Because force is at the same location and no distance is there. Moment must be equal to 0. What is the moment at C? Moment at C equal to force into distance, 20 into 2. It is coming as minus 20 into 2. Why minus guys? Tell me. Because this will try to hog the beam. As it try to, this is the hogging actually. This try to hog the beam is definitely it is coming under negative bending moment. So how much is coming guys? Minus 40. Next, M about D. So M about B, guys. M about B. How much is moment about B? Now tell me how much? Minus 20 into this distance equal to how much, guys? 4 plus 2. 6. Next again RC upward plus RC. RC is coming how much, guys? 42.5 into 4. It is coming as plus 50. If you observe, guys, at C it is coming negative, at B it is coming positive. Then where the POC lies? Definitely it should be between B and C. So what I have told you, guys, take the section between B and C, write the bending moment equation. So I don't care about what is there after B right now. I am taking only between B and C. Assume this point is the B, this point is the C, this point is the D. Here what is there, guys? Your point load 20 is there. Again here what is there, guys? Your support reaction 42.5 is there. So what I am doing now, I am taking a section between B and C at a distance of X. This is 2. So this distance equal to how much automatically, guys? This distance is X minus 2 is this distance automatically. Now take moment about this point. I can write mx equal to force into distance minus 20 into how much? X. Next, upward force plus 42.5 into how much, guys? X minus 2. This is a typical bending moment till X. But you know that between B and C, at POC, what is going to happen, guys? Your bending moment must be equal to 0. If you make it 0, guys, minus 20 into X plus 42.5 into X minus 2. If you make it 0, you are getting X equal to 3.78, which means that at this distance, your POC lies, your curvature of the beam is changing from sagging to hogging or hogging to sagging, or bending moment changing from where to where, guys? Changing from negative to positive. So this is the way to find out the point of contrafluxure. Okay, guys, we have completely covered the entire shear force and bending moment diagram. Okay, whatever I have covered in the past 3 to 4 hours, I'm going to give you a quick summary which is going to help you for the last minute revision before going to the examination, guys. Please look at here. First one, we start with definition of shear force and bending moment. Definition of shear force and bending moment. What is meant by shear force and bending moment with respect to beams, guys? Please look at here. Assume I have a beam subjected to various types of loads. If it is subjected to various types of loads, the internal resistance offered by the beam at any cross section of a beam are shear force and bending moment. Okay, but why we have to find out this one, guys? Because shear force will give you shear stress, bending moment will give you normal stress. Are you getting an answer? If these are more than the allowable strength of the material, then what is going to happen? Because of shear force, beam will split. Because of bending moment, beam will bend. Okay, so to design a beam, so we have to design a beam in such a way that the stress induced due to shear force and bending moment should be less than or equal to allowable stress, then I can say your beam is safe. Okay guys, now we will see how to find out the shear force and bending moment at any location actually guys. Second one is, you can see this is for the design guys. I can write, to design any object, any beam, we have to follow this one strictly. And second one, what is mean by shear force? Shear force equal to algebraic sum of the lateral forces, algebraic sum of the lateral forces from LHS side, from LHS side, left hand side, are that equal to minus of algebraic sum of lateral loads from RHS side guys. Why? I clearly explained each and everything guys in the concepts. Next, third one, next bending moment equal to how much guys? Algebraic sum of moment of forces, moment of forces from LHS or RHS, you get the same value guys, I can say. Next, third one, sign convention, sign convention. This is the one you have to remember guys while finding the shear force and bending moment. First one is applied load upward is positive, which means that I am assuming that anti-gravity load. Why I have assumed like this guys? Because our convention is in general upward is positive, downward is negative. Similarly, applied load downward equal to negative. Okay, I can write positive force will give you the positive shear force, negative force will give you the negative shear force, and positive force will give you the positive bending moment, negative force will give you the negative bending moment. But just follow these things itself. But if you coming from right hand side, just keep minus symbol for shear force and use the same sign convention here. Why? Because guys, instead of remembering clockwise positive, anti-clockwise negative, this is very easy for you remember guys. That's why I made it like this. But if it is a point couple is there, how you have to remember guys? Just keep the water. If the water is falling down, it is a negative bending moment. If the water is storing because of the couple, it is the positive bending moment. Okay guys, so I have done with this. Next one, we got the relationship between load intensity, shear force and bending moment. What is that relation guys? It is dV by dx equal to Q and dm by dx equal to V. Okay, from this we are making another conclusion actually guys. What is that conclusion is? Slope of shear force diagram, I can write shear force diagram SFD, slope of SFD equal to how much guys? It is the applied load at any point. Similarly, slope of bending moment diagram is equal to how much guys? Shear force. What does it mean? Whenever shear force is maximum, your slope of the bending moment must be maximum. Whenever applied load is maximum, slope of the bending moment must be, slope of the shear force must be maximum. Whenever load equal to 0, the slope of the shear force diagram must be equal to 0. So I got this one. Fifth one, I ask you to observe one thing here actually guys. Are you getting an answer? Here we are getting this expression like this. Whenever applied load is proportional to x power n, applied load proportional to x power n, then how is the shear force, guys? It is proportional to x power n plus 1. How is the bending moment? M proportional to what? X power n plus 2. You have to remember this one, guys. Next one. I'm just segregating, guys, each one. Next. Coming to the sixth one, guys. I have made a table for this. Please look at here, guys. I have made a table on the fifth one, actually. Variation of shear force, variation of shear force and bending moment based on applied load and applied load. This table you must remember, guys, while drawing the shear force and bending moment diagram. What is that? Please look at here, guys. This is the load, this is the shear force, this is the bending moment. Please tell me, guys, if no load is there, load is no load, then what happens for shear force, guys? Shear force is a constant, V equal to constant. Next, what happens for the bending moment, guys? It is a linear variation. Constant means x power 0, linear means x power 1. Next, if point load is there, what is going to happen? Point load, then there is a vertical step at the application of the point load with magnitude of this, or this height of this vertical step equal to magnitude of the point load, I can say, guys. But bending moment is not defined at that location at a point. Next, coming to UDL. If the load is UDL, what happens exactly, guys? UDL means constant load, x power 0, I can say. Here it is varying linear variationship, x power 1, and it is varying parabolic variation, x square, I can say. Next, if it is a UVL, then it is parabolic variation. This is a cubic parabolic variation, bending moment is. Next, point couple M is there. If the point couple M is there, what is going to happen? No variation for the shear force, no variation. At that point only I am telling you, guys. But here at bending moment, actually there is a vertical step at the point of application of the bending moment. This height of this vertical step equal to what, guys? Magnitude of this couple, I can say. Okay, these are the basic things you have to remember while drawing the shear force and bending moment diagram. And another observation you have to remember is, guys, I already told you. Another observation is, can make it here. Seventh one. Whenever load is positive, whenever load is positive load means upward load, actually, guys. Then how is the shear force value? Shear force, I can say, shear force is increasing shear force or falling shear force, guys. It is always rising shear force. It can be from negative to negative or whatever it may be, guys. Your shear force always rises. When load is upward, shear force always rises. When load is downward, shear force always falls. It can be linear, it can be parabolic also, guys. Depends upon the situation, I can write. Always falls, or other side also, no problem, guys. Getting or not, sir? Similarly, if shear force is positive, what does it mean? Because I got the relationship between load and dV by shear force, so I can able to say that if QV is positive, if load is positive, always your shear force will be rising, I can say. Similarly, I am getting another relationship between shear force and bending moment. So here also I can say, if shear force is positive, then bending moment must be rising. Are you getting it, sir? Next, if shear force is negative, the bending moment must be falling. Must be falling. But the condition here is, guys, all are rising or falling. I have to look from the left hand side only. Left hand side only, guys. Don't look at from the right hand side. Rising and falling, everything is from the left hand side actually. So I got this seventh one. Next one, guys, I ask you to remember few points while drawing the shear force diagram. What are those few points, guys? Please look at here. Can make it so it's easy for me. First point is, guys, important points to remember. Important points to draw. SFD and BMD, guys. SFD and BMD. First point, guys, please tell me what is the first point. Always find out the shear force from the left hand side itself. It should be always find the shear force from left hand side. If you are finding from right hand side, actually, guys, keep minus symbol actually on right hand side. But I've stressed you multiple number of times, but for cantilever beams, always find from the free end, whether it is left or right, always find from the free end. The reason is, guys, tell me, guys, because if you calculate from the fixed end, you need to find out the support reactions first. Your calculation part is increasing, time is consuming actually, guys, automatically. That's why always find from the free end itself. But for bending moment also, guys, you can take from either LHS or RHS, you get the same answer itself, or getting an answer. But I prefer to take it from LHS side itself actually, guys. Hope you understand that, answer. Next. Second point you have to remember is, whenever you are drawing the shear force diagram exactly at the point load, what you have to remember, guys, tell me, exactly at the point load, you have to take it, assume this is a point load X, you have to take it shear force before S, shear force after S, before and after. So first I have to go into before and then after. Before, this is the before point, this is the after point. Join these two. This height of this vertical step must be equal to what, guys? It is the magnitude of this point load, I can say. Hope you understand, guys. Okay. And even for the design, which one you consider, guys? For design ke liye, you consider V equal to maximum of modulus. I am telling you, only magnitude I will consider, guys, before and after. This is what you consider actually, guys. Similarly, we discuss for the bending moment also, guys. For bending moment, we discuss like this. Whenever point couple is there, same logic. Find out the bending moment before the section. Find out the bending moment after the section. Are you getting an answer? So you draw it before and then after. This is the before and after. Join these two. There must be a vertical step. The height of this vertical step equal to what, guys? Magnitude of this bending moment, I can say. Are you getting an answer? S. Now coming to the next one, guys. 8th point. We discussed about point of contrafluxure. Point of contrafluxure, POC. What is mean by point of contrafluxure, guys? This is the point at which the curvature of the beam changes from sagging to hogging. Assume, you can write curvature of the beam changes from sagging to hogging or hogging to sagging, or This is the point at which the bending moment on the beam changes from positive bending moment to negative bending moment. The point between these two I am calling as a point of contraflexure. What is the significance of point of contraflexure, guys? It helps the designers to identify how to reinforce particular beam actually, guys. These things we discussed clearly, but it is not required for time's sake. But how to find POC? How to find POC? Please look at here, guys. This is a beam. You know how to find a moment about A point is there, B point is there, C point is there. You know how to find a moment about point A. You know, assume MA is positive and MB is positive and MC is negative. Then what does it mean actually, guys? There must be point of contraflexure lies between B and C, but where we don't know. That's why I'm assuming that between B and C, I'm taking a section between B and C, and I'm assuming that at a distance of x, it is point of contraflexure lies. So what I'm writing now, we're writing the bending moment equation at x. I'm making it equal to 0. You will get the location of x. We are going to get the point of contraflexure. So this is the basic concept of point of contraflexure, guys. And next one, internal hinge problems, guys. Internal hinge. What I told about the internal hinge, guys. Whenever internal hinge is there, your internal hinge doesn't transfer moments. So I can able to say, guys, at internal hinge, your bending moment equal to how much? 0. Assume if the applied load P is there, how is the free body diagram, guys? Please look at here. The one load downward direction automatically, guys. This will give you, bottom beam will give you upward reaction automatically. Similarly, guys, if we draw the another side of the cantilever beam, so same thing will be opposite. If this is R upward, this is the R downward. But exactly at this location, there will be no bending moment will be there. So if this is P, this R must be equal to P by 2, and this is also P by 2 if it is symmetric, I can say. So here also R equal to how much, guys? P by 2. What is the moment about this point? Assume this is the L aitho, PL by 2 is the answer. Hope you understand, guys. We discussed about the internal hinge actually. Next, third most very important one actually, guys. That is drawing loading diagram. Loading diagram from shear force diagram and bending moment diagram. Okay, this is just ulta of these two things actually, guys. Earlier loading diagram is given, we are drawing SF and BMD, and here they are giving the shear force and bending moment diagrams. Then our task is to draw the loading diagram. Only one thing you should remember, guys. The moment you see any loading diagram, observe and identify is there any sections where there is a sudden change. If the shear force in the shear force diagram, if it is sudden jump is there, sudden change is there, then what is going to happen, guys? There must be point load. There must be point load actually. It leads to point load. Point load should be acting on the beam, because sudden jump in the shear force diagram is it should be point load. Are you getting an answer? Suppose if you're looking from the left hand side, the sudden jump is downward direction. This is jump, guys. Jump is downward direction. Then point load Q will be how much, guys? Downward direction. If jump is sudden change is upward direction, Q will be upward direction actually, guys. I can write. This is about the shear force diagram. Are getting an answer? And second point is, okay, if SFD is linear, if write no load. This I can able to find out from here easily. Next, third one. Look at here, guys. If SFD is, I can say, SFD is, I can say, guys, if it is a linear, load must be UDL. If SFD is parabolic, load must be UVL. This is the one you have to understand. And another important one, guys, you have to remember is, look at here carefully, guys. Fifth one, if, look at here everybody, guys, if shear force is rising, if the given shear force diagram is rising like this, given shear force diagram is rising, then what does it mean actually, guys? Applied load must be positive or negative? It must be positive load. It must be positive load. Are you getting an answer? Okay. If shear force is a positive, means I can say this is a UDL, guys. Rising means linear variation, right? It must be upward UDL. I can write upward UDL. Okay. Now tell me, guys, if shear force is falling, always rising or falling, we are calculating from where, guys? From the left hand side only. Then load is UDL, I can say. Okay. Now tell me, guys, if the shear force is rising in a parabolic manner, I can say. Parabolic manner. It is rising means same manner actually, guys. Rising means same manner, I can say. This is also, look at here everybody, guys. This is also, load is positive, like it is rising means your load must be positive or negative load, guys. Positive load automatically, guys. So this one also having a positive load actually. But you can observe, guys, whenever shear force having a zero slope, then load must be equal to 0. Whenever shear force having a maximum slope, load must be equal to maximum actually, guys. This is the way you have to remember. Are you getting an answer? Okay. And last important one, guys, that is whenever vertical step in the bending moment diagram, then there must be point couple. There must be point couple in the shear force diagram actually, guys. There must be point couple in the loading diagram, guys. Hope you understand, sir. With this, my complete shear force and bending moment diagram is over. With full examples I have explained, guys, and with summary I have given. With this summary you can able to solve any problem. Be confident, guys. Hope you understand, and thank you so much, guys.